soleil, pas de 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 soleil,
Welcome to JFall 2021. Your hosts of today are Bert-Jan Schrijver and Brian Vermeer.
Wow. Good morning, JFall. Really? Good morning,
JFall! Yes, it is great to be back here, and I assume this goes for all of you. It is going to be a bit different because, well, we're actually in front of people now here on a real stage and close to people, and we're going to run into people and talk to people. And it might happen that you run into somebody who you've only seen for the last time in person, maybe, let's say, 2 years ago. So the situation might occur that I'm walking through the venue, I see somebody and think, this guy looks an awful lot like that Brian guy, but I'm not really sure. Is it him? Oh, yes, maybe it's him! Brian! Well, that was a bit awkward. And today might be a bit awkward as well. So be prepared. Not everyone is used to being in big crowds again, but probably will be good. It's great to see you all here, and I'm happy to hear from Brian what we have in stock for today.
So I will try once again. Good morning, JFall. Thank you. And this is the 18th edition of JFall. So I can barely see you, but just a show of hands. Who has been here for all 18 editions? 1, 2, 3.
We have a couple.
4. Applause. Okay. But get back to the next thing. Who is here for the first time? Thank you for coming. And again, applause for you as well. And everybody in between, thank you for coming back to JFall. And if it's your first time, you will be blown away, trust me, because we have a ton of amazing things. But as Bert-Jan already told us, it's a little bit different. Normally we have around 1,500, maybe a little bit more, people within the venue. And we had to move that a little bit down because, well, we all know about government regulations. So about 1,300 people are here. We have an amazing amount of sessions, still basically the same amount as we normally have, over 60 sessions and over 50 speakers. So you can enjoy yourself by getting new information, new content, and more fun. Next to that, we have hands-on labs. These are at the pit, as we call them, on the ground floor. And special shout out to our 40-plus business partners who are here in the venue, and you see all the booths. Make sure, please visit them in between talks and have a conversation, because we can have conversations now. So, Bert-Jan, can you tell us more about the program?
The program. So there'll be plenty of room between sessions to switch rooms, so don't rush. We'll have a couple of session types for you in stock, so regular technical sessions where you can enjoy 15 minutes of technical content. You can choose of 8 between those sessions in every time slot. We have a couple of keynotes, obviously you're watching one at the moment. Hands-on labs is where you can get your own hands dirty by bringing your own laptop, but seats are limited there, so be in time. During lunch we have Ignite sessions, and Ignite sessions are fun type of sessions. They take 5 minutes. We have 20 slides, and the slides auto forward every 15 seconds. So 2 things can happen. Either the speaker nails every transition and has practiced their talk perfectly, or they get stuck and they screw up. But for the audience, it's amazing in both cases, right? And we have bite-sized talks, which are 3 16-minute talks. So don't go in any discussions on bytes and 16, but it's, well, at least better than 15, right? 3 16-minute talks in 1 15-minute time slot, so you get 3 for the price of 1.
Yeah,
logistics.
Let's talk logistics, because again, it's a little bit different than normally. And you see the map over here on the screen. Make sure that we try to implement routes, so we have some sort of crowd control. Make sure that on the ground floor that we want to have the mainstream from room 9, that's this room, all the way up to the back room 1. On the first floor, it's the other way around. We try to prevent as much as possible that you folks collide, and that we make it as comfortable for everybody as possible. One thing that's different as well is that you normally enter the rooms from the top level, and you probably go down. If you exit the room, please do that at the ground floor. So go down so the new people can come in from the top. If you do that, everybody feels comfortable, hopefully, and that is what we're trying to do. Keep in mind that all sessions are recorded. All sessions will be recorded, so if you have to choose which session you want, pick the session you think like, this is the most interesting and I can ask questions. The other ones will be provided to you afterwards on our YouTube channel and on the website. Also be aware that this room, room 9, the main stage, will be live streamed all day. So don't go on stage, pick your nose and that kind of stuff. It will be live streamed. So if you have colleagues, co-workers, or any other people you want to share the main talks with, feel free to hand them over the link to the live stream, and it's also on our website. So some extra COVID measures that we needed to take. First of all, do I hear somebody coughing? No, good. But because if you feel like you have COVID-related symptoms, sneezing, coughing, running nose, or you feel nausea or something else, please move. No, seriously. If you feel sick, please remove yourself from the crowd and go home. We do not want to be a super spreader event because we want to be here next year as well. Make sure that you keep your distance. If I stand too close to Bert-Jan, he probably doesn't like it. And I did shower this morning. So respect each other's personal space. Be aware that during lunch is served on both floors. So if it's too crowded on the first floor, go downstairs. There's enough for everybody. And if I am fully aware, yeah, it's over here on the slide as well, lunch is served to you in separate bags. So don't just grab a bag, take it with you, and go somewhere where you're comfortable. Last but not least, I already saw a few folks wearing a mask. That's okay. If you feel more comfortable wearing a mask, I'm all up for that. And please, I do support it. Make sure that we respect each other's choices in that. And if you feel more comfortable, don't keep your mask off because everybody's doing it. If you feel more comfortable, put it on, whatever you want. So one thing I still wonder, the venue is quite big, but what do I do if I get lost?
If you get lost, you only need to do one thing. You put your hand in your pocket and you take out your phone with the NLJUG Events app. So you can download this in the Android and iOS app stores. In this app, you can find a complete overview of the program, all the speakers. You can compile your own favorite program. You can view a map of the venue when you get lost. There's more information about the conference that you can find there. And most important, you can rate sessions. So a bit more about this later. This app was created for us by the Dutch Tech Service. So I guess I can thank all of you a little for participating in this app.
Yeah, thanks for that. So can I also come back to you folks if it doesn't work? Because we're all responsible for it. Anyway, Bert-Jan already told you, like, please rate the sessions in the app. And that's for a good reason, because we want to see if the program that we compiled is good enough for you, hopefully. Also make sure that if you have something to share on Twitter, that you use the right hashtag, #JFall, so we can find it and repost it on either of the channels that we own. If you have any issues or problems or you want to connect with somebody, feel free to go to the NLJUG Twitter and DM the person, so send a direct message. One of the folks here is always monitoring the direct messages, but also in this venue there are the folks with the black shirts like we wear, and also the folks with the red shirts with the JFall logo on it. If you feel uncomfortable with anything, please go to them, or if you have questions, we can guide you and we can help you out. Make sure that afterwards we will send you all an email. And in that email we ask you for your opinion on this version of JFall. Please fill that in. It's anonymous. I want to know like how you are coping with the situation currently, how things were for you, and if you liked things or didn't like things, and that helps us compiling a new program or changing things for next year. Last but not least, we want you all to feel welcome. So we all do that together, but if you encounter a situation that is not so much in your comfort zone, and you want to talk to somebody about that, please go to one of the folks. It can be anything, from like, I bumped into somebody, or somebody said bad words to me, to like, hey, the toilet paper is not refilled. Like things like that, everything, go to the folks in either the black or the red shirts. Did I mention that you have to rate the sessions? If not, rate the sessions, because it's not only important for us as a program committee, but also we provide that feedback back to the speakers. And speakers want to improve as well for their next occasion here at JFall or any other event. So please do vote. And I think that's it. Or was it?
There's more.
Oh.
So we're already on sort of the second day of JFOL.
What? JFOL is a one-day event. Come on.
Okay, yes, we kind of have the name of being the best one-day conference in the world ever. But we also wanted to have some, well, a little bit more fun. So what do you do if you want to add a day, but you're still a one-day event? You create a pre-conference event, right? So that's what we did. So yesterday we had our pre-conference where we had the Masters of Java, which you'll hear more about in a minute. And we had 3 expert-level workshops. So there was a workshop about modern Java, we had a workshop about domain-driven design, and a workshop about intermediate and advanced Kotlin. These were, I think, fairly well visited and well rated, so might be a good idea for you for next year to join one of them. We're almost there, I think.
Day one was for me just for the free lunch, but hey. Anyway, you heard enough about us, or from us, and I think you want to get some content. You want to get the show going. So I want to introduce to you the first real session. And this session is presented to you by Rabobank. So let's give this next speaker a big hand. Please welcome Michel Schüttel.
Good morning, JFOL. Is my mic already on? Yeah, it is. Awesome. Yes, excited to be here. So, before we begin, just a question that I want to ask you, you can ponder upon. Were you ever in your career in a team that could, quote unquote, just get shit done? Hopefully, yeah. Yeah. And they could burn through stories effortlessly and produce really good software. And don't you wish you could do that all the time? Now, I was fortunate enough in a position to be at Rabobank in a team that, in the end, could do just that, could produce very good software and work really well together. We didn't start out that way. We started out as a quote-unquote normal Scrum team. But to continuous improvements, we tried to try stuff, and some of the things failed miserably, other things worked really well for us. And what I want to do with you today is share some of the things we learned during that time, and in the form of some tips. And maybe you can cherry pick some of those tips and take them home to your team and try them out. So maybe they will work, maybe they're not, but at least you can try. So I'm Michel Schüttel, as Jan already said. I've been a Java developer in the business for like 20 years now. I have some videos on YouTube about Java, cryptography, stuff like that. So if you're into tech, you can really look that up. And this is my Twitter handle. So if you want to follow me, Michel Schüttel, you can do that. And so let's begin. Yeah, it works. So a little bit context. This is the department division of Rabobank, which is called Lending and Insurance. So it's basically the mortgage department. So not really exciting, but still, we make apps for customers to help them with their mortgage application process. It's like 500 people, the division, about, I guess, 20 teams, and our team was called the Avengers. So, nice tech stack. So we use Java 11, 17 soon to be released, soon to be used, I mean, it's already released. Kubernetes, we deploy in Kubernetes. We use Microsoft Azure for our repos. And for our build pipelines, we use Elastic for logging. And Kotlin is now on the way in our division as well. So it's an awesome tech stack. So if you want to learn more about that, go to the Rabobank booth and they can tell you all about it. But today, I'm not going to talk about tech. Well, maybe a little bit, but not too deep. But what I'm going to do is I'm going to take you through one of our sprints and see how we do things, or how we did things, how we failed, and how we started to do things in a different way that allowed us to make software in a better way. So what I'm going to do today is give you 8 tips to improve the performance of your team. Some might work, some might not, but you can cherry pick them and try them if you like. Okay, so the first thing we do in a sprint is get in stories. So this would be a typical story in lending and insurance. So there is basically a law change that basically allows you to buy a house without property tax if you're younger than 35 years. Well, that's fine, it's not really important for what I try to tell you. But the first thing we do is we take it in and we do story refinement. So the way we did it in the beginning was something like this. So we took the property tax story and then we went into refinements. And she said, oh yeah, it's refined, so let's put it on the backlog. Oh yeah, do we have room? Yeah, like 4 weeks from now, yeah. Okay, that's fine. So we put it on the backlog, and then 4 weeks later, we started implementing it. And of course, we completely forgot about half the context, why we made certain decisions, what the context actually meant. So we had to go back to the product owner and ask them if he's actually there, more on that later. And ask them if, what was this again? So we completely forgot. So we said, can we improve this? Well, let's try something else. Let's try refinements, but we do them just in time. So we call them JIT kickoffs, so just-in-time kickoffs. It looks a little bit like a refinement, but it has some properties of refinements, but it's also a little bit different. So here are some properties for you. So the whole team is involved, that's one. So that includes the business. The business is on the table as well. It's 2 hours back, so we time box it. So if it gets too intricate or too complex, we split it out and move it to a different kickoff. Very important, the team creates a global design on the spot based on the business, what the business tells them. The team then tries to identify subtasks, either round robin, for example, so what do you think should be done, what do you think should be done, or just ad hoc, just shout out what you think needs to be done. And the most important part is you go to work immediately after finishing the kickoff. Now, why is this? Because the context is fresh in everyone's minds, and because everyone was involved in the subtasks, everyone knows exactly what needs to be done. So there's no reiteration of, oh, what was this again, and stuff like that. So that really helped us in making a quick start in new stories. And what we try to do is all work on the same story together, or max 2, because if you have a bigger team, it's not really feasible to do that. That presents some other challenges, but I will talk about this later. So an example of this would be something like this. So here's a property text story. We make a design on the spot. In this case, maybe it's a sequence diagram or something like that. And then the team members, so the remember team was called Avengers, so that's why the icons are there. We identify subtasks. So basically, Iron Man says, oh, we need to make a front-end controller. And I think that's Bruce Banner. We have to get calculation service to production, stuff like that. So all team members contribute in making subtasks. So that's the way we do that. So that really helped us in making sure that the context is fresh in everyone's minds. So that was my first tip, do just-in-time kickoffs. Now, when you have done the kickoff, you can start with the sprint. So here's the story again, so we look at it again, but we know already because we just refined it. But yeah, there is a small difference. So if under the max price, what does that mean? We don't know. Probably the product owner went into Jira and typed something in, and we don't really know what it means. So it doesn't matter, it's only a small thing. Let's ask the product owner. Product owner? I have no idea where he is. You know? Does this sound familiar? So our product owner used to be a very busy guy, and he was not always there. So we said, what can we do about this? Because we need this information in order to progress on this story. So yeah, it's basically really simple. So if he's not there, you can make sure that you have either a product owner who knows about the same stuff, so from another team, or a business analyst, if you have something like that in your organization, who also intricately knows about this particular story or particular problem. So that's tip number 2 for you. So have a product owner or backups that are available all the time. That really helped us in making sure that we didn't create any bottlenecks. So once the story is actually pretty clear, we start working on it. So this story is like a law change. So we had like a front-end developer in our team, which was doing front-end. And we had a stuff of like really older guys, I see. That is our Java developers. And yeah, we had something like that. So there's a story, this is only like calculation change, and the front-end developer said, so what should I do? I don't know. I have no idea. The back-end developers, if it was a front-end story only, so making screens, for example, says, this is stupid typed JavaScript stuff, I don't want to have anything with it, you know? So sometimes you have someone who has nothing to do, and you create a bottleneck. So we had this problem, and we tried to solve it. Now, we try to solve it like this. So fire everyone, and then look for full stack developers. Now, what we found out, this guy doesn't actually exist. By the way, this guy doesn't actually exist. But Yeah, because our landscape is way too big, for someone to know everything about everything. So we said, okay, then how should we solve this? Okay, so we started doing this. So for example, for a front-end story, we put a backender in the driver's seat. So that's way out of your comfort zone at first sight. But thankfully, you have a mentor in the form of the front-end developer that will guide you through the process. So you learn a little bit about Angular and TypeScript and stuff like that. And for backend stories, so for example, work on calculations, we turn it around. So we put the front end in the driver's seat. So that was his first connection with Java, and he said, it's really strong, the type language is really stupid. And we put the Java developer as a guide to mentor him. So in that way, you learn something from each other's knowledge, and you basically become T-shaped, which is actually a real thing. So what then happens is your knowledge area grows closer together. And that means that for, well, let's say not really complex tasks, but simple tasks, you can just work on front-end, back-ends all together without the need to wait for someone. So that is my tip number 3 for you. So pair different disciplines to grow T-shaped developers. That really helped us. Yeah, so when you're in the story, you put something to the build pipeline, right? So we have a lot of build pipelines, and they're always green. Nah, just kidding. Actually, never. So we have a build, and it's like 2 minutes, and they do quality control like Sonar and stuff like that, 4 minutes. Yeah, that's great. Deploy to test is Kubernetes, so it's just putting a Docker image in there. And then performance test, 45 minutes, okay. But at least it's green. And then we start the chain test, which is shared by everyone. And it's red. And it's always red, so nobody wants to work on this. And it takes a long time as well. So this is a really problem for us. And we said, okay, can we just skip that step because we don't really need it? Well, it turned out we actually needed it. I don't know if Wouter Oet is in here, but he will tell you chain tests are dead ends. It didn't work for us. So yeah, what do we have to do about this? Okay, so we found out a couple of things. The performance test is too long, so do we really need that? And the chain test is way too flaky, so there are tests in there that sometimes work, sometimes they don't. That's a real problem. So we started trying to solving like this. So if you look at the last part of the build pipeline, we scaled down the performance test to a flight check. So that's basically performance test that runs for only 5 minutes. And if there is anything seriously wrong, you will notice it. But if it's just like, okay, it's a little bit slower, we don't really care at the first build, right? So we run the full performance test nightly, and we run the flight check test just during the day. So you have really quick feedback. And then we started to work on the chain tests. We took out all the tests that were no longer needed and just could be part of a front-end test, so like jest testing, for example, and made sure the tests we kept were really stable. Now, I'm not saying this is never read, but it's now read a lot less often, right? So minimize the performance test, minimize the chain test, and very important, share chain test responsibility. So if you have like 3 or 4 teams, you're working on a product together, 1 week, one team is responsible for keeping this thing green, or at least pointing to another team that has to fix it. So you can all see that you all share the pain of keeping something that might be a little bit flaky. So that's really helped us to stabilize this. So that's tip number 4. So keep your pipelines fast and stable by eliminating unneeded jobs and minimizing flakiness. So on to the code review. So once the story is finished, you want to do code review, right? So how many of you do code reviews to pull requests? Oh, there are a lot of you. Okay. Well, that is not necessarily a bad thing, because a pull request contains all the stuff that you actually had to change. But still, for example, that Captain America, that's me, I will tell you in a little bit, gives a pull request to Iron Man, which is a perfectionist. And he reviews it, and we all know the code details and stuff. So in the end, who knows about this particular piece of change? Only these 2 guys, right? So that presented a problem for us, because the next time someone had to work on this, they had to ask us, so what do you actually do there? And we didn't really know what was going on. So we said, okay, how can we improve this? So we started to do team code reviews. So we still have a pull request. Actually, I must say sometimes we directly push the master for small stuff, so don't hold that against me. We do the code review with the whole team. And that is not about the details anymore, but like the structure, right? So is the packaging right? Is the responsibility right? Stuff like that. And the end result is the whole team knows about it. So the whole team intricately knows that particular piece of code that was needed for that change. And we didn't have to explain it anymore for the next person who went to work on this piece of stuff, on this piece. So that's tip number 5. Do team code reviews for every story, and I mean every story that is reasonably sizable, right? If it's a really small change, you don't have to do that. But anything that is of a reasonable size, this is a really good tip. So, when we were finished with the code review, the product owner came up to us and said, why does this take you 3 weeks to finish? It's only a small law change, right? They said, yeah, well, we need to restructure this a little bit, and this API was not right. And so he was totally baffled why this took so long. But of course, this is technical debt, right? So you notice this when something that should be really easy takes you a lot of time. So this is what is called a quagmire. Now, probably, I had to look up quagmire, and the only thing I found was this guy. I didn't really know Family Guy, so I was pretty surprised at what a horrible guy this is. But what I actually meant was this. It's quicksand. That's the English word for, that's quagmire in English. So it does mean you walk into the quagmire and you start working on stories, and because you have technical debt, you go slower and slower all the time. You don't come to a virtual standstill, but you go slower and slower, which is even more dangerous because first you don't notice it. That's really a problem. And of course, yeah, we had some stuff like this. So we looked at Sonar, and there was like, let's see, like 152 code smells and 8% coverage. A little bit exaggerated, but nobody wanted to work on this, of course, because it will take me weeks. So this is what is called broken window syndrome. So the worse it will get, actually, nobody wants to work on it anymore because it is a huge amount of work. So we said to each other, okay, what do we have to do to solve this? Okay, we started trying this technical debt backlog. So some Jira stuff, refactor internal structure, cleanup, upgrade Guava or dependency, stuff like that. But the problem here was we didn't get priority ever from the product owner to do this. And we totally forgot what held us back, what particular piece of technical debt held us back to finish the story. So he said, okay, this is not really going to work, so what do we have to do? Well, it's really easy. Have no technical debt. Yeah, but how do you do that? Okay, he said, okay, let's start with Sonar first. So, yeah, we have a lot of stuff to process, but we want to go to this, basically. You have zero technical debt at all times, with some exceptions. So, basically, if you open Sonar, you want to see something like this, right? So, what we try to do during a story is making sure that every build doesn't produce new stuff. So, that's basically Boy Scouting principle, and maybe work away some of the stuff that was already there. That's one, but Sonar can only do so much. So you also have something like structuring and code smells. And remember we did code reviews? So we tried to identify code smells during the team code review. So what happens then is we're already done with this story, so we implemented everything, but then we put some extra subtasks on the backlog that will get rid of this technical debt we encountered. So it's not much, it's just a little bit, but that will help you clean up stuff eventually so that you don't have to deal with any technical debt from the start of your story as time progresses. So that really helped us. Now, this guy. So we were finished and we got a new Scrum coach. And he was really enthusiastic. And he said, oh, so it's awesome and you should do Scrum and you do planning poker? I said, well, no. Because we have like stories that are like equal size anyway. And stuff like that. Yeah, but we are more predictable. Yeah, but we finish like 4 stories every sprint. Yeah, but then you can measure the velocity against other teams. No, dude. Dude, you can't. Well, bottom line here is, this is great, but if you have something that works really well, keep an open mind, that's fine. But also keep being critical and drop rituals that give you no added value ASAP. Yeah? What does that mean? Oh, yeah, dankjewel. That gives you no added value ASAP. So be open-minded, be also critical, drop stuff that you don't need, okay? That's tip number 7 for you. And last thing I want to talk to you about is team composition and dynamics. So this is the hardest part to solve because you have to get lucky which person you get in your team. But I can at least explain to you a little bit how does this team dynamic work. So first thing is, these are 4 junior developers. What happens if you put them in a Scrum team? I will tell you, nothing happens. Because they have no clue what to do, right? And this is understandable, right? Because, yeah, they don't have the experience, stuff like that. So what happens if you put seniors in a team, only 4 seniors? It will turn like this, right? It's like a bar fight. So we had something, nobody could agree on anything. And that's really, that doesn't work as well. So the bottom line I want to give you is what we eventually grew to was that we had a good mix of people with a little more experience, people with less experience, and that works really well for us. So when you compose a team, make sure that you take into account this mix. Now the other thing is team personality. So this is the hardest part to solve, but at least I can tell you something, the different types that you can find in teams. So these are a few. So I'll walk through them pretty quickly. So first you have the coordinator. That's the guy who is always right, oh, now we should do this, and now we should do that. It's not a leader, but someone who keeps the, what do you call it, the grander design of things, right? So really useful if you want to have good planning. And then you have the plans. That's the creative guy. So that's Tony Stark in this case, who will just shout, let's do GraphQL. Okay, sure, if you think that's a good idea. Not always a good idea, but it's really good to have a creative force in your team. And then the implementer, that's the guy who's just a workhorse, gets shit done. That's me, by the way, in this team, partially. Maybe the team is here, maybe they don't agree. Well, I'll talk to you later. Then you have the researcher, and that he works really well together with the plans. So he will take an idea and just go ballistics on it, figure out what to do. Then there's the perfectionist. I really hate that guy. It's all in the details, boys. He goes on endlessly about small stuff, and but of course, that's useful as well, right? And then the investigator, he or she looks outside the team for inspiration and information. And last but not least, and this guy you cannot do without, is your team worker. You always need him, because he will make sure that the team will be working as a team together instead of a group of individuals. Now, of course, this gives clashes. So I had something like this. So I'm the guy who always said, let's put it in production, it's good enough for now. So I don't care. And this guy comes in and says, no, that button is 2 pixels too far left. I don't care. But of course he has a point, and I have a point as well. So this basically, this interaction or something, this little bit of conflict really helps you to fine-tune your software or find a balance between fine-tuning and say, okay, it's good enough for now, right? So that is the last tip I wanted to give you. Have a good mix of personality and experience in your team. So that's all I wanted to tell you. So this is the summary. I won't go through it again because you can take a picture, but there will be a QR code after this. So thank you very much. The QR code will lead you to my YouTube channel where you get an automatic premium subscription of $20 a month. Now, just kidding, it points to the URL where the presentation is, okay? So yeah, that's all I want to give you. I hope you can take some of these tips back to your teams and maybe try them out. And last but not least, I have to say, you know, enjoy the day very much because it's first offline conference in ages. So enjoy JFall and thank you very much.
I was already scanning that QR code with my Corona app. Didn't work. I love the just-in-time principle. I always apply that to my own slides and talks. So I finished my demos like 3 this morning. Hopefully they work later. Anyway, thank you, Michel. Great talk. Some things I need to take care of as well in my team. So thank you for that. But let's continue. We will. The Anal Jug is not only about JFall. We do so much more. And one of the things I want to present to you, well, basically I will bring up somebody on stage, is the Anal Jug Innovation Awards, and specifically the Anal Jug Innovation Awards 2021. There's somebody who knows far more than me about that, so let's bring up on stage Bas Knopper.
Thanks, Brian. Is my mic on? Awesome. Can you read this logo here? Great, because otherwise you would already spoil the surprise. So you can imagine how happy I am to be here again. I just realized this morning that this actually is my 10th anniversary at JFall. I've been here as a developer, I've been here as a speaker, I've been here attending a booth, but this is the first year that I've been wearing this shirt. And let me tell you, the amount of energy and passion and work that goes into creating this awesome event today is just phenomenal. So can I get a big hand for all of the organization and everybody here? Truly amazing. Speaking of putting a lot of passion and energy into something to make it exceptional, let me talk about the Innovation Award. So this is something that we started with a couple of years ago, because as you know, this is a day that's all about technology, about everything in and around the JVM domain. And we're IT developers, so we talk a lot about tech. And one of the things that we wanted to stand out here is the impact that everybody makes with that tech, which is why we've created the Innovation Award, to honor the projects that were truly innovative this year. So we had a lot of nominations, and I just wanted to thank the jury with which we went through all the nominees, did a lot of work, had a huge Excel with ratings and everything and discussions. And I just wanted to thank Johan Jansen, Arjen Wiersma, and Ingrid Romein, who did the were in the committee with me. So big hand for them as well, please. Awesome. And now, obviously, on to the winner. Well, first off, I wanted to start with the numbers, the third place and the second place. So in third place was Stream Machine. Big hand for Stream Machine. Stream Machine is a streaming platform that has data protection at its base and by design. So Arjen had a great quote here saying, adding GDPR compliance to the base of its stream processing is a very novel idea, which is one of the reasons it got so highly graded, and came in third place. So that's amazing. Second place, the runner-up, is 42 for building a ANWB, the new software for the emergency center. So big hand for both 42 and ANWB. Ingrid said about this project, an innovative concept to integrate different tools and applications on such a scale and set it up as a SaaS, which is one of the reasons that it was so innovative. Third and second place. But we're all here because of the Innovation Award winner, obviously. And the Innovation Award winner of 2021 is, well, actually, chances are that you received groceries this week from this company, because it is Picnic. Give a big hand for Picnic Technologies with their automated warehouse project. Matthijs and Sjoerd, can you come up to the stage, please? You can come up over there. A really big hand, please. There you go. Congratulations. I think there's a mic and some flowers as well coming over here. I can talk a lot about Picnic because I've read the very extensive nomination. Thanks, Sander, and thanks you. But you obviously can say a lot more about the awesome stuff that you're doing at Picnic than I can. So first off, how does it feel to get the prestigious Innovation Award this year?
Yeah, I think it's really great, and there was talk about high-performance teams, and I think our team is definitely falling into that category. I'm every day amazed by how much stuff we did in the past 2 years that we were building on this, and I think this award is very well deserved, and it's always really nice that somebody else also thinks that we are working on a really cool project.
Yeah, getting recognized for such an awesome project is always awesome, right? And Sjoerd, can you talk a bit more about what the project entails, what you've done, and why it's so innovative?
Yeah, sure. So you already said, like, a lot of you maybe are already getting your groceries from Picnic, and one of our biggest challenges is kind of scaling up and like building this huge company with so many people, keeping everyone happy, keeping everyone healthy as well. You can only do that with efficient processes and trying to kind of scale up your business in a way that actually works for what you're trying to do here. And we're trying to deliver so many orders. One of the biggest challenges we have is all this order picking, you know, getting a lot of stuff in, getting it into the right totes, and then shipping it out in time. The only way to achieve that is automation. And we thought, you know, we're a web-based company. It's kind of, you know, it's new for us. We don't usually do stuff with hardware, but let's give it a shot. So we applied our web stack basically to kind of just drive this automation now. Pulled a lot more in-house, I think, than a lot of companies would, and I think it's paying off. The team has been working their asses off for 2 years now, so it's really amazing to get some recognition that what we're doing is in fact special. And in the end, it all comes back to you, because you know, we're going to be able to deliver groceries for even more people and keep everyone you know, from doing a lot more heavy work in the FC. So we're making everyone's lives better, I think.
Yeah. Great, yeah, because Johan said about this controlling shuttles, lifts, and other robots in a complex warehouse shows once again Java can be used anywhere. Because you've used your cloud-based software and actually went down through the control of the warehouse itself, which is a warehouse, I believe, of 25,000 square meters, which is, whoa, it's in Utrecht, right?
Yeah.
And you service 150,000 homes from that warehouse, automating the process from like the suppliers to the well-known electric picnic vehicles, right?
Indeed, yeah, everyone loves those.
Yeah.
We still love them as well. They're amazing. Yeah, 19 kilometers of conveyor in there, so big thing.
Amazing. Congratulations with winning this award. Have fun next year with building up on top of this software, and yeah, give them a big hand, everybody. Woo. And over to Bert-Jan. Moet jij het hebben?
Yes. It's great to get an applause for doing absolutely nothing, which is what I'm best at. I already talked about the Master of Java a bit during the opening. So it's my very pleasure to invite onto the stage fellow Energyk board member Noortje van Berlo. Please give her a warm welcome.
Hello everybody, hello JFall. I'm not alone.
No, I'm here too. Job van der Meijden, I'm from First Aid, and together with the Energyk, we organize the Masters of Java, which is kind of the Dutch championship of Java programming.
Yeah.
And yesterday we were there.
Yeah, so we want to take you with us in the journey we've made yesterday. It was a really nice journey, I think. What did you think of it?
It was very tense. There were a lot of teams, and right up till the last minute, the decision hadn't been made yet who had won.
Yeah, wow. For me, it was the first time, but really exciting. So yeah, I enjoyed it a lot. But first of all, I want to tell you about a little frustration I have right now. Because Michel over there just made a reference to Family Guy. And now I have a really annoying song in my head. I don't know if you know it, but it goes like this. But the bird, the bird is the word. So I hope now some people more have it in their minds as well. I'm not the only one with frustration. So thanks, Michel.
I think at the end of today, when you walk around these halls, you will still hear someone whistling or...
Sorry for that, guys. Okay,
Yes.
Let's go. We have a video first, so we will give you an impression of the experience we had yesterday. I press start now.
Het was een topdag. Het was een hele mooie competitie. De spanning was tot aan het einde. De gezelligheid hier, de gemoedelijkheid onder de deelnemers. Alles heeft het gedaan tot het eind, wat wij dan weer heel fijn vinden. Dus wij zijn uiterst tevreden over vandaag. Ja, zeker. Yes. For those of you who've never been, there are 5 Java questions that are posed to the candidates, and each of them will take half an hour. Or less if you're quick, and you have to submit working code to solve the problem that is posed in the question. And if you do that fast, you get more points than if you do that slower. That's pretty much the concept. So if you think that's nice, you're welcome next year. We're doing this every year, so
yeah, join us next year.
Please join us.
Okay, and then we will announce the top 3.
Yes.
So at 3rd place, we have Team Tribute with Wouter van der A and Casper van der Duin from Planon. Give it up for them.
And 2nd place was Camel Case, and he was alone, which is even more impressive. Jasper van Merle.
Woohoo! Also nice to say, he's a student actually, I heard it. So yeah, really proud of you. And so when you are a student, you can see it's possible to maybe win even. So join us next year, even when you're a student.
And 1st place.
First
which
place
is
goes to...
impressive, because there was not one single question where they finished first, but they were steady along all questions, either 2nd or 3rd, which made them the winner. And the winner is?
And the winner is...
OV Software. Please come on to the stage.
Thomas Wittaar and Maarten van der Zwaard. Give it up.
They are here.
They are coming.
So congratulations. Any words of thanks or anything you want to say?
Well, you kind of already said it. We weren't the quickest in any of the assignments. We were like 2nd or 3rd quickest, pretty quick. But yeah, slow and steady wins the race. So just carefully read the assignments, think about it with your partner, write good code, good enough code. Doesn't have to be production-ready code, just get it done. So yeah, it's fun to do.
And one more thing, those of you who've been here before may have noticed, this isn't the first time they've won. This isn't even the 2nd time that they've won. This is the 3rd time in a row, I believe. How do you think about that?
Never change a winning team.
Well done, thank you.
Give it up. And then the moment we've been all waiting for, that's the reason why you are participating every year. It's a really, really nice cup. Really nice. Do you know already a place where you're going to put the cup?
Next to the other.
Next to the other. Wow, it's really strange. I didn't expect this answer.
At what point is there no more room there?
It's a pretty wide desk, but 10 more.
Oh, 10 more, okay.
10 more, okay.
See you next year then again?
Sure.
Okay, nice. Okay, give it up again. And then we will give the word back to Bert-Jan or Brian? Yes, we can.
And we hope to see you next year, of course, as participants.
All right, thank you. One thing that always amazes me by the Master of Java is that I am a Stack Overflow programmer. You don't have access to Stack Overflow. So it's pretty hard, and I'm a bit of a coward. That's why I never ever did participate. But maybe next year I need to step up my game. Anyway, this is it for us for now, for the main hall thing, keynote thingy, because you're probably all out of coffee, right? Who wants a cup of coffee or something like that? I do. All right. So from this spot on, the whole NL Jug and JFL team wants to thank you for being here. Enjoy today. Go to as much sessions as possible. Visit the booths. Make sure that you kind of go in the right direction, thankfully. And last but not least, I didn't mention this before, but please rate the sessions in the app. Thank you so much. Enjoy JFL. See you later.
checking off on their phone, checking their emails. So consider this a warning, by the way, also for people on Livestream. So we're here today because we want to learn a lot about Java. My name is Sander Mak. I'm part of the Picnic Tech Leadership Team. And what a morning it has been for Picnic, right? With the award and everything. However, I am not going to talk about the automated warehouse. There will be a talk in the afternoon by Sjoerd and Matthijs, who were on stage. So if you want to know more details about this project and about the cool stuff that is happening there, highly recommend going there. However, this talk will be about a tool that has enabled this team to actually do the work that they did. So also very interesting, I would say. And I'm actually going to let you in on a little dirty secret. Because we, as conference speakers, we really like to talk about new, cool technologies, new frameworks, new languages, new everything, right? And that's cool, and people seem to like that kind of talk. But in the end, what do you really take away? What can you actually use in your day-to-day? And I think there's place for these talks, but there's also place for more practical talks. And this is actually going to be a very practical talk. Because in this talk, I'm going to teach you a superpower. And this is a superpower that you can take away today and take to your team tomorrow already. This is something that you can apply to any Java project that you're working on. And the superpower that I'm talking about is to be able to refactor at scale. So I hope I won't have to convince you of the advantages and the benefits of refactoring, right? So I'm not going to do that. Let's just say that a lot of code bases would really benefit from having some refactoring time to time. And I'm not talking here about everything that we learn to do in IntelliJ. So refactoring at scale doesn't mean learning all the shortcuts and everyone doing this frantically in their IDEs. No, when I talk about refactoring at scale, I really mean something that you can work into your CI pipeline, that you can work into your automated processes that can help you scale the process of refactoring your code and making your code better. And the tool to do this, and the tool that we use at Picnic, is called ErrorProne. This is an open source project created by Google. They also use this heavily internally, and they published this quite a few years ago already. And I think it's a really, really cool tool. It is also not that well known in the Java community, and that's a pity, because I think it can bring a lot of value to a lot of projects. So that's also why I'm here, sharing how we at Picnic use ErrorProne to improve our code base, to improve our way of working. Now, before we dive into the details of ErrorProne, I would like to sketch a little bit of a picture of what it is that we try to achieve at Picnic and why we actually care about having such a tool at our disposal. So, this is what I call the online groceries challenge, right? So what we want to do is we want to make grocery shopping, online grocery shopping, fun, easy, and affordable for everyone. So the idea basically is pretty simple, right? We have an app, people can order there, then you can select a slot, and the slot is pretty precise, so people are happy that they don't have to sit at home for the whole day. We make sure that all the groceries are picked and delivered at the right time to your doorstep, no delivery fee, and we have to make sure, as a tech team, that this actually works. And that's a pretty big challenge, because being able to fulfill this many orders, being able to actually ensure that our electric vehicles are at the right place at the right time, that takes a lot of software. And people are really happy when they open what we call our delivery radar, where you can see the electric vehicle coming to you, delivering your groceries, so that you know exactly where it is. This takes a lot of tech. I think you can see that. So yes, we built the obvious backend, and we have the obvious app, of course, that we built. But there's so much more behind the scenes. We need to make sure that in our warehouses, every order picker is working efficiently. We need to send our drivers out into the world and navigate them to where they need to be. Make sure that they deliver the right groceries at the right place. Lots of apps, lots of systems that are going on behind the scenes. So to give you a bit of an overview of the numbers that are currently at Picnic, the company is 6 years old, and it has grown from a handful of engineers who built the prototype and made sure that we could do our first delivery, to a team of 180 engineers at the moment, and doing many, many, many more deliveries weekly. As we already heard in the automated warehouse project this morning, only from there we will already do 150,000 deliveries every week. So these are really, really huge numbers. And also looking at the code bases that we have, Of course, we started out with some off-the-shelf software, but we are starting to develop more and more systems of our own as we scale, because a lot of the off-the-shelf solutions just don't fit and don't work at our scale anymore. So these 4 million lines of code, I mean, these have been built up over the past 6 years. A team of 180 engineers. This takes a lot of automation to actually guide this sort of way of working into something that is a quality code base and that is workable for a longer time. Now, some tools that are pretty well known do help in improving your code base, right? For example, SonarQube, already mentioned this morning. It's a tool that we use as well, and it's pretty decent at what it does. But at the same time, I do very much recognize the remark that Michelle had about broken windows, as you see. Because, I mean, you can see you have like 10 days, 20 days, 30 days of technical debt. What does it actually mean, right? Are people actually looking at these results? And if they do, is it really embedded in your development cycle? So you end up in a situation where you can see some trends, but you're not really in control in making your code base really, really better. Now, it is good to know your code, it's good to see trends, so I'm not bashing on SonarQube in any sense, but it's just not enough at this scale to ensure that you are doing the right thing at scale. So we want more automated sanity in our process. Now, there are other tools which are also fairly well known, I would say, things like Spotbugs and Checkstyle, all kinds of Maven plugins and tools that you can use to actually prevent things from getting worse. And these really do tie into your development cycle, into your build tool, so that is also giving you more feedback. But what if we could take it a step further, and if it's not just a tool yelling at you that you're doing it wrong, but a tool that actually fixes things for you and that helps you encode patterns and best practices and helps you do refactoring at scale. Now, Error-Prone is such a tool, and Refaster, another project that is very closely related, we'll also discuss, is also very important in this whole setup. So what is Error-Prone? Basically, Error-Prone itself is a Java compiler plugin. Can a Java compiler have plugins? Yeah, actually it does. It does have the capability of loading plugins. Not that often used, but for this use case, it fits pretty well. Now, Error-Prone itself, as a plugin, can analyze your code and can look at patterns and can actually already spot a lot of predefined bug patterns that are inside of Error-Prone itself. So that capability is a little bit like Spotbugs and PMD and things like that that already offer this kind of capability. By the way, there's over 500 of these predefined checks. They're all well vetted and well maintained. There's a good description of everything that it checks and does for you. What is also important is that the Error-Prone compiler plugin supports both Java 8, 11, and 17, and the last one is also pretty important for us because 2 weeks ago we migrated most of our services to Java 17, which is a completely different talk for a different time, but also very cool, I would say. But anyway, this tool does support it, and that was key for us to be able to migrate and to use Error-Prone. And if you go to the Error-Prone side, there's a very cool testimonial by Doug Lee, the guy who created the Java util concurrent libraries, where he says, well, it's a bit embarrassing. I guess I'm back to liking Error-Prone again because it found a bug in one of the Java util concurrent libraries. Though it annoys me sometimes. Well, I think that's a sentiment that we can all recognize, right? If we don't like to be pointed out errors, but in the end, it's all for the better. Now, I can talk a lot about Error-Prone, but how about we just look at some code, right? So I'm going to switch into my IDE, where we have a very, very simple Java application called My Buggy App. There's a bit of code here. We print something, we check some arguments, then there's an exception, and then we print something again. There's even some empty method, which we'll look at later. But who sees the problem here? Will this compile, by the way? Yeah, exactly. There's new illegal argument exception, but we're not throwing it. Now, if we just compile this code, right, so Maven clean verify, there we go, then we will see it compiles fine, right? So it's syntactically valid, but it's most likely not what we meant and what we want. So what we can do with Error-Prone is we can go into our pom.xml. We can go to the compiler configuration, because remember, Error-Prone is a compiler plugin. And we can insert the configuration for Error-Prone, where we introduce the annotation processor path here. and we point it to com Google error prone and error prone core as an artifact. And just by doing this, we can run Maven, well, let's just say Maven verify again. There we go. Let's clean it as well. And what we see happening now is that we are actually getting a compiler error. And this was not there before we added error prone to the annotation processor path. And this compilation failure says, hey, you created an exception, but it's not thrown. And this is most likely wrong. And the cool thing here is there's a link to the bug pattern, so you can read more about it if you want to, if you don't really understand what is going on. You can click on it because it's just a compiler error, so IntelliJ knows where to point you. But what is also really, really interesting is that it doesn't just tell you about the type of error, it also has a real suggestion here, which is completely context aware. So it says, did you actually mean throw new legal argument exception? Why? Yeah, indeed, that is what we meant here. So this sort of supercharges the Java compiler with a lot of additional checks that you already get out of the box with error prone. Now, the nice thing about this being a compiler plugin is that it's really build tool agnostic, right? So you can configure a compiler plugin in any build tool. So it's not really a Maven plugin or a Gradle plugin or anything like that. It's really core to the Java compiler. But what we can do as a next step with error prone is take it up a notch, because yeah, we have a great suggestion here, but the next thought that you might have is, wow, if this suggestion is already there, can it also be applied for us? And the interesting thing is that the answer there is yes. Because if we go to this configuration here, we see that we actually configure error prone as a plugin to the compiler. We also have to set the compile policy to simple, because the error prone compiler plugin does have some assumptions about the way the JDK compiles, which are only satisfied if you set this policy. There's a JDK bug open to make this actually make it work with the defaults as well, but that's unfortunately not resolved yet. But anyway, we can configure error prone itself as well. So in this case, we can add some additional arguments to the error prone configuration, where we say we don't want to do checking, but we want to do code patching based on these checks. And now this EP patch checks, there we have to list which checks we actually want to apply. So in this case, it's the dead exception one. You can see that is also the identifier that is used here. And we're going to say the patch location to apply the patch is actually in place. So this is a special token. You can also specify another location, and then it will just emit a diff, a patch file that you can apply yourself with some tooling later. But for this demo, let's just do in-place patching. And if we now say Maven clean verify, you see there's no error, right? So, because we don't do checking, but we're doing patching. And that has actually fixed our code. So it says now, throw new legal argument exception. And I think that's really cool, right? So we have a tool that knows about some patterns, and it doesn't just warn us about it, it doesn't just give an error, but it's also capable of actually fixing it for us. And I think that is really, really powerful. So let's get back to what we were talking about in terms of error prone. So what do we have here? We don't have just a tool that is capable of telling us that we're wrong, but it's actually sort of like autocorrect, but for code. And I think a lot more useful than a lot of the autocorrect scenarios that we're familiar with. The nice thing is, this seems a fairly trivial one, right, the dead exception. But it is not just core Java that is addressed by error prone. So there are a lot of patterns that are indeed about core Java APIs and core Java usage. But there's also a lot of predefined patterns and checks already that work, for example, very well with Android code bases, or with code bases that use the JUnit library, where there's also, of course, some best practices and some anti-patterns, or things like the Joda library. So all of these are already bundled into error prone itself. Now, if you are using error prone, then you might, if you run it on your code base, run into some errors or warnings that you might disagree with, right? That happens. We all have sort of differing opinions, I feel very confident that the set is pretty well defined and pretty complete. But if you want to, you can also, in the configuration of error-prone, override what it actually does. So you can tone down a compiler error if a check results by default in an error. You can tone it down, for example, to a warning by saying -xep, and then colon the name of the check, and then providing the level and the severity that you want to assign to it. It might also be that you just want to plainly skip some of the checks. For example, in our code bases, we build backend services, so we just disable the Android checks. These are not really relevant to us, so why waste CPU cycles actually doing that check? Now, there's also cases where, in general, you might want to have the check and want to apply it to your whole code base, but there are some tiny exceptions in your code base where you want to allow this sort of anti-pattern or this bug pattern to occur. Or you want to do this because you intend to clean it up later. In that case, you can use the standard suppress warnings annotation that Java has, that you can also use to suppress Java's own compiler errors. You can use the same mechanism to also suppress these error-prone checks and these bug patterns that are in there. So that's all quite flexible and really tunable to your own taste, let's say. But again, I think already by default, the stock configuration that error-prone comes with should be a very good guideline for most code bases. And it's a really well curated set of bug patterns and checks that are in there. I want to highlight one other check that error-prone does that I feel is very valuable, that we also use within Picnic. And that is the var check rule that is in there. Now, you all might have this annoying coworker probably in your teams who says, we should be fully immutable, right? And I think there's a lot of value in there. But as soon as you start pushing it to the max and say, okay, well, then everything needs to be final, and then we need to put final on everything, then it starts to get annoying, right? Because it's also visual noise in your code, and yes, you sort of know the value of it, but do we really want to make our code uglier just to get this? And it doesn't have to be this way. With the var checker and the var check that is in error-prone, you can actually invert the default. So if you enable this check, then by default, everything is assumed to be final in your Java code. So the local variables, the parameters, anything where Java has the assumption that it's non-final, now the assumption is flipped around and you say, okay, it's final. However, if you still want to have a mutable variable, you can by using this add var annotation, which comes from error-prone. And there you may reassign and may use it as a mutable variable. And I think it's a really cool thing because in the end, yes, we do want to encourage immutability in our code, and we do want to encourage people to think in that way, but we don't want the visual noise of final everywhere. So by flipping this around and by having error-prone check this for us, that's a really powerful tool to have a cleaner and also more, let's say, reliable code base where you can more easily reason about immutability inside of your code. So that's an example of something that's not really a bug pattern or something, really trying to find problems in your code, but where you can actually flip some of the Java defaults around in the compiler and then have error-prone enforce immutability for you for these local variables. So we've seen that with stock error-prone, you get a lot. You can configure it pretty well. But the nice thing is there's also third-party contributions, third-party checks that you can work into error-prone. There's, for example, the Mockito team has also released error-prone checks that you can add if you are using Mockito for mocking in your code. And there's a contribution also for SLF4J. So if you're using the SLF4J API, there's some do's and don'ts in there that can be enforced much more easily if you do this. But that sort of raises the question, right? Because wait a second, if people can actually publish this to Maven Central, then it does mean that you can create your own checks, right? And your own way of working with error-prone. And that is indeed actually the case. And that's what I want to show in a second demonstration. So what we're going to look at here is I'm going to introduce another Maven project, which is called My Bug Checker plugin. And here we're going to build a very simple bug checker implementation that error-prone then uses to apply it to your code base and to automate this check and maybe even automate this rewriting that we were talking about. So this is a different Maven module that we're going to create. And the core of it is a class where we're going to extend the bug checker type. That is an error-prone type. Now, once we have that, and we have compiled the jar file for my bug checker plugin, we can add it to the annotation processor path of our buggy app application and actually start using that bug checker. And error-prone uses a mechanism called service loading to actually find implementations of these bug checker types in jars that are added to the annotation processor path. And we'll see that we can do this pretty easily using another Google library without having to dive into all the details of this service loader mechanism, where usually you would have to create in the meta-inf directory a certain named file pointing to the implementation class. We don't have to do all that because there's better solutions for that as well. So let's head to the IDE again. And in this case, I'm in a second project called my bug checker plugin. We can see here on the POM configuration that we are just invoking the Maven compiler plugin. We're not running error-prone here because we don't want to go full inception. But we are just configuring another annotation processor, which is called Google Autoservice, which allows us to just put an annotation on a class, and it will be service loadable by other implementations like error-prone. And furthermore, there's a few dependencies because, well, we're going to write against error-prone APIs here, so these are also listed here in the POM. So let's look at the code. I already have a little bit of a stub here where we say what we want to do is create a bug check rule that checks for empty methods because, well, why would you want an empty method, right? We don't really want that. And we have one right here in our buggy app. So that's the goal. That's the one that we want to flag. So we extend a bug checker, which is an error-prone type, and we implement bug checker.method tree matcher. Because what a bug checker effectively does, it allows you to walk over the AST, the abstract syntax tree of your Java code, the code that you're checking. And it uses a kind of a visitor pattern, or actually it uses the visitor pattern. And here we are interested in actually only visiting method declarations. So we can do that by overriding the match method implementation, and then we get a method tree, which is a sort of the subset of the AST that represents the method that you're currently inspecting. But before we go there, we need to ensure that we actually say that this is an auto service for the service loading, as I said. So we need to define bugchecker.class as the actual type under which it will be loaded. And there's an annotation called bug pattern that contains metadata of the pattern that we're creating. So we need to give it a name. Let's call it empty method. There we go. We need to give it a summary. Yeah, so we don't like do nothings. There we go. And we also need to assign it as a severity. And in this case, we're just going to say, let's make it an error, right? Because why not? And now, there's of course the meat. How are we going to implement this check? So of course, I picked an example which is pretty straightforward to implement. So in this case, we will look at the method tree. We say, give us the body of the method, give us the statements of the method, and let's see if it is empty. And if it is empty, we are going to return a description of a match that we've made here. And we actually matched this method tree that we just inspected. And we're going to give it a suggested fix. And the suggested fix here is to delete this method tree. So this is basically setting up our check so that it can find the right method, and it can also say as a suggestion that you probably mean to delete this. And it could mean that you delete multiple lines in the source code, right? Because the method is opened and then curly brace and then enter, curly brace close. Or it could be a one line. So this is not about source line codes, but this is about nodes in the abstract syntax tree that we want to flag. And the compiler infrastructure itself will turn this into source lines and will make it work as if by magic. Now, here we are going to return a description no match because, well, if the method wasn't empty, then apparently our check doesn't match. And I mean, we can make this much more complex, right? We can check maybe if it's a method that's annotated with override, because we have to override it and we just leave it empty, then we might make an exception. So you can make lots and lots of tweaks to the rule, but let's keep it simple for now, and let's do it like this. Now, what I'm going to do is I'm going to Maven clean install this one, so we want to put it into our local repository as a jar file. There we go. And what I'm also going to do is I'm going to copy the coordinates of this jar, or this Maven artifact now. And I'm going to go back to my buggy app, and we want to apply the rule here. So let's go to the POM file, and in the annotation processor path, we're going to add this new jar file that we just created. Let's paste it in. Now we also need to enable it, right? So we're going to add empty method, which is the bug check that we just created. And now what we would expect is, well, looking at the code here, is that the method that is here, that it will be removed, right? Because we had the suggested fix. We are going to match this method because it's an empty one. So let's see Maven clean verify what is going to happen here. And poof, it's reloaded, it's gone. Right, so we created, wow, yeah, it's magic, right? Woo. So what we did is we created a fairly easy bug pattern that matches in your AppSec syntax tree and then has a suggested fix. Now, just to make the picture complete, let's undo this, and let's try to run the same check, but not as a patch, but just as an error-prone check, which is the default mode. So we're going to remove this patching code, and we're going to actually have a look at what happens if we now run the code with this empty method in place. You will see that we are getting a compiler error. And this is one that we defined ourselves, right? That's pretty cool, I think. So we see that we don't like do nothings, right? So let's go to the error here. And if we would then remove this line, then indeed we would get rid of the warning. So that is, I think, a pretty cool way of dealing with technical debt and with your own patterns and with your own best practices in Java code. So what kind of bug checks do we have at Picnic? Because we have quite a few custom bug checks as well. There's a few categories. So on the one hand, we have checks that are helping our developers write correct code and use APIs correctly. So for example, we want our code to not just fall back on the default time zones and on using local date time now, for example. Thank you. So we have bug checks that actually flag these kind of usages and that force you to think about what is the actual time zone that I'm going to use here towards my customer, towards my system. And if I want to have the current time, then I need to somehow obtain and via Spring inject a clock and get the time from that so that we can also easily mock it and replace it in testing, for example. So this is one where it's fairly easy for us to find good patterns. And of course, these are all patterns that have arisen through many discussions, usually on PRs, etc., that we can now encode into such a bug check. The other category is where we want to avoid some runtime errors, right? Because even though you invoke something, it doesn't mean it's going to, if it compiles, it doesn't mean it's going to work at runtime. So an example here is when working with SLF4J. Some people can't forget that SLF4J uses the curly braces as placeholders rather than the %s, which is in the Java string formatting as a sort of as a placeholder. So we wrote a check that actually looks at the string and sees if somebody actually accidentally used the %s. And they say, well, that looks nice, but you probably meant to say curly braces here rather than a %s as a placeholder. Or if you have the info statement here, you have two placeholders in the string, but you only provide one argument to the login statement. Again, it's not easy, but it's possible to write a bug check to flag this and to inspect all of the invocations of the logger, where you look and parse the log string at compile time in this error-prone check, and then see if the arity, if the number of arguments is actually corresponding to what was defined in the string. Another category of things that you can enforce and that you can check using these custom bug checks is more along the lines of style, code style. So, for example, if you have annotations and you have something like order and then value is 1, you can much more tersely write this as order and 1, because value is the implied parameter here, and the implied target for a single argument to an annotation. Also, if you have an annotation, you can have an array of values usually. But if it just has a single element, and it has a trailing comma here, which is also valid syntax, but we don't really like that, then we can create a bug check, and it actually can flag this for you, but it can also rewrite the code, as we saw, to actually make it uniform and make it, yeah, in my opinion, also nicer. So there's correctness, there's avoiding runtime errors, there's the style issue. There's a lot of flexibility in here. And that's also a little bit of an issue, right? Because if I just showed the headers of the checks, right? I didn't show the implementation of these checks. And some of them can be pretty intricate. I mean, you have to know your way around in Java as abstract syntax trees. And you have to work with this error-prone API, which is very powerful, but also, well, I would say it does have a learning curve. So it's not for everyone. It's definitely not trivial to write some of these checks. It's worth it, at least for us at our scale, but it's not easy. Especially if you want to also emit these really good suggestions and replacements, because you also need to take care of that if you want to make your check maximally useful. So, given that, you might be thinking, but actually what is happening here is that we're sort of rewriting code, right? So, wouldn't it be really nice if you could have some work by example kind of approach, where you say, okay, I have a little bit of a bad example here on the left-hand side. For example, if you say a string equals an empty string, it works, it compiles, but it's much more intention revealing if you would write this as a string is empty. What if you could take this sort of approach and not fiddle with abstract syntax trees, etc., and just have some magic in there that does this for us? And that is actually also possible. And that magic is called refaster. So with refaster, what we can do is we can actually specify some before code, so an example of the code that we want to match, that we want to replace, that we want to rewrite, and some after code. And then refaster and in the end error prone take care of all the nitty-gritty details of actually finding the matches for this kind of code and doing the rewriting and just working as a large-scale refactoring tool. And the way you do this is by creating a class that contains some methods, at least one with a add before template annotation, where you have the code and the thing that you want to match, and one after template annotation, which shows how it should be. And I'm going to show this as a demo to you as well. For that, we have a third Maven project called My Refaster Template, where we're going to have such a class, and we're going to compile this class with the Java compiler with an additional different annotation processor, the Refaster resource compiler. And this will result both in a Java class file output, which we're going to ignore, because this code is never going to run. It's just there to inform Refaster of how you want code to be rewritten. And that is encoded into a Refaster file. So you will see that we'll also get this empty string.refaster file out of it. And once we have that, we can configure error prone to pick up this rewriting template, this empty string.refaster file, and to actually apply it to our code, to our buggy app. So let's do that. Let's have a look at how we can do that in practice. And again, the goal here is to replace this equals with is empty in this case. So what we have here is this class that I talked about with actually two before template methods, where we can see that we are targeting rewriting expressions of type Boolean. We can see that here in the return type. But not just any expression of Boolean type, but in this case, if it has the form of some expression of a string and then a method call to equals with a literal empty string in there. That is what we want to match. Or, alternatively, you have other creative people who say, no, let's call length on string and see if it's 0. So both of these cases we want to turn into the string is empty. So this string, this name here is just a placeholder, it's not really important. The name of the method here is also not really important. This is sort of the free variable that we have in our rewriting. It doesn't really matter what is here as long as it is an expression of type string. And if we go back to our application, it's actually an array dereference that we have here that will result in a string and that we want to rewrite then this part. So that's all pretty flexible. So what we still need here is an after template. So let's put this in there, empty string, there we go. So we want to have here an after template, and by the way, we also want to match negations, so if we say not, then we also want to rewrite that. That's a little trick that we have here. And we rewrite it to, well, again, something that returns a Boolean expression, because again, we need to rewrite to something that still compiles. But instead of invoking length equals 0 or equals empty string, we are going to invoke is empty on this. So that's all that we need to do to make this check reality. Now, I'm going to show you here in the configuration of our POM file that we are again running the compiler with a plugin, but a different one. This is called the refaster rule compiler. And we pointed to an output file, in this case, one level up. I'm going to output the empty string.refaster file, which then we can use in our buggy app to actually do the checking and the rewriting. So let's run this. Clean verify. There we go. Let's just check that we have the file. Yeah, that's all good. Then I'm going to go back to my buggy app application, and I'm going here to error prone, and I'm going to configure it with EP refaster. There we go. Again, using the EP patch checks flag, but now not referring to the built-in checks or any of the checks that we add to the class path ourselves, but we're going to refer to a refaster file, and this is the file that we just created by running this refaster resource compiler on the template that we have. And we're going to patch this in place. So let's run this. Maybe clean verify. Let's go back to our source code. And ta-da! We have is empty. How cool is that, right? So we had some before code. Just to reiterate, we had some pretty easy to write before templates. We had a pretty easy to write after template. And all the machinery around that was handled for us by refaster and by error prone. So we actually can get automated refactoring at scale going this way. Now, can it only do this expression rewriting? No, there's also an option to do actual blocks of statements and to write particular sequences of statements to other sequences of statements. Like if you have this manual swapping code, you can rewrite it to a single collections.swap method. That's pretty cool. But I think it's also really nice to look at some examples of how we use refaster. For example, when we migrated to Java 11, when it was released, there's some pretty nice improvements in the API there. And you can teach people to use those, and you can do the bushcart rule. So for new code, you can use it. For old code, maybe if you touch it. But how cool is it if you can upgrade all these 4 million lines of code that I talked about in one go to go from the old API to the new API? So we did this, for example, with a simple rewrite on optional, where you used to do not optional is present. And then in Java 11, we finally got optional is empty, which reads much nicer. So again, create a refaster rule, compile it, hook it into your error prone, and you actually get this rewriting for free on your whole code base. Pretty nice. There's some other ones in the JDK migration as well, where we used to do this on a stream. You would first maybe filter on optionals in the stream if they were present, and then map optional.get over all these optionals that had a value. Or if you were using Guava, you might have used stream.flatmap and then the streams stream method. We do use Guava, and this is also a nice example of showing where a rule matches both JDK APIs but also Guava APIs. But we wanted to rewrite those to standard Java stream.flatmap, and then optional stream method, which that's the new method that came in JDK 11. So again, and this is super powerful to be able to migrate your whole code base in one go from an older version of Java to a newer version of Java, and also improve all the code that is in there by doing these kind of rewrite actions. We don't do this just for core Java. We also use, for example, Reactor as a library, as a reactive library. Again, doesn't matter really what the exact details are. You don't have to know the API, but we have the ability now to spot some anti-patterns when we see in pull requests people using it slightly in the wrong way. Encode this into a refaster template, hook it into our builds, and make sure that it never occurs again in any of our code. So there's some more options here as well that we have for Reactor rewriting. Also, the refaster any of allows you to match any of some of the options. I skipped over that a bit in the previous one. What is also interesting about this example is that in the after template, we're actually calling a static method to optional. If you would just plainly put that into the source file, then it might be that it is not imported, right? So you can also use an import policy in the rewriting, saying, okay, if we're going to replace this kind of code, also add a static import for this to optional method. These kind of things are all possible and tweakable using refaster rules as well. So one way you use this, if you want to use an API which uses a certain method to another one, and that might have a fluent list of invocations, such as the examples that we saw, then refaster is really easy to use. Or if you have these blocks of statements that you want to rewrite to another block or to a single statement, that is also pretty well possible using refaster. However, it does have some limitations, right? So what we saw is that refaster is really about rewriting expressions. It's really easy to do it, right? You just have to define some before and some after code. But there's limited expressiveness, and refaster is really about rewriting code. It's not about spotting anti-patterns and giving good error messages about that, like we saw with the bug checks. So there's a place for both. There's a place for the bug checks, there's a place for refaster rules. Because bug checks allow you to do much more intricate manipulation of these abstract syntax trees. And you have the full AST available, so you can do much more powerful things, but you need to write more code in these bug checks to do so. So if you want to create a bug check yourself, this is actually coming from the error-prone site itself, ask yourself a few questions. Is this actually a bug that's easily understandable? Can I explain this in a short compiler error message? And also, is it easily fixable, right? If you have to go through 12 steps and a lot of hassle to actually fix it, it might not be something that you want to add to your generic build pipeline. So these are kind of concerns that you would have to take into account if you're going to adopt a tool like this, and if you're going to create your own bug checks, and maybe even contribute bug checks to error-prone itself, which is also a possibility. So what I say is the bottom line is that when a user sees one of our or your errors, they should think, I'm glad error-prone caught that for me. That's sort of the sentiment that you need to strive for here. You might also be wondering, okay, that's all great, but you show some demos, but how does it actually fit into your CI pipeline at Picnic, and then how is this actually applied? And the idea is actually pretty simple. So every time you create a pull request, every time we do a build, we will run all these refaster rules and these error-prone checks in patch mode. And if there is a difference, so if there's a non-empty git diff, well, then there's something that you missed, right? And then we can give a nice comment on the pull request. Says, okay, maybe you forgot to run the patch checks, and please run the scripts. There are some style errors. So this way, you will not be able to merge your pull request unless you addressed all of these refaster and bug checks that we have. And that is our custom checks, but also the stock checks that we have enabled, and the refaster rules that we have devised for, well, with the examples that I've shown before. But it doesn't end there, because we are so excited about error-prone that we also are actually investing in this. And We have Stefan Schroevers, also Rick Ossendrijver, who's also here right now, who did some research into extending the capabilities of Aeroprone and Refaster in particular. Because as I've shown, it's really cool, it's really nice to be able to write this, but it's still somewhat limited. And we have a very concrete use case. We wanted to be able to rewrite our code from old RxJava to the new Reactor library that we have. And you can get pretty far with Refaster as it is, but at some point you have methods with a return type that is of a RxJava type that you would want to migrate to a Reactor type. And as you saw, you can only rewrite expressions. You cannot rewrite method return types. So Rick and Stefan looked into this and extended actually Refaster and Aeroprone to be able to do this, which I think is really cool. Also led to a paper submission at a conference. So yeah, we're really excited about this because it works, it's cool technology, and it's actually useful in every Java project that we have. So I would urge you to go practice the new superpower, right? I think we've all seen some pretty cool stuff here. So first of all, just go to the Aeroprone site, browse a bit around. Also, I must warn you, we do have a fork of Aeroprone that we run. We also have contributed a lot of patches to Aeroprone, and some of them have been merged, some not. So if you really are going to use this, also look at this fork, and we've made some incremental improvements around the ability to emit multiple Refaster files and use them in one go, and all kinds of convenience things that help us, and that might also help you. We also, I think it should be only fair to shout out to Stefan Schroevers, who's our resident Aeroprone expert. I think it's really a testament to what a great engineer can do for a whole tech team. So if you have any in-depth questions, do reach out to Stefan. And I think with that, we come to a close. Thank you so much for being here. I hope you can tell that I'm really excited about this. I hope you are too. If you would like to work with this kind of stuff, please visit our booth and please go to this Join the Picnic website, because the 180 engineers that I mentioned in the beginning, it's only the start. We have so much scaling to do, and I would love to work with you. I would love to have you on our platform team also working on this kind of tooling, or in other teams using Java 17, using all this cutting edge technology to build the best milkman on earth. So again, thanks a lot for being here. I hope you enjoyed it. If you have any questions, feel free to come up after, because we're a little bit out of time here. Also, feel free to reach out to me at the booth. And thanks, everyone.
Okay, good morning and welcome. I have to say it is a real pleasure to be back speaking to a live audience again. I've spent a lot of time over the last, 18 months or so, talking to my laptop. And now I actually get to talk to real people and, well, maybe I can actually see a few people as well as we're doing the presentation. So, what am I going to talk about? I am going to talk about the differences between ahead-of-time compilation and just-in-time compilation, and how that relates to performance of your application, and specifically when we're looking at microservice-based architectures. My name is Simon Ritter. I am the Deputy CTO at Azul. There we go. So the first thing to think about is, in terms of the JVM, what are the performance challenges that we face here? Because the JVM is very powerful. It's one of the primary reasons that Java as a platform has been so successful over the last 26 years and has maintained that level of popularity. But having a managed runtime environment does mean you get better performance in some respects, but it also poses some challenges in other respects. Now let's look at the things that we can think about there. So the first of those is latency. How quickly can we respond to a request from a client? And there are a couple of reasons why you get latency in the JVM, but the biggest one of these is down to garbage collection. Automated memory management, the JVM decides where to allocate space in the heap for your objects, and you as a developer don't need to worry about figuring out how to reclaim that space. It makes your life easier. The problem is that the way most algorithms work is that they need to pause your application threads in order to do the garbage collection work safely. So when they're marking objects that are still in use, they don't want you changing objects that you use, and when they're relocating objects in the heap, they don't want you changing data as well. Now, there are some other things that can introduce latency into a JVM, things like JIT compilation. If you start compiling code whilst the application is running, that can also interfere with the performance of your application response. So latency is a big one. Second thing is throughput. How can we look at the way that we get throughput for our application? How many transactions per second can we deal with? And a lot of this is dependent on how we can optimize the compiled code that we generate for a given method. There's a number of different techniques that we can use, and we'll kind of talk more about this as we go through in terms of what are called speculative optimizations and the effect that those can have in terms of de-optimizations and the reality of then degrading throughput as the application is being used. And really it comes down to the effectiveness of the compiled code. How heavily can we optimize that code as to how much throughput we can get for the given application? And then the last thing is availability. So how quickly can we start up an application, and how quickly can we deliver the optimum level of performance? This is very apparent with the JVM because we use bytecodes. It's a virtual machine, it's a virtual instruction set. So we use bytecodes, and those bytecodes get interpreted by the JVM initially, which is very slow. As we spot the methods that are being used more frequently, then we compile them using the C1 compiler, then we spot that they're being used even more frequently, we use profiling information we've collected, and then we recompile them with the C2 JIT compiler, and that gives us better performance. But that all takes time, and that's the warm-up time that we see associated with the JVM. So now let's look at the microservices world and how speed and performance impact on those. If we look at the changes that we've made by moving away from a monolithic architecture to a microservices architecture, this is a sort of diagram that kind of puts that into context. We have our users on the left, they're interacting with the system, and what we've decided to do is break it up into a number of individual services. Those services interact with one another, and they produce the results that the client wants. On the right-hand side, we've got some database type activity where we can maintain state and things like that. And one of the real benefits of using a microservices architecture, especially from a performance point of view, is that if we find that one of our services becomes a bottleneck in terms of performance, lots of different parts of the rest of the system are depending on that and using it heavily. If we only have one instance of it, then that clearly is going to be a situation where we're going to degrade the performance of the overall application. Now, if we were in a monolithic application, the only thing we could really do is to throw more resources at the whole monolithic approach. More memory, more processing, and so on. And that's very inefficient, because if it's only one part of the system that's the problem, then we may be wasting resources. In a microservice-based architecture, we have the ability to change that. So what we can do is we can say, okay, that particular service is being heavily used. Let's spin up some new instances of it, share the load across them using whatever techniques we need in terms of like Kubernetes or whatever to load balance across the different instances we have. And we can do that very dynamically. So we can spin up new instances when we need them. We can then shut them down when we don't need them. And in a cloud-based environment where we're in a very much a utility-based model, pricing's based on what we use, that is a very efficient way of dealing with changes in load. The other thing we need to think of when we're looking at microservice-based architecture is that our users are interacting with the whole system. Okay, well, that's obvious, yes. But what's the impact of that? The impact is that they interact with the system, they have a particular task that they're trying to achieve. And we need to look at the design of our microservices in terms of how many of those are being used. Because the more that we chain together, the more impact we can have on performance. And this is especially apparent when we're dealing with a JVM-based microservice. Because if we do introduce latency into our services because of garbage collection, for example, then the latency of the request to the user is a cumulative effect of all the different services that are being involved. So if each of those starts doing garbage collection sequentially, in effect, then we can end up with some very long periods of latency associated with our system. So it's something that we need to think about quite carefully when we design the system as to how that might impact. So let's look at the performance challenges in terms of microservices related to what we spoke about earlier from the JVM perspective. So the first is this ability to spin up new instances. And we need to think about how quickly we can do that. Are we going to need to provision a new cloud instance? That could be something that could really take a long time. Or are we going to cache a number of instances and then make those available so that we can start up the individual services from that? Once we do that, how long is it going to take to reach the full transaction processing speed that we need for that service? Again, if we're going to go through a warm-up phase associated with the JVM, then we're not going to be able to deliver high performance, high throughput immediately once we've got that service started up. So spinning up a new instance is going to take longer in terms of its effectiveness, and we may need to think about spinning up more instances or creating other approaches to that. That becomes especially relevant when we're talking about serverless computing, where we're doing sort of a function that's only going to be used for a very short space of time. Second thing is obviously throughput. And from a microservice performance perspective, what we need to think about is how many transactions can we process with a given service. The more that we can get through one service, the less instances of that service that we're going to need to provide to handle the load from our users. And the third thing, again, coming back to what we said earlier, is latency. And that could be in the extreme form if we get something that goes into garbage collection and has a long pause associated with that. That may even trigger the overall architecture to think that that service has gone offline and therefore have to restart it or to create new instances to deal with the fact that that has, in effect, disappeared. So there's a number of things that we need to consider quite carefully with that. Let's talk a bit more about AOT and JIT then, and what are the different approaches to compiling our code. So if we look at Java specifically, we can take the approach and say, let's compile our code ahead of time. That solves a lot of the problems that we might see in terms of that warm-up, in terms of that startup time associated with the service. And this seems to be quite a sort of common approach to thinking about how to deal with Java-based microservices at the moment. So what you do is, rather than taking your source code and compiling into bytecodes, you compile straight away into native instructions, and that way you can run them immediately on the platform that you have, and you don't go through the whole warm-up effect. But that's not necessarily the best approach, because there are some things that you need to think about quite carefully. First of those is that, yes, we can compile, let's say, for an Intel architecture with a Linux operating system. But not all Intel processors are the same. Clearly, they can have different chips, different clock speeds, but they can also have different microarchitectures in terms of the instructions that they actually support, depending on how modern they are. And so you have to think, do we compile our code based on a knowledge of exactly which platform we're going to run on and which processor we're going to use? Or do we compile based on the fact that we might have slightly older chips or we might have slightly newer chips, in which case we can't take advantage of some of the more modern features? A good example of that is vector operations. And there are 3 different variations of this: as AVX, AVX2, and AVX512. And that determines how big the register is that you're going to use for your single instruction, multiple data approach. So do you compile based on 128-bit wide registers, or do you compile on a 512? Well, that's the kind of thing that you have to think about. The other thing that you lose when you do this is the whole write once, run anywhere approach that you get with Java. So you can't just move it to a different machine that maybe is running Windows. You'd have to recompile. Okay, probably not too much of an issue. But the other thing, which is more significant, is the fact that you're doing static analysis of the code paths that are being used. That means that you've got no visibility of what's actually going to happen at runtime. So you're saying, okay, let's compile the code based on what we can see there and just knowing what the code actually does statically. The other thing that's quite important is the fact that Java is a statically typed language, but it is dynamic in the point of view of class loading. You can load classes at runtime. It's very common to do that. And that will have an impact on how effectively you can optimize the code you generate statically. One of the most common techniques for improving performance is method inlining. You take your method, and rather than creating a stack frame, running the method, then popping the stack frame off, you just say, well, let's take the instructions of that method, put them into the loop, and avoid the repeated stack frame creation and popping. You can't necessarily do that if you don't know which method is going to be called. So if you are running with dynamic class loading, maybe at runtime you change the method that actually ends up getting called, and that way you can't inline it when you do ahead-of-time compilation. There are definitely techniques that can alleviate that. You can use profile-guided optimization. That's something that's been around for a long time, where you run your application, having compiled it statically, you run it, you get some profiling information, feed that back into the compiler, and recompile it again, knowing how it works when you run it. But that's still only taking a particular run as the reference implementer or the reference data. If you've got something which changes a lot, then you're still going to lose out in terms of the performance that you can get from that. So the optimization opportunities are definitely reduced. You've got less method inlining, and again, speculative optimizations, you can't use those in the same way that you can with different approaches. And also, the other thing you've got to think about when you're doing ahead-of-time compilation with Java specifically is that because there is this idea of automated memory management, how does that happen? How does it actually happen at runtime if you're compiling statically your code? Where does the allocation happen? Where does the garbage collection happen? We can also think, obviously, about the opposite approach, is what we use most of the time, which is just-in-time compilation. So now what we're doing is we're saying, find the methods that are being used most frequently, and then compile them as the application is running. What that does is it allows you to see a full set of information about how that application is being used. So you've got profiling information of the running application, and you can use that to optimize to the best possible way. The other thing you've got is a very accurate view of all the classes that are currently loaded, meaning that if you do want to do method inlining, you know exactly which method is going to be called because you know which class is loaded, and therefore you can use more aggressive inlining to improve the optimizations. And you can use speculative optimizations. However, the downside of that is that you have to do a lot of work whilst the application is running as well. That takes away from the resources you've got in terms of the CPUs, the cores, and even the memory, because you're doing this compilation at the same time, concurrently with the application. And that's going to reduce the throughput. It's also going to introduce latency by having stop the world pauses as you do method compilation as the application is running. Talk a little bit more about speculative optimizations, because these are very important to the ability to use JIT compilation. Here I've got a method which is a slightly contrived method, but it does demonstrate what we can do in terms of improving efficiency of code. So my method is called compute magnitude, and what it does is it takes a value, and then it says if the value is greater than 9, we're going to determine a bias that we want to use by calling another method that does some sort of computation. If the value is not greater than 9, then we just set the bias to be 1. And then we return the log base 10 of the bias value plus 99. Great. Now, if we profile that and we let the application run, we may find that in the run of the application, we've never had a value that's been greater than 9. When we come to compile the method, what we can do is we can make some changes to the code which will improve its efficiency quite markedly. What we do is we say, okay, well, if we know that up until now, we haven't had a value that's greater than 9, let's assume that that will happen in the future as well, and we'll continue to not have a value greater than 9. In which case, we know the bias is always going to be 1, we know 1 plus 99 is 100, and log base 10 of 100 is 2. So let's avoid all that work and just return 2 every time. Now, clearly, we have to have a situation handled where we do have a value that's greater than 9. If that happens, we then jump to this method called uncommon trap, and what that does is it says, ooh, we made a mistake, let's throw away the code that we compiled and then recompile it based on the fact that we need to handle both branches of that if statement. So this is where we get a de-optimization, and de-optimizations are what we really don't want to happen because obviously we're throwing away code and then having to recompile. Now, what we found at Azul in terms of analyzing code is that over half of the performance benefits we get through JIT compilation are down to these speculative optimizations. It's not just about complicated situations like that. Even simpler things like null checks can be eliminated a lot in terms of speculative optimizations. And so this really is critical for getting the best performance from your application. And also, the obvious thing is that if you minimize the number of de-optimizations, you're going to improve the way that your code is going to work. So what are the different approaches that we can take in terms of solving this startup speed problem? If we want to have less warm-up time and get to a faster level of performance as quickly as possible? Well, one of the sort of common things that people are using at the moment is GraalVM. So just a show of hands, anybody tried GraalVM? Oh, yeah, so that's probably a good, maybe 40, 50% of the audience. So GraalVM is one of those things that's been around for quite a long time. I used to work for Sun Microsystems back in the day, and Graal came from Sun Labs. And it's actually a series of projects that were started there. And Oracle have kind of bundled it all together and overloaded the term Graal to confuse people. Now, I don't think they really did that, but it is a bit confusing because the GraalVM represents several different things, which includes the Graal JIT compiler. Okay. One of the big things about Graal is it is designed to be polyglot and run lots of different languages, not just JVM-based languages, Scala, Kotlin, Clojure, and so on. What you can do is you can run all sorts of different languages, and as you can see from the diagram here, there are different pieces involved. So if we look at the Java side, that's quite simple, because what you do is you take your Java code, and then rather than running it through the C2 JIT compiler, you can run it through the Graal JIT compiler, which is actually written in Java. And then you can use the JVM compiler interface, and you can either run it through Hotspot as the JVM, so you're just running it as code through there, or if you want to create a native image, you can compile it directly into native instructions, and you use the substrate VM to provide the functionality that you need to do things like garbage collection and thread synchronization and so on. Now, for other languages, non-JVM specific ones, like Ruby, like JavaScript, the scripting type languages, then you need the Truffle framework. And that's a language implementation framework, produces or uses abstract syntax notation, which can then be fed into the Graal compiler to generate the code to run your application. For more traditional compiled languages like C and C++, they also use another layer, which is called Sulong, and that's based on LLVM, which is a compiler project that generates intermediate representation for that, passes it to Truffle, then compiles it using the Graal compiler. So there's a lot of different options with Graal in terms of how you can use different languages and have them run on top of the different parts of the system. Again, Graal uses profile-guided optimization if you've got the Enterprise Edition to try and optimize things when it generates static images. So if you look at Graal VM for Java applications, you can essentially do it two ways. You can either run it as a traditional JVM type application where you're using bytecodes, running them through the Graal JIT compiler rather than C2, and use Hotspot. Or you can use native images, which is what a lot of people do to really get fast startup and small footprint for their microservices. And what you're doing there is, as I say, creating AOT compiled code. It is fast startup. Oracle claims up to 50 times faster than using the JVM, and low memory footprint, again, Oracle claims 5 times smaller than you would get if you were using a JVM. It does use, as I said, the substrate VM to handle the managed runtime part of the functionality, and so memory management has to be done somehow. It is something to think about because the way that it does garbage collection is quite similar to G1 in that it uses a region-based allocation, but it's a sort of hybrid approach with region-based allocation and some static analysis as well. So it may introduce longer pauses than if you're using a concurrent garbage collector. There's another project in OpenJDK that was proposed in April 2020. And this was really looking at doing a very similar thing purely for Java. So creating native images for an application so that you didn't have to go through the JVM and you didn't have the overhead of various things there. It is designed, as they describe it, as a closed world. So it limits some of the things that you could have done if you're running on top of a JVM. There's no dynamic class loading at runtime, and there's also no dynamic bytecode generation at runtime. I'm kind of confused with this one because they proposed this project in April 2020, and to date, nothing has been done. There is no mailing list, there is no clone of the repo. They announced it and then did nothing. So, a bit confused why they bothered doing that. Another approach is what we have done at Azul. And we have a different JVM to Hotspot, which we call Prime. And part of that is a technology called ReadyNow. So what we do in terms of our JVM is to try and improve performance. So we look at the limitations that I talked about at the very beginning of the presentation. And we said, okay, well, rather than writing a JVM completely from scratch, let's take Hotspot, because a lot of the code is very good, but there's certain things we can improve on. And having made those changes, we need it to be a drop-in replacement for other JVMs. So we run the TCK tests, and we make sure that it passes all of those, so it's functionally equivalent to Hotspot. There's no differences in terms of how it will run your bytecodes other than from a performance perspective. So what we do here is it's all about low latency, high performance. And to do that, one of the things we do is remove all of the garbage collectors in Hotspot and replace them with one called C4, which is a truly pauseless collector because it does everything concurrently with your application threads. The other thing we've done more recently is to replace the Falcon JIT compiler in the same way that Graal does. But rather than using the Graal JIT compiler, we use one based on LLVM, the compiler project. And that allows us to get some good performance improvements that way. And then, as I said, we've got this ready now and compile stashing technologies, which is designed to reduce warm-up time. What does ready now do? Well, the idea is that if you run your application, you go through the warm-up, you compile your methods, you recompile your methods, you de-optimize, you re-optimize, eventually you get to a steady state where you've got all the methods you need regularly compiled and optimized. Great. When you restart your application, you have to go through the whole process again. So what we do is we say, run your application until you're happy with the level of performance, and then we'll take a profile. And the profile consists of 4 things. All the classes that are currently loaded, all the classes that are currently initialized, because that could actually be a subset of loaded classes. We also record all of the profiling data that was collected during the interpreted mode and also the C1 compiled code mode. And most importantly, any speculative optimizations which we used and then we had to de-optimize and throw away the code, because clearly we don't want to make the same mistake again. The great thing about this is there's no restriction about when you take the profile. You can let the code warm up for as long as you like. So whether it's 2 minutes, 2 hours, 2 weeks, doesn't matter. Just let it get to the point where you're happy with the performance and then take your profile. The other thing you can do is you can take profiles for different workloads. And by that I mean you could have a profile that you collect on Monday morning, you could have a profile you collect on Friday afternoon. If you need to restart your application, depending on when you restart it, you can use the right profile to address the load that you would expect to have at that time. What this allows us to do is to say, when we restart the application, rather than going through that whole process again, let's use the information in this profile. Let's immediately load all of the classes that we can, initialize all the classes we can from that list, and then compile all the methods we know we're going to need using the profiling information we've collected and the de-optimizations so we know what we don't want to do with speculative optimizations, and do all of that before you get to the point where you're starting your application in main. That way, when you get to the main entry point, you're going to have about 98% of the performance that you had when you took the profile. And you start your application and off you go with very, very high level of performance. Run about 2 or 3 transactions through that and you'll get to that 100% level of performance. Now, we can't quite get to 100% straight away, and there's a couple of reasons for that. One is that the way that the JVM is specified, there's certain things you have to do in a particular sequence when you start it up, and that limits some of the things that we would need to do with our profile. And the other thing that we have had some issues with in terms of the way that we can compile code is around some of the things like lambda expressions, because lambda expressions rely on invoked dynamic, and so you defer the implementation of the lambda expression to runtime, and so those are a little bit more complicated in terms of how you generate the code for those. We are working on some solutions especially to the lambda expressions at the moment. So the effect of this, if we look at latency specifically, is that if you take your normal application, you run it without Ready Now, you're going to see something like this blue graph, where you start off quite slow, latency because you're interpreting bytecodes, so the ability to respond is slower. And then as we compile methods, we'll gradually see that latency decrease because the methods are now being compiled into native instructions. And we'll see up and down in the graph because we're getting the optimizations at the same time. We can then do different generations of profile, and we can see different effects, and we can gradually bring that down closer and closer to the fact that we've got sort of 0 latency associated with the compilation of code dynamically during runtime. The thing is, though, if we look at a simplified version of our performance graph, so this is now not latency, this is performance. If we look at a simplified graph of without Ready Now, start off slow, gradually warm up, get to our optimum level of performance. Okay. If we look at it with Ready Now, it looks like this. So now we've got a much steeper graph, so we're getting to our optimum level of performance really quickly. That's really good. Except we've got this kind of blank bit before the application does anything. And that might be bad, because what's happening there is obviously we have to do all this work first. We have to compile the code, we have to class load, initialize, and so on. So we thought, how can we get around that? How can we reduce that as much as possible? And we looked at the way that the compiler worked, and we said, okay, what's happening is we're taking our bytecodes, and because we're using our Falcon JIT compiler that's based on LLVM, what we essentially do is convert the bytecodes into LLVM intermediate representation, pass that into the compiler. The compiler then needs to know how to optimize that method. And to do that, it will ask certain questions of the virtual machine using callbacks. And this is essentially asking it about the profiling information that's being collected whilst that method has been run. The VM is then going to provide some responses to that, which is the input to LLVM to understand how to optimize its code. It will then use that, generate some machine code, and we get a compiled method. Okay. Now, the other thing that we know about LLVM is it is a fully deterministic compiler. And that means that if we take the same inputs, we're guaranteed to get the same output. If we look at a method that we have in Java, we're going to see, in terms of the data that we have, something like this. So our method is going to consist of some initial intermediate representation generated from the bytecodes. We're going to have a live profile associated with that method, and then there'll be a set of queries and responses that LLVM uses to optimize, and then the machine code that's generated. Which means that if we have identical inputs, if we haven't recompiled the method, and we're using the same profiling information as we had before, that will result in the same queries and responses. That means that we're guaranteed that the compiled code that's generated by Falcon is going to always be the same. Right, we can take advantage of that. So what we now do, in addition to taking the profile, which consists of classes loaded, classes initialized, profiling data, and de-optimizations, we also take a copy of all the code that was compiled from the run of the application. That way, we can put our compile stash, as we call it, effectively as a cache between the JVM and the compiler. If we pass in the intermediate representation and we know that the profile hasn't changed, we get a match on the method that we need to compile. Rather than getting the compiler to compile it, we simply say, take the code that we've already got, pass it back, and avoid all of that workload. What that then allows us to do is take that graph where we've got this sort of blank period where the application doesn't do anything and shrink that down. So now what we can do is reduce the amount of compile time that's required by up to 80%, and the CPU load before the application gets to doing its work by up to 60%. So that's a good improvement in terms of what we can do there. The other thing that I want to talk about is Java on crack. Now, I've got to say that our marketing team may have to rethink the naming of this, because it might not be the best. But this is an interesting research project that we're doing at the moment. Java on crack. Crack stands for Coordinated Restore at Checkpoint. And as I say, it's a research project that we've started to look at pausing and resuming JVM applications. And we've now got this as an OpenJDK project. So if you go to the OpenJDK, you'll find CRAC as a project there, and you can look at what we've been doing. What we did was we looked at some other technology that's already been around for a while, which is CRIU, Checkpoint Restore in User Space for Linux applications. And I'm sure some of you have come across this in other places. And that was originally targeted at live container migration. So you could take copies of containers and migrate them to other machines as they were running, in effect. Now, if you think about taking a running application in Java and simply freezing it, taking a snapshot of everything, the code that you've got, the registers and everything, and then being able to restart it at some point later, that's very difficult. And you can't just take a snapshot and then restart it. Things like file descriptors, things like network connections are just not going to work if you do something like that. So the key thing about coordinated restore at checkpoint is coordinated. What we do there is we're creating an API which says if the application is running and it decides that you want to take a checkpoint, you can let the application know, and then it's up to the application to take whatever steps are necessary to make itself ready for a checkpoint. And that involves things like closing files, closing network connections, and tidying up things which it will need to restart when you use the restore part of the functionality. And the thing is that, you can actually enforce rules with this so that if the application hasn't done enough work, then it won't actually take a snapshot. What then happens is, clearly, you can restart the application at a point later in time using the snapshot. And again, the API is used to say, right, I know I've been restarted. Now I can open the files I need. I can reconnect to network resources I need and coordinate the restart of the application. This can lead to some very impressive results. So if you look at our GitHub repo, github.com/crack, we have created a proof of concept of this, and we've done some comparisons between just running standard OpenJDK and then OpenJDK on crack. Spring Boot. If you take a Spring Boot application like we did and you run it to the point where you get your first operation in terms of application functionality, in the machine in the example that we ran here, it took nearly 4 seconds to go from cold to processing a transaction. Using our checkpoint restore, coordinate restore at checkpoint, that reduced to 38 milliseconds. So that's 2 orders of magnitude faster. And remember that you're also going to get the same level of performance in terms of JIT compiled code with all the speculative optimizations, with all the ability to do aggressive method inlining and things like that. So very, very fast startup with the optimized code and better performance. We did some other benchmarks here. You can see Micronaut, that took a second to get up to speed, 46 milliseconds using crack. Quarkus was 980 milliseconds. So, Quarkus is one of these frameworks designed for very fast startup. Great, so that was 980 milliseconds using crack. We got that down to 33 milliseconds. And XML transform, which is probably not the best benchmark to look at, that was 4.3 seconds to processing a transaction, and we reduced that to 53 milliseconds. So again, you can see that there's some really quite impressive results that we're getting with this. It is still only a research project. I wouldn't say this is quite ready yet for production, but it's got some interesting ideas, I think. Just to summarize then, basically faster startup or faster code. I think it's obvious that microservices can benefit from fast startup. If you want to have this dynamic ability to spin up services, then that can really benefit from having the ability to go straight to 100% level of performance. But it isn't always necessarily essential. If you've got a longer running microservice that's going to run for minutes or hours or longer, then you might need to think, is it really important for me to start that service up super, super fast, or am I more interested in getting better overall performance once it's warmed up and once it's doing what it needs to do? Overall performance, like I say, can be just as important. Consider all the aspects of the application performance, so startup time, throughput, and latency. And if you're interested in trying our Prime JVM, as I say, it's got different garbage collection, it's got different JIT compilation, it's got Ready Now. You can go to our website here at azul.com, products Prime Stream Download, and you can try it for free. And with that, I think that is the end of my presentation. And I will just make one more plug for one of my colleagues, Hirchen, who I can't see where Hirchen is. Where are you here, Hirchen? You said you were going to be here. At the back there somewhere. I can hear a voice. Okay, so Hirchen works for Azul as well, and he's responsible for Fujay.io. And Fujay is Friends of OpenJDK. And it's a website that we've started to provide lots of information about OpenJDK. If you're interested in seeing the differences between different releases in terms of command line flags, in terms of the updates and what's been included in the updates from security perspective, from a bug fix perspective, there's all sorts of information there. It's very, very useful. There's lots of blogs on there as well. It is not an Azure site. It's a vendor-neutral site. We've got lots of partners that help us with that, people like SNCC, Pyara, JFrog. There's lots of other companies involved in this, so I would strongly recommend you to check out fujay.io. And with that, thank you very much.
Yes, welcome back everyone. I'm not going to make you do anything today. It's great to see that many of you are still here. We're about to continue with our next keynote for today. This is presented by a veteran speaker who has spoken all over the world. He's going to enlighten us by talking about the Zen of programming. Please give a very warm welcome to Sander Hogendoorn.
I can tell you how good it feels to be back on a big stage, right? So the last time I was on a big stage, it was like February last year, actually. So it was I think it was the opening keynote to JS World or something. And don't worry, I'm not going to joke about different programming languages. I learned not to do that. So this is a personal talk. It's actually a brand new talk. I haven't done it before. So if I fail in my timing, if it's boring or whatever, it could be because you're my tryout audience, basically. So let me start by saying this is my journey, right? So when I was asked to do the keynote, I was like, what can I tell that is not already being told? Well, my personal story, of course. I can tell you about, yes, you need to do OO, you need to do design patterns, you need to do solid, you need to do yada, 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 and unit test, of course. But I want to show you a bit about what I learned along the almost 40 years that I've been writing code. I've been writing code since, I think, 1981. So given this is a Java audience, most of you were born yet, and if you do this in a JavaScript audience, there's like, what? Did they have computers back then? Well, yeah, my Commodore 64. It still works, by the way. So this is my personal journey. And because it's a journey, I'm going to talk a little bit about travel, and I'll talk a little bit about how I write code, basically. It's not meant to say you have to write code like this. It's meant to say I write code like this, and if you take something away from it, please do. So I love to travel, and I love to write code. Those are basically my hobbies, I would say. Now, I find this nice word on the internet saying you could be a travelist, which is slightly different than being a traveler. So I looked up what the definition of that was, and the definition of that was, well, it's a bit long, so I'll put a red thing around it, and it says, those who wander to fully experience a new locale, and the culture, the people, the approaches to the everyday common tasks we all endure, to learn to be inspired, to deepen the soul, and enlighten the spirit and refreshen the mind. Wow, that's a mouthful, right? It does sound a bit of like how I experience travel. It's also how I experience writing code. Usually, except for the big difference is that coding is 90% frustration, as we all know, right? So it's, oh man, I can get so frustrated when something doesn't work. I actually can stay up on like 4 in the morning, and then I'm like, what? It's so dark, everybody's gone to bed, and I'm still writing code. So I sort of rephrase it, and like, those who code, if you want to be a codist, those who code to fully experience a new locale, an LNL, the culture, the people, the approaches to the everyday common tasks, or call it stories, whatever you want, we all endure to learn to be inspired, to deepen the soul, enlighten the spirit, and refreshen the mind. Now, isn't that cool, right? That is what I sort of want to be when I grow up. Yes, I'm old, I know. But anyway, so the great programmer Aristotle said, well, before the things we have to learn, before we can do them, we learn by doing them. And this is typically it, right? Malcolm Gladwell says you need at least 10,000 hours of practice to become really, really good at something. Like the Beatles, they practiced forever in the basements in Hamburg. And like Bill Gates, for instance, well, okay, not a good example here, but Bill Gates practiced programming since he could read, basically, right? This is the point of, you need to do it continuously and slowly get better. It's a bit like the old Adagio Shuhari, right? You probably know this, right? First, you need to learn the rules, right? You need to learn from somebody who's done it before. I'm going to point it here. Well, it looked a bit drunk though, but so you need to learn the rules, and once you've learned the rules and you blindly can actually apply them, you slowly start to detach from them. And in the end, you sort of transcend, which means you can find your own thing outside of the rules. Like the Scrum community, I have to bash on Scrum a bit, sorry. So that's okay, right? You all don't like Scrum either, right? No. So basically, a lot of the people stick into the shoe stage, right? It's like, yes, these are my rules. This is the Scrum guide. I have to have sprints. I have to have retrospectives. I have to have stand-ups. I have to have user stories, which are not in the Scrum guide anyway. But and they stick by that. And they're like, no, you have to have sprints. And I'm like, I don't like sprints. I'm beyond that. I do continuous delivery, right? So why would I do sprints for? Yes, because in the Scrum guide. Yes, so what? Well, that's the whole point, right? You need to transcend from it. And it's the same with coding. Once you learn something new, the next step is, where do you take it? How do you make it your own? And how do you transcend from the rules you've learned? Because otherwise, we would all be doing the same thing, right? We would all be writing our code in the same way. And the good thing about coding is that it's that intuitive feeling that you can have when you write the code and when you make it work. That is such a beautiful moment, right? And we all recognize that. So for me, it has become much more, well, let's say Zen-like. I'm going to move away from all this East Asian shit, but I have to get through it first, right? So what does Zen basically mean? Well, Zen is a state of calm attentiveness in which one's attention are guided by intuition rather than by conscious effort, right? And a nice example is the Zen of gardening. You become one with the plants, lost in the rhythm in the tasks at hand. Cool, right? But for me, it's the intuition part that is most important, is I code by intuition, basically. I don't apply rules. I don't check for which design patterns to use or not to use, or how to set up my functions. And it has become sort of an intuitive feeling about what I like and what I appreciate about what my code looks like, right? So I came to the Zen of programming saying, you become one with the code, lost in the rhythm of the tasks at hand. Cool, right? Now, let's do something, right? Okay, so what about learning? How do you learn then, right? There's a great analogy in a book by Gerald Weinberg. Gerald Weinberg has died a long time ago, but he wrote a book called Becoming a Technical Leader. In this book, he describes very nicely how learning proceeds. And he says, well, I tried to learn to play pinball. Very different example, right? You say, what's to learn about pinball? And his original assumption was that it sort of progresses over time. It's a linear function, right? You can say, oh, you get better slowly and slowly and slowly and slowly. And then he started measuring his scores at the local pinball machine in the local bar in the town he lived in. And he said, well, it's not like that at all. My scores slightly go up until I get to this point where they all of a sudden get a lot better. And then progresses like that again, and then felt like that, and he tried to identify what made this work. So he jotted down all his scores he had on the games he played on the same machine, and he realized that right before there was this strong incline in his scores, he actually had his scores go down a bit. And he was wondering why that was. And the reason he found for it is he said, every time I slowly progress, at some point in time, I have, let's call it an epiphany. I have this idea about how I can get better, how I can make it better, maybe how I can write my code better, and I have to try it out. It fails at first. This is experimentation, right? It fails at first until you get it. And the example he gave is multi-ball. Okay, have you played pinball before? Do people still do that? I love to. And so what happens with multi-ball is you get multiple balls in play at some point in time. I never understand why, but at some point in time, all the machines I play, they have like 5 balls in play. Like, what do I do? What do I? That's the question, right? And he thought, what if I keep my eye on this single ball so that I don't lose them all at the same time? That happened to me quite a lot, right? You play these 5 balls and you're like, and all of a sudden, buff, they're all gone. Right? And he said, well, I keep my eye on one, and that one I keep in play, so I can continue to play. And he tried that out for a bit, and he got better. And his score increased like, pew. So he had this epiphany, and with this epiphany, you learn. This is how it works. You get an idea, you try it out, you fail it first, and at some point in time, you realize it starts to work, and then you get a lot better. It's exactly the same with coding, I found. So Gerald Weinberg says, well, we must learn from any place we can and any way we can. And by the way, I think that doesn't only include learning. It's not just more and more and more and more. You also have to let go of stuff. So it's basically learning and unlearning at the same time. Now, I found this nice graph on LinkedIn earlier this week, which is pretty cool. And actually, I thought it was surprisingly correct for what I have done in the 40 years of programming. I started really simple because I didn't know shit. By the way, I learned to write code from a book. A book is a big pile of paper and they put letters in it. When I learned to write code, there was no internet, right? You literally had to learn from a book. The book was all you had. It was a big black book, Pascal on it, so I learned to write Pascal, right? Really cool. And I got better at it. And eventually I got to a point that I started doing things that were not in the book. Weird, right? And then I started learning OO, like in the 80s. And I learned design patterns. I read the book when it came out in '96 or something. And I started adding all of those layers and abstractions and interfaces and all of this stuff you can imagine that you think you need to build a decent application. And in most cases, it probably is. The point was to me is that at some point in time, and I don't remember exactly when, I started letting go of a lot of those ideas. It doesn't always have to be 60 layers of inheritance. I don't always have to use an abstract factory, right? I can do it without dependency injection. Pretty cool. But I can also write a lot of code without using dependency injection. It still works, right? And so I realized that I was on a quest for simple code. And what simple code is always in the eye of the beholder, right? What could be simple code to me could be rather strange to you, or what could be complex to me could be simple to you. It's all based on context, right? There is no such thing outside of context. What I realized is I will never be there. There is never going to be a point that I said, this is the simplest code that I can ever write. I have thought that for the last 25 years, and every time I was wrong. So no surprise would be that if I write code next year, that my code will be simpler than the code I write now. And there is a good reason to write simple code, right? Because simple code is better. So the question is, where do you go? This is a good point to introduce myself, right? So my name is Sander Hogendoorn. I'm an independent dad, as I like to call it. I have 3 kids. About 1.5 of them live at home. I'm a speaker and author. I travel a bit. I'm sort of a serial CTO. And I'm a mentor, and I'm basically a lifelong programmer. That is the one point in this, well, except for being a dad, the one point is that I'll never stop doing. Probably until the day I die. I'm currently the CTO at iBoot.com, a well-known e-commerce company. I was born to be a programmer, I'll show you. Listen, I was double object-oriented. It gets worse, by the way, because I live in the Java street. I did that. I like to say, oh, I don't want to have an apartment in the Java street. Yeah, sure. So I also do write some open source stuff. This is basically the result from the last 5 years of programming in TypeScript, and we built a framework out of it. If you look at the framework, it reflects quite a bit of the stuff I'm saying, which is, well, no surprise, right? So let me tell you a bunch of stories. The first story is about the wall in the desert. So this is in Wadi Rum in Jordan. And the interesting story about this is a guy called Wim Groenendaal. He used to be my first mentor when I was like 26, 27. I came into his team and he said, Sander, listen, imagine walking in the desert. There's a thick fog. So you don't, fog is a bit hard word to say in English, right? But you can only see about, what, 30 centimeters, maybe 40 centimeters. So you don't see anything right in front of you. Now, imagine that there is a wall in the desert. Well, there could be a wall in the desert. You don't know. It might be there, it might not be. You might run into it, you might not run into it. And you don't know. So what do? Well, you start walking. That's the thing, right? You don't know, so you just start doing it. And that means that because if you don't know exactly what you will run into, all of these managers that come to you with the questions, when is it done? Why are you slower than your neighbor? Why is your velocity slow? How many points can you do per week or per sprint or whatever you do, right? They're all wrong. It doesn't work in software development. They should stop doing this. Like, oh yeah, we need to have a personal velocity. These are actual charts, by the way, from a manager this year. And like, oh, he had a velocity of 14.8. Pretty amazing, right? What did the other dude do? He did like 10.5. He's slow, right? They should kick his ass, I think. So there's a nice quote from the famous US programmer Donald Rumsfeld. he said, well, there are the known knowns, right? There's the things we know. And we also know that there are known unknowns. There's things that we know that we don't know. Those are okay, basically. Where it goes wrong is where you talk about the unknown unknowns, because these are the ones you don't know that you don't know, right? This is the talk you need to do to your manager. He'd say, listen, dude, Donald Rumsfeld says, and he's a famous Java programmer. He's not, because he doesn't have a beard, right? So, and he say, there's the unknowns. That is why we cannot estimate. They'll hate you for it. I do this every day with my manager, by the way. And he said, well, it's basically the latter category that tends to be the difficult ones. Well, no surprise there, right? And then your manager comes, yes, I get all this, and I get all this agile stuff, and I get all this stuff about you cannot. Ford says, he says, well, developers are drawn to complexity like moths to a flame, often with the same result. Gregor Hope says it worse, by the way. He says, well, basically, excessive complexity is nature's punishment for organizations that are unable to make decisions. And the same goes for developers. And there we are, right? Every developer, well, that's me, right? And we all say the same things. We're like, yes, well, we might need this in the future. Eventually, we will need this. What if I make it more generic now so we can benefit from it later? What if we want to replace this database by another at some point in time? You all do this, right? Especially the latter one. Like, yes, but what if we want to replace MariaDB with CloudDB database, whatever, right? What if we want to do that? Who's ever done that, right? We build all this complexity into our code that nobody asks for. And that's the problem, right? And what you need to do is you need to learn about these keywords, about we might, in the future, eventually, later, or what if. All this code that you build in for these reasons is premature optimization. And premature optimization is highly expensive. And it also needs to take into account a thing called Hofstadter's law, right? Because if you are adding all this complexity, it gets complexer. And once you think you've almost tackled the complexity, oh, wait, there's something else coming out of the big head, and oh, what, shit, we need to take even. This is Hofstadter's law, right? It always takes longer than you think, even if you take into account Hofstadter's law. Like, I was working with a small mobile team recently, and they were building a new mobile app. So what's the first thing you need to do? Right? Well, let's log in, right? Okay, so we'll put 2 text boxes on the screen and a button. And we fill something, we click it. That's the first thing you can do, right? And then I said, so what's next? I thought, well, probably they connect it to an API or something. And I said, no, we need a Redux store. A what? A Redux store. Why do you need a Redux store and a username and a password to an API? Well, we always do a Redux store. Now, those arguments are so wrong, and these arguments are costing us tons and tons of time and money, and now I don't know where my presenter is. Where do I put it? What? Oh, wait, there's more. There's a secret thing here, right? So the problem is, big trick, well done. So the problem is you can only spend your time once. This goes for everything in life, by the way. I learned to do this by getting a burnout, seriously, in 2009, 2000. Ask yourself all the time, every day, every time somebody comes up with a stupid suggestion or a very smart suggestion, the question is, do we really need this now? All the teams I work with, they know this question. They ask these questions every day. Especially when I say something like, you know what, I'll build in, and then they say, do we need this now? And the question is, do you really need this now? No, you don't. And if you don't do it. It's as simple as that, right? That's the simplest thing you can do. And simplicity rules, because code is not a product, right? It's not like the more code we write, the more we produce. Actually, code is cost. Because every line of code we write takes time, it takes money. It needs to be maintained. Somebody needs to deploy it. Somebody needs to test it. So it's expensive. So every line of code that you don't have to write, you shouldn't. And then the intuition part comes back. It's like, okay, I look at this piece of code. This is a Jest test. And I look at it and I'm like, this is actually code I picked up like 2 weeks ago. It's my own code, actually. And, and I look at it and I'm like, yeah, It's okay-ish, I guess. It's like 5 lines per function. I don't like 5 lines per function. Let's make it 3. So I refactored it. It took me about half an hour. I was like, okay, I created this addID function, which sort of does the same trick as the other 3 lines, and I make it simpler. And it's now simpler to maintain, meaning it's cheaper, right? And the cheaper the code is, the better it is, because the best code and the easiest code to maintain is no code. By the way, that doesn't mean I'm in favor of stuff like low code and stuff. We can have discussions about that, but it means that the code you don't write, you don't have to maintain. That is pretty much important, right? And I realized that over time, when I got over this bump, and I went down to the other side to where the simple code lives, I started realizing that most of the functions I write are single-line functions. And a bit like this, right? These are single-line functions. They're lambdas, basically, but and this is all they do. You can hardly go wrong with code like this, right? So you're thinking, yeah, but I could never do this. It doesn't have to be, but you have to think about getting over the hill. And where that hill is for you is different than it is for me, probably, right? So, and then I also realized that I started doing these little things that I first, well, when I first started doing it, I didn't realize it, but I got sort of conscious about doing this. I start every function I write with return. It's the first word I write in a function. It's not the last word I write in a function. I can write like lines of code and then, oh, return this, right? No, I took it the other way around and said, okay, return. What do I need to return? Well, maybe a Boolean, maybe an object, maybe this, whatever. Could be anything, right? And I started writing it back to front. So to reverse the order in how I write my code, I changed it to, okay, I need to return it. What do I need to do to return this? Oh, I probably need to get it from a database. Oh, that means I have to talk to the gateway. I probably need to do some validation maybe, or stuff like that, right? So you start thinking about it. It helps you reason about the way you write your code. And this is a technique that works really, really well for me. I'm trying to teach that to the teams I work with as well. Not that I say it's mandatory, it's an idea, right? And it's with naming things as well. We are very used to, especially in the Java world, to name the variables we have, the parameters we have, and give them the same name as the class. Do we still do this in Java? Or? Yeah, right. Why do we do this? What's the point? I realized that when we had Notepad that we need to program in, that it would be useful to give the variable the same name as the class name because, well, if I use it 10,000 lines down the road, I don't know what it is anymore. But these days, we have all really good UIs, right? Or for IDEs, we have WebStorm, we have IntelliJ, VS Code, whatever you use these days. But they know this, right? I can hover over it and they say, well, it's an order repository. So I don't have to name it the order repository. I can name it in a way that it makes sense to the rest of the code. I'll give you an example here. It says, return this orders by order item, which is much more logical, much more readable than saying, oh, return this.order repository.get by whatever, right? It doesn't matter where it comes from, it matters how it reads. And that's a different way of looking at it, right? Especially if you have classes like this. If you would make a function, put this in a parameter, and give it the same name, it's already way beyond the maximum length of the line, right? So it doesn't have to be. I'm not saying this is badly named. It's probably very accurately named, but I'm saying is if you make a parameter of this type, just name it A. Or SI for servlet initializer, right? Good enough, because it works, especially if you write the small functions. Because in a small function, it's always there in front of your head, which is good, right? Or for instance, if I look at parameters, I name them really short. Sometimes, usually just one character. And I know this is almost forbidden, right? And this is exactly what I was talking about a Scrum community getting stuck in shoe. It means, why wouldn't you name a variable with one character? If it's clear enough, it's only used in the next line. So why would I care if it's called... Sounds nice, right? Also, the most secure code is no code, right? So, next topic. We have to talk a little bit about architecture, right? And the thing about architecture is, I started to realize a long time ago that my architectures need to be able to adapt. I need to be able to move to different databases, new technology, or different patterns, or adding all sorts of new stuff to it without it breaking. Now, since I started writing microservices in 2014, I don't have a single repo anymore. I have like tons of repos. And the problem with that is, if you all let them grow into the impossible to read, right? And because these things last for a long time, you need to be able to understand them. So now I've thought back about that, and like the great Java programmer Charles Darwin, he said, well, he has a beard, right? So it's not the strongest of the architectures that survives, nor the most complex that survives. It's the one that is the most adaptable to change, right? And Neil Ford, of course, who doesn't have a beard, he says, well, in his new book about evolutionary architecture, he says, well, evolutionary architecture supports continual and incremental change as a first principle among multiple dimensions. That's a bit of a tough sentence, and let Neil explain that, but basically, a microservices architecture really fits this, because you can change it in different dimensions. And then I thought back about a book I once wrote, and a lot of people in the room, oh, is this the dude that wrote the unreadable book about UML? Yes, that's me too. And sorry, I'll try to write better readable books. And in that book actually is an architecture. And that an architectural pattern actually. And that architectural pattern is one that I've been dragging along for almost 25 years now, and it's still there. And it's been implemented in very different languages and very different platforms and ecosystems. It's really simple. It has entities, well, it's DDD, right, in its heart, repositories around it. It has use cases in a sort of process layer. They're really useful, actually, from the UML book, of course. And this is how you talk to it. This is your interface towards it. These are your resource classes. And you know what? You need to get out to get the data from other services, from elsewhere, from a database, whatever database, wherever it is. And this is the architecture, right? And the nice thing is, recently, I went into Bitbucket. Sort of archaeological, you don't go voluntarily into Bitbucket, right? But and I discovered a code base of my own team from 2010, I think it was. It has the same things, right? It has like a data layer, and it has a business layer, and it has a process layer, and it has a web layer. And I went into it, and it looks exactly the same as I would write my code right now, except that the way I write it has progressed, right? So here's a repository class from that code base, basically, written in C#. And you can see it's C# because the brackets are on the wrong lines. And it's only because I do JavaScript, huh? It's like, no, just kidding. I had a recruiter recently in the company said, yeah, I have a CV for you. And he said, what? And he said, well, yeah, it's a Java program. I said, well, we're doing JavaScript. And I said, well, that's the same, right? Anyway, so much for recruiting. So anyway, this is one from C# in 2008 or 2010. I don't remember anymore. This is one in Java. This comes from a code base that we wrote in 2015. It's still a repository. It's still the same pattern. It does the same thing, except that this is highly organized around using a try class, which I'll get to next. And this is one, Java. Yeah, this is Java. Okay. Oh yeah, use ligatures. That's the, anyway, doesn't matter. So, and this is one in TypeScript. This is very recent, but it's the same pattern, right? So I've been dragging this pattern along for a very long time, and it still works. Yeah, you see the TypeScript one, right? So, and I shortened the code, right? It's now repo. It's a large improvement from repository. So the whole thing about architecture is this thing. So this is me, my girlfriend, my son, and his girlfriend in Rome. And because we're in Rome because we decided to go to Thailand. Well, given COVID, you can decide all you want to go to Thailand, but it didn't work, right? And then we thought, we'll go to Iceland because it's so cold, there's no COVID. But apparently more people thought about it, so car rental for a week was 4,000 euros. And then we decided not to go to Iceland. And then we figured out, maybe Norway or Turkey, and both of the countries, just 2 weeks before we wanted to go on holiday, collapsed. And then we said, well, let's go to Italy. Italy's safe, right? Italy's always safe. Well, sort of, but it's nice. And we decided the last day to go to Italy. And what the point in this is that if I would have made the decision to go to Thailand, booked the tickets, and we got the refusal to go there, we'd be stuck. So we waited until the last responsible moment to make the decision. And this is exactly what you need to do with architectural decisions. You need to wait until the very last moment in time that you can make that decision. And you need to figure out for yourselves when that moment is. It's not necessarily the last day because you still need to build it or implement it. But wait for it as long as you can. Right? So, what's the next step? Well, the next step is to realize that this world is complex. At worst, it's chaotic. And I'll explain to you what that is. So, I'll give you a nice example. This is the 32 best React state management libraries. Are you like, 32 React state management libraries? What do you mean? And like, there are 32 React state management libraries? Well, given that these are just the best, and you have to choose from it, right? Of course, everybody chooses Redux, and the rest of it, I have no idea what they do. So, here's the point. This is the Cynefin framework. You know this one, right? The Cynefin framework, I'll explain really briefly, is a very interesting model that says, in the obvious zone, if you live in that, you have a best practice. You apply that best practice, done. Simple, right? And then there's the complicated zone. In the complicated zone, there might be a good practice, but you still need to figure out which one. So it's probably one of those 32 React state management libraries. You don't know which one, you need to figure it out. And once you figure it out, you can get going. The problem is that most of us live in complex zones or in chaotic zones. Now, in complex zones, that means there is no best practice yet. We don't know yet. It's coming. It's sort of progressing. Out there in the world, people are doing this too. They see the same problems. We sort of find the same sort of solutions, and we can work together on it. We have an emergent practice. In the chaotic zone, it's even worse. There are no practices because nobody's done this before. We don't know how to do this. If you make a choice to go for a technology that lives in the chaotic context, well, you're basically up for trouble, right? That's not necessarily wrong, by the way, but it is a fact. So here's the thing. There are no best practices. In what we do, because we live in the complex and the chaotic zones, there are no best practices. There's no such thing that's valid everywhere. Even when it's valid in the whole Java community, or even the whole Java and the .NET community, it might not be valid in the Python community or in the JavaScript community because they do different things. Right? So there is no such thing as a best practice. Well, there are good practices, of course. There's things that you can count on because you need things that you can count on, like stuff like coupling and cohesion, right? You're always going for low coupling and high cohesion. That's what you do. Also, the Unix philosophy is one really nicely, right? It says, well, write programs that do one thing well. None of us do that, by the way. We write way too big programs, right? That's good. And then you think, yes, now comes the solid part. Oh, okay. Solid is okay, right? So the single responsibility principle, I live by this basically because I write one lines of code. They can only have one goal. There cannot be more goals in a single line of code. Well, depend on how you construct it. So if I look at the bit of code like this, which is from my own team, I look at it like, what? You have like 5 gateways to fill one repo? What are you doing? And then I look at the code, I'm like, okay, it's asynchronous, I get that. It's using the right structure. I still can't read it. Intuitively, I don't like this code. I think I need to refactor this. It's Boy Scout rule, right? You need to improve on it once you see it. So I was in trouble, but I did actually. So, and the open close principle, yes, always, right? But some other stuff, like the DI stuff, well, I did DI and I promoted DI and I built DI engines and I built frameworks for it and I used it everywhere, including in Java, right? This is my own code basically from a previous client. See, here's some injection and, well, we're creating instances of contract repository, which of course is called contract repository. And the organization repository is called organization repository. See, this is what I mean. It could have well be called contracts, right? Would be much readabler. But this is where we do it. And it's okay, it works. But when I started writing the easy framework, the open source framework, I was like, I don't need it yet, right? I don't need the DI yet. So I'm going to leave it out as long as I can. And it's still not in there. And we're writing full-blown commercial applications with it, it's still not in there. Apparently, We didn't find a need for it. So you can perfectly write code without doing dependency injection. Now that's news, right? So this is how it looks like. So the only thing I do is, well, if I need a new instance of the manage shop use case class, I'll just create it. This is a default parameter. And if I, in my test, need to fill it with something else, I'll just put it in there, right? That's it. So one step up. This is my favorite part. Some of you like monads, some of you don't. The latter group is probably the majority. But let me tell you, you need them. So there's an interesting quote from Douglas Crockford, who, although he has a beard, doesn't do Java. He says, well, monads are amazing. They are simple things, almost trivially implemented, with enormous power to manage complexity. He also says, but understanding them is surprisingly difficult. It is. And most people, once they have that aha moment, seem to lose the ability to explain them to others. So if you think it's smart for me to try to explain it to you, it's not. So I'm not going to explain it to you, because you all know this thing, right? Do you like it? The optional? No, it's still not there, right? So, so here, what it does, basically, it takes away side effects. That is what all monads do for you. They take away side effects. So you can execute functions on something and taking away the side effects. I'll show you another example. The other example is here, right? This is, if you look at the second function, I'll try to sort of enlarge this a bit or enlighten it. This is an update function. It says this gateway by ID, and then it says then. Now then is a method on a monad called promise, which handles, as the side effect, handles asynchronous behavior. So basically waits for the previous one to get back from wherever it's coming from, and then takes the next step. And if one of those steps fails, it gets into a catch clause. And then it sort of throws, and it throws up and up and up and up. And this is really convenient. There's another monad in here. It's a really tiny one. You don't see it at first. It says, when J not as defined, reject. This is a very small monad that I built into the Easy framework that does validation on stuff. It's all. It's just about readability in this case. And it knows how to validate. So you don't have to remember how to validate that stuff. Right? So that's the point. And the nice thing is that as soon as you start looking at monads, is what they do, and I'll put a nice graphic example of it on the slide next, saying, well, all of these functions that are in there, they're basically lambdas. Each of these lambdas is, or can be, well, either a pure function, meaning it has no side effects because it just does that, or it's a really simple function, usually a one-liner, that I can test separately. So it makes testing a lot easier. So here's how monads work. And I'll try to explain it anyway, despite Douglas Crockford. So a monad is basically a box. The thing that you want to do something with, you put it inside of the box, right? Once it's inside of the box, you can send functions to it, to the box, right? And the box will handle that function on the thing that's inside of the box. It usually does a transformation of it into a different type, a different color, whatever it could be, right? While doing that, it takes away the side effect of doing that. You can do as many of these things as you like. They're usually called like map, flat map, reduce, stuff like that. Basically, an array is also sort of like a monad. And then eventually, you take the result out of the box. Now, all of the handling of these individual steps in between have been done by your monad, and they have been done in a safe way. I'll show you an example. So this is a choose class. But basically, well, there's basically two classes. There's a choose, or case, which is here, and there's a found, which inherits from case. And they're highly generic, and the only thing it does, it says, well, give me a predicate for every case, and a function that you need to execute, and a function that you need to execute in case of the predicate is true. So here's a try-catch block. An actual try-catch block, by the way, once I saw this and I put it on my slide, I replaced it by another monad called a try. And if you use this kind of stuff, it looks like this. It's saying, right, given the predicate is auth error, I need to do this. If it is an exception does not exist, then you need to do this. If it is, et cetera, et cetera, et cetera. If it's a response, you do this, and you create the following thing that comes out. And if all fails, it's basically saying, okay, you need to return this, what's underneath here. Now, what this does is all of these functions, the predicates and the functions that you execute, they could go wrong, right? And when they go wrong, they break your code. So it's the case statement that handles that takes it away. You could, by the way, build this in Java in probably less than an hour, right? And it's extremely useful, becomes really, really powerful stuff. So, think about monads for a bit. And this is, monads, when they were introduced into my life, I was in a Java project in 2014, 15, and a guy on my team came up with them, and I was like, what is this stuff, right? And we had a big team, and I was the CTO, we had like 40 people, and it was adopted by sort of half of the people and not adopted by the other half of the people. Both is okay, but the monadic code is far more robust and actually far more readable, I think, than the non-robust code. It's like for if, for if, for if, code like that, right? You lose that kind of code. Basically, if you look into the EASY framework itself, there's very little if statements in the whole framework because they've all been, well, monadized, et cetera, et cetera. So, a few more points that I need to make. Well, crap, what I'm doing now? Pressing the wrong button. You don't see that, by the way. How do I get rid of that? So, a slide deck doesn't want to go in the same direction I want to go in. Okay, there goes your touchscreen. It's stuck. That you get with this Microsoft. No. Wow, it's sort of back. Now I'm hoping that this. So we're talking about stuff that is complex, right? And stuff that is chaotic. Now, if this is your tech stack, you think I made this up, right? I didn't. This is the actual tech stack of a company I worked for. A couple of people in the room here worked for it too. So I made all the developers come up with a list of all the tech that we were using. This is it. There were 30 developers. You can never do this, right? This is just terrible. And that's what Edsger Dijkstra says. He says, well, basically, a programmer has to be able to think in terms of conceptual hierarchies that are much deeper than a single mind ever needed to face before. You get to the point that you realize that most of the stuff out there, I have no idea how it works. I've been writing code for 40 years. I still don't know everything. And it gets worse. I know little and little and little. Because the amount of stuff that you need to know to build software, it grows and it grows and it grows and it grows. And there's no point anymore in thinking that you can know it all. I used to know it all when I was writing Pascal on my little computer in my student room. That was my universe, right? But the universe is a lot bigger these days. And for you have to remember that you are on the left side of this diagram, meaning this. Meaning, this is Dave Snowden, the author of the Cynefin framework. He says, well, basically, in a chaotic context, searching for the right answers is pointless. You cannot. However, if you are in the chaotic domain, this is the best place to start innovating. And you know how you innovate? You take really small steps. You set a dot at the horizon, you take really small steps, and you start doing experiments. I'll show you what an experiment is. It's a test done in order to learn something or to discover if something works or is true. Cool, right? So you do an experiment. If it fails, well, turn again. If it succeeds, continue. That's the only way we get through this stuff. And you learn by doing. Now the problem of these, all these things that you need to know to build software, that it's too much, best comes down to looking at a collective. This is the New Cool Collective, it's a Dutch big band, and they play in all sorts of different subsets of what they're doing here, right? And they all can play their own instrument really well. They cannot play each other's instruments usually, or sometimes they can a little bit, and it's a bit like how we work in tech, right? What I see is that beyond Scrum and beyond Agile, how we defined it 20 years ago, we go into larger groups of people, because only larger groups of people have the total amount of knowledge that you need to know to build decent software. You need to little know about front end, about testing in the front end, about AWS, about the Google Cloud, about Java, about Kotlin, about running microservices, about DDD, about TDD, about everything, right? And you cannot know it all anymore. That means all the work that we do is not individual work. We're always part of a team. This is basically what I try to teach my own team, is work as a team, right? Took me about a year, and they're now completely collaborating as a team. The nice thing is that each individual item that you need to work on, each story or whatever you call it, usually can be handled by a subset of this, right? A subset of the total set of skills that you have on your total team. Well, maybe you need a front-ender or an architect. I know René doesn't like it if I put front-end next to his name, but... So the question then comes back to, again, making it smaller. And the question is, what small problem are we solving today? And if this is your only cycle in the process, you can get rid of the sprints and the retrospectives and the sprint planning meetings and the estimation thingies and the story points and whatever. You can get rid of all of it. And it really works. You can go to say, okay, this is what I do. I pick an item from the board. I'm like, this is what I want to do. Who's coming to help? And you look around the team and people say, that sounds interesting. I want to know more about this. Or I do know more about this, and I'll help you. And it could be like, whatever, configuring the load balancer with some new stuff, or it could be building a single service, it could be building some front end stuff, it could be anything, right? You just do this. You get together, you form a band, you discuss the work that you need to do, you just do it. You go through, of course, it requires really full, complete continuous delivery. You do the work, you go, you disband, and you do the same thing the next day. And the nice thing is, this model fits into most of the teams that I work with so far. And it helps you to spread the knowledge. Like, this is a developer and an ops guy. These are two developers and a QA guy. Of course, the QA guy is a stand. This is two Java developers, for instance. This is an architect and a developer. You can see it's an architect. He's praying for it to work. And this is a nice technique that I've sort of, well, let's say invented over the last 6-7 years and worked with it. And it really works really well because leadership becomes contextual. It's just that team. Where they work, when they work, whether that's from 10 in the evening till 3 in the morning, I couldn't care less. I actually say that to my team, guys. Guys, if you have to take care of your kids in the morning, do it at night. I don't care, as long as you do the work that you think you can do, right? It broadens your skill sets really, really fast, by the way. You don't need sprints anymore. You don't need estimates. Refinements, they're gone because you only do this in this really small group of 2-3 people working on this item instead of with this whole group of people who don't care shit about what you're doing. And you can work anytime you want, anywhere, right? And I recently got into a discussion about, does this stuff scale? And I'm like, I only work with small teams and small companies, so I don't know. So Marcin from ING, Marcin, are you in the room, Marcin, somewhere? Hello. He said, you're wrong. It really scales really, really well. So thank you for that. It really made my day, actually. So the last question that I want to ask you is, why did we never go to Italy? This is my mom. She's 82. My dad died 2 years ago. And for the majority of their life, they went to the same campsite for like 25, maybe 30 years. And they enjoy that. They go to the same spot on the campsite. They know the people at reception. They say, hi, good to have you back. They go to the same bars, the same restaurants. They're recognized. They like that, right? And that's really good. But when I got back from holiday from Italy, she looked at the picture and said, why didn't we never go to Italy? And I'm like, well, because you always go to the same place in France for 25 years. Yeah, she said. And that was good. So the point here is that some people do like change. That's good. Some people do not like change. That's also good, right? To build software, we need both. Or maybe there's multiple types of people. Maybe there's people that say, I only do green. I don't know. But there's different types of people, and you need all of these people on board. You cannot say, you would not want to do a project with 5 people like me. That would never succeed, right? You would build beautiful software, but it wouldn't work. And we would never finish it. I need complete finishers on my team, right? I need people who picked it up. I have a guy on my team, I call him the bezemwagen. He's great. He's amazing, actually. So you need that. But the thing is, if you do want that change, if you do want to break through, if you do want to look into, let's say, monads, or just naming things by one character instead of like, swoop, do it. Because if you want that change, there's only one person in the room who can ignite that change. I tried this once, by the way, at the local football club, and get like all these parents coming in, and I was like, I parked it the wrong way, see what happens. They all started parking it wrong. It really works, actually. But if you want to make sure, if you, in this room, want to make a change, you want to change them, you want to make it better, grow beyond the big mountain and go into more simpler code, whatever that can be for you, there's only one person to ignite that, and that is you, right? So never, ever in your life be afraid to ask the newcomer questions. Like, what does this button do? What is a template method? All the things that you're supposed to know, if you don't know them, ask, right? Doesn't matter if people think you're stupid, you're not, because you dare to ask. That is important. And then you take really small steps. And you never, ever, ever stop learning. And the most important thing is, you never forget to have fun. Well, and if all else fails, you can always remove the node modules and do an npm install. One last thing, and this is maybe the most important thing in the whole talk, is take your mother out for dinner more often. Okay, thank you all for having me. I hope you have a nice rest of the day.
Oh, wow. My key takeaway from this talk is I have to leave my beard on. It gives me credibility. Sander, thank you so much. I love the talk. And for you out there, we're going into a small break, but of course I need to make some announcements. I probably have said it before, maybe not, but you can rate talks, and you can also rate this talk. Do it, please, and also the talk that you have visited before, please rate them. Next, in room 8, there will be an extra session. It's a session from Picnic about the project they won the NLJUG Innovation Award for. We forgot to mention it before, so I'm mentioning it now. Are you still having fun? Okay, so 30% says yes, 20% is asleep, and I think there's a person over there refactoring his abstract interface working factory, whatever it was.
I'd do that.
Yeah, I think so. Again, folks, thank you. We're going into a break, and don't forget, rate sessions. See you back later.
Yeah, it's better. The code will be bigger, don't worry. I'm going to make it bigger.
Oh, that's fine.
I can make it bigger when I'm talking. I know because...
They can also switch between you and the camera or you full screen. So.
Okay.
Need anything else? Drinks are over there.
No, fine.
You have, I think, 5 or 10 minutes before we start.
Yeah.
4 minutes before we start. So then the music will go out, probably the lights will dim a bit, and then you can just get started.
Yes, it works. Thanks. Hello. Oh, okay, so you hear me now. Welcome to Cloud Native Resiliency Patterns from the ground up. Thank you very much for coming in such a high number today. I'm a bit nervous because this is my second in-person event and haven't seen a lot of people in the past year. First of all, I would like to say that on your seats probably you found a flyer. That one has a QR code on the back of it and contains access to a book that 2 of my colleagues have written. It's about modernizing Java apps. It has very useful code, it works, and please use that free book and that flyer to get your own free book.
those said, first of all, I am Anna, the nervous one. I work as a developer advocate for Red Hat. But earlier this year, I became a Java champion, and I also certified myself as an architect. I've been an architect for some time, and now I moved to a developer advocacy role. But what I like to share, the most important change that I did this year, is the fact that I moved from Romania to Netherlands. And I currently live here. This is why I was able to come in person way more easier today. And I'm very happy that you have welcomed me. And the reason why we're having this talk today is because I am a control enthusiast. That's why I went to computer science, and that's why I'm into programming and learn so many stuff. Probably like many of you, I like to control things and have things under control. So this is why we have this talk today. And first of all, let's start with what is resilience. Of course, I could give you the definition of resilience, but that is something that you find over the internet, and it's easy to be found. But in simpler words, from my point of view, resilience is that situation when an unexpected condition occurs from external of your application, so from outside of your app. Your app is going very well, is normal behavior, right? But then it turns red. It's not as normal as before. That's because an unexpected event has occurred inside your app, and your app is not behaving as normal as before. It gets into a state called faulty behavior. Now, that faulty behavior state can be somehow detected thanks to a detection control mechanism that probably you code that recognizes that malfunction. Based on that recognition of the malfunction, you can have feedback. So you can have a feedback control mechanism to mitigate that malfunction. And yes, you get into the degraded mode behavior of your system. When you're using the fallbacks and you are still having your application available and replying something to your users, but it's not exactly like the normal time. Well, until then, you are working on a degraded mode behavior, even though and the best case scenario is that your end users don't feel that. But last, there is a recovery control mechanism that you implement that restores expected behavior, the one that's normal and it's nice that we want to get to. So this is in a nutshell about resilience. Now, what can we control from resilience? Of course, we cannot control unexpected events and unexpected conditions, but what we can control as developers is these three. We can make the detection control mechanism, we can make the feedback, and we can also have control over how our application is recovering. And in today's talk, we're going to look at multiple levels on how to do that. First place, where to start. Now, I put this picture here just to scare you a little bit and to wake you up after lunch and make it bigger to be even scarier. But we're not going to start with this picture. This is like homework. You are looking at it at home when you would like to remember what I'm sharing today, because I'm going to code for you, so we don't need to look at the picture. Those being said, I will have an activity microservice that I'm going to work with today. And this is a Quarkus microservice that's very easily created from the Quarkus app. It's running with Java 17, by the way, because Java 17 is the newest version of Java, and we all love it, right? And in this service of mine, what I'm doing, I am consuming some information from a real API, which is this API, Board API. Now, the Board API, what this one has activities for the situation when you're bored. It gives you ideas what to do when you are bored. It's a free API, and it gives you a good idea what you can do, on different types, on social and on other parts. And you can even define how many participants do you want to have in those activities, and gives you information about that too. So we consume the information from this one, right? And the reason and how we consume them, well, with Quarkus is pretty simple. You define an interface, in my case, activity service, and you just give the URL to the boardapi.com, and you consume the service really nicely in an activity service interface that is annotated with register as client. So that easy. Now, it's a resiliency talk, right? So we need to fail things. Let me go here, and instead of Board API, let's use Board APIs, which doesn't exist, by the way. And yeah, let me start my app. First of all, let me check I'm Java 17. and say mvn Quarkus dev, because I firstly want to work in dev mode and see how my app is behaving. Huh. It has a problem. I don't have internet. Let me check again the internet. Ah, this one works. Then why didn't this one work? I did not expect it for this to not work. mvn Quarkus dev, come on. Weird. Let's move over this one and explain the concepts without the app, although that would have been more fun in the live mode. So, getting back to our talk, let's add some resilience to our methods that we are consuming from a third party that now is unstable, it's not existing. So the board APIs, let me get it here. Yeah, they do not exist. Cool. Those being said, let's make this thing resilient. First, what many developers would think of, let's add a circuit breaker. Yeah? And what the circuit breaker does, it's using failure ratio to know like at what percentage it should open the circuit. And we're going to say like at 75%. But it's good also to know when to at least try to close the circuit and use the real thing, right? So you need to add like a delay for that circuit to become closed again so that you can consume the real app. And I'm going to use the default here to 5 seconds. All good, right? But the thing is that when something is failing, you don't know how much time it takes for an application, the faulty endpoint, to respond to you. It can be forever, right? So to check upon that, maybe it would be good to add a timeout. And we'll put like 100 milliseconds on this one. So if the request is taking more than 100 milliseconds, the timeout annotation will throw a timeout exception. Thanks to that timeout exception, another annotation can be used, which is retry. And retry still believes that things are working. And what it does, it checks a few times that maybe your things are not as bad as they are. So max retries 4, and then let's add some delay because maybe the service will become back and available in some time. Now, again, 100. It's all good. I mean, we're now having retries, but if things are still failing, we need a way to like give an answer to our users, right? So let's use a fallback to give them at least something default, or at least to those that are, interacting with our microservice to know that something is returned, but is not as great as the real thing. And on this one, I'm going to say default basic hobby dot class, and let's create it. Create an inner class, and let's go here. But wait, Java 17, record. Let's make it record, because I'm using only here this part. So I can also declare it like this, and use a fallback handler having basic hobby. And now let's implement the default logic. And now implement methods in handle. This one is going to return a basic hobby. .empty, so an empty basic hobby. Now let me check again. Maybe this one starts. It doesn't want to. I would have loved to have seen this running and show you how it's behaving. Trying to think what I can do, because I don't have an image of it not running. And you have to take my word for it, or come by the Red Hat booth. Maybe the internet is going to work for me there better. But this is how you can do the resiliency part at the application level and make sure that you're still returning something to your end users. And now let's go back to the presentation, not the complicated thing. In other words, what I did earlier was to do the detection control, feedback control, and recovery control via the annotations. And here's the thing. Detection control is used it can be done via circuit breaker, timeout, and retry. Why? Because all these three are there to detect the faulty mode. They're there to help you with the faulty mode. Okay, retry is more like a believer that things can be better and it retries things, but it's there to help you in detection part as well. Feedback control. Now, the ones that give you feedback constantly, of course, first of all, is fallback. But you also get feedback when you're using the circuit breaker because it's looking at the part of your, it's looking at the percentage of your failure ratio, but it's also trying again, and you also get retry. And the retry is also giving you a feedback what this has tried and what has worked or not. And recovery control, of course, fallback. Fallback gives you a default until something is good is happening for your app. But circuit breaker as well, because that's one who's going to close the circuit so that your app is going to run in the normal mode, is not needing the fallback anymore. Now, this was the app level resiliency part. But what about connection issues? Because sometimes we're coding at our best the apps, but the fault is in the infrastructure or can be in the infrastructure. And you rely a lot on the network part. Now, for the connection issues, my own recipe, a big fan of Kubernetes or OpenShift in my case for today. And what I'm going to need for this one to demo to you, I'm going to use a deployment activity. I'm going to deploy an activity. And that one is labeled with V1. That's why you see here deployment activity V1. I'm going to use also another deployment called V2, same, but labeled with the 2. Both of them are accessed via the service called activity. So both of them are reachable via activity. That's it for the Kubernetes part. But to add some resilience, I added Istio because Istio is also coming with its own circuit breaker. And we're going to use that. So circuit breaker with Istio, what it means is that somebody requests something from your app, and that is being done in browser or in mobile or wherever. But that is done typically via a host name or via something more nicer than an IP, right? What happens is that thanks to a gateway config done in Istio, that request is being translated for the ingress controller. And thanks to the virtual service, that can be routed better to a service or to a deployment application deploy that can give you the best or the shortest answer, of course, if you know how to tweak things. And I'm going to show you how. And last but not least, you can choose the destination rule. And at the destination rule part, we're going to apply the circuit breaker, because at the app level and interacting with the deployment, we should add our destination rule. And those being said, let's go back to coding and hoping the internet will work. Okay, let me see if this one replies. Otherwise, if you give me a second. Okay, this one is fine. So at least I can talk to my Kubernetes/OpenShift instance. Okay, let me just place myself in the namespace activity. OC project activity is just the same thing as setting the current context to the namespace activity. And let's look at what we have to do. So first of all, we need to deploy the apps, right? And first of all, we're going to see the app without the circuit breaker pattern, what's happening. And I have my deployments. Let's add them here. First of all, I'm going to deploy the backend V2. And this one is deploying a deployment and a service account. Now let's add V1. And V1, it has also the service part. So I was a little bit lazy, and I didn't want to, do it separately. By the way, if you're worried about the route, don't worry. Besides the route, you found in the GitHub an ingress specification so that you can use it in Minikube as well. And next, I need to create the gateway, right? Let me clear this and make this bigger. So the gateway, it's going to interact, and it's going to interact with the internet, right? And it's going to do the awesome stuff. And next, what I need the place to enter the gateway. And let me show you why I'm coding the gateway, because it looks this big, and I cannot remember this kind of stuff. Next thing, let's deploy the destination rule. And the first destination rule without circuit breaker pattern applied at Istio level is available here in K8s. And it's very simple. So what this says is like, okay, if you're coming on the host activity for this service, so what you have to know is that for the host activity, there are two subsets that you can select as destinations for your request. The version 1, the one that has label version v1, which our first deployment, the deployment v1 of the activity. And there's version 2 of it, but in Istio, we're proxying it with different names. And you can give whatever name you like it here, as long as you remember how to use them in the rest of the configuration. So this one was the first one that we're going to deploy, and nothing fancy for the moment. And there's also a default virtual service, not the timeout, this one. And this one is just saying on anything, use the gateway, activity gateway that you deployed earlier. But if you find the /activity prefix, go to this port number, search for the destination activity, and so on. Simple as that. Let's go with it. Clear this. And now let's simulate how 4 concurrent users would send their 10 requests to an endpoint that is throwing timeout. So now the concurrent users are happening. I'm using a tool called Siege that's preparing the users for me. And this will take a while to be done. But I want to show you the entire process and how things are failing. So first of all, this endpoint timeout is throwing a 504. I coded specifically like that in here to throw a 504, yeah, on gateway timeout, although it returns some information. And we need to let it do the magic. Hopefully it's not going to take longer. And while we wait, okay, so it's done. What we need to know is like elapsed time, so the time for my requests was very big, it was like 53.65 seconds. Okay, everything failed, bad. And the longest transaction was at 7.49 seconds, so it took kind of time to do that. Now let's fix this by adding the circuit breaker destination rule that has a way to handle the max pending requests when things are failing. It allows max for concurrent connections. And if there's a max request per connection to a container to read to 1, it will throw a 503. So let's do this one, and I'm using this part here with simulating. I'm just copying from this one so you know how to replace it and for your own examples. Let me clear. And do again the same siege. But you can see that in the last time the requests were, this one fails too, it was a 503 because it's timeout. But last time the requests were like 5 seconds, 7 seconds, we're taking a lot of time. And the idea is at least to fail fast when you are failing, not to wait a long time and things not to go great. Okay, the longest transaction took 12 seconds. That's not good. But the total time for the entire transactions were failed, true, was 21 seconds. So this means that when you're applying the circuit breaker, it can help you in failing faster, and you can detect things and when they're not working as expected way faster than without it. That's the story behind it. Now, going back to the slides, I showed you how these things are working. But what I invoked in my siege was something, a special case. Another special case that I want to talk to you now is about load shedding. And according to Site Reliability Engineering book, load shedding is that practice that is dropping some proportion of the load, meaning it's helping your load by dropping traffic as your server is cannot handle anymore the situation that's going over there. There are too many requests. And right now when you see drop, you're kind of thinking, so what we're doing to our users, we're dropping their requests. Well, not necessarily. And I want to talk to you about a technique that you can apply at application level, so Java application level, by the way, with a nice library called Bucket4J. That is using token bucket algorithm. And this is what's depicted here in the picture. So what this says is that you have a bucket that allows requests. That has a size B, its capacity is B. When an incoming request is coming, that incoming request gets into the bucket and is compared, so the bucket size compared to the incoming request is not bigger than the bucket. Then the request of the user is being served. If not, if the bucket is full, then you should drop, prioritize, or send with low priority. The idea of dropping is like a last case scenario. Dropping probably is the easiest thing, but I would advise on prioritizing or sending with a lower priority, and there are techniques on how to do that. We'll show it to you in a second. And there's another thing that you should know, that there's a refill rate. So once your bucket is full, you can refill your bucket. And when you should the duration to refill your bucket is given by the size of your bucket over the refill rate. So added some math to this so that you would know where things are coming, or when you're wondering how to do this on your own, this is the math behind it. And now that we are done with the rate limiting part in the slides, let me show you how that works at Java level. So let me go to the random hobby resource, make it bigger, and I first initialized my bucket. So I had the Bucket4J dependency added to my app, and I initialized my bucket. Now, before giving, I put my bucket as a field, sorry. I didn't initialize it yet. But I also need to give a limit for my bucket, and I can do that with bandwidth. Now, the bandwidth, what it does, it adds some limits to your buckets. It's the one that's looking over the capacity and the refill. And what I said here is like, hey, the limit for my bucket is as follows. It has capacity to 20. And refill it with the greedy algorithm for it. There are more algorithms, by the way, to refill the bucket. And refill it with 20 tokens when the duration of 1 minute expires. So what this means, if like 20 requests are sent in a minute, they will be in your bucket. But when 21 is coming, it will say bucket full. So now let's uncomment this part and add our limit. I'm on you nervous. Add limit, and let's add the limit. A nice feature of Bucket4J is that you can add multiple limits for your bucket to evolve. So you can have multiple of these and just continuously add them and to refine your bucket. But for today, I just wanted to use this one as example. Now let's code the bucket at the limited response. Now this one returns 200 OK, but I wanted to use the token bucket algorithm. So what I do, I'm instantiating a consumption probe that is actually checking. Is returned by the checking of on the bucket. So if I'm trying to serve this request, I'm trying to consume it, and then I'm trying to also return the remaining size of my bucket. Now, if my bucket is not full, this means probe dot is consumed, then return the remaining tokens. And the way to do that elegantly, because you're not putting that on your answer to the people, but you need to signal that to other apps, is by adding a header. You can add the header x-rate limit remaining, and you get on this one probe.get remaining tokens. Now that's the part for the good moment. But what if the bucket is full? Well, if the bucket is full, you need to wait some time to refill the bucket. But also it would be good to return something to your users and also say to those that consume you in another status that you should return and at the rate that they should retry later. So you warn them like, hey, retry later, because this is the amount of time you should wait for the bucket to be refilled. By the way, this library works very well with Spring Boot. There's already something done there to work seamlessly as well. So this is the part for the bucket. Now, how do you test this? Well, that's easy. I made a test. So I have the test limited cached endpoint that is running 20 requests. And on those 20 requests, my expectation is that, okay, everything will be fine. So the header that I receive is to X-rate limit remaining. But when my 21 gets done, 429 is being thrown, and it says retry after several seconds. Now, I need to know if this one is not run. Maybe it will do this. MVN test. It doesn't work anymore. What's wrong with you? Anyway, we'll check about it. But please do check out the repo. I'll share it at the end. It works, trust me. It's just a simple unit test. So this is about rate limiting at the application level. But how about concurrency control? So there's another way to apply load shedding. You can do it at the infrastructure level most of the time with a proxy. And there are several proxies that you can use for concurrency control. That's HA proxy that OpenShift has as well in order to have this better concurrency control. There's also Nginx, if you're using it as a proxy. Or you can have Envoy, for example. That one has very nice adaptive concurrency control in it, which is very nice. But in our case, I'm just going to use a very simple situation with concurrency control via Istio. So what I did, I'm going to use a destination rule and a virtual service, but in the virtual service, I will assign a priority for the requests that are coming from Safari, for example. That's something that can be done. So it's a nice way to prioritize your requests. The simplest way to prioritize requests is via the browser that those are being sent. There's one way of doing this for the limits. And now, and thanks to that, the priority, if I'm not mistaken, it will share that always will go to the version 2 of it. So let's apply that. By the way, you find the priority example in here. And first of all, I'm getting back with my destination rule to a simple destination rule, no circuit breaker. Okay, clear. And let's apply also the virtual service for Safari. This one is very, very easy. It has the filtering based on baggage user agent. If it contains Safari, then do this. And of course, it will say if any request is coming on V1, just route it to V2. So let me here, clear. And now instead of Siege, I'm going to use curl because I want to show you something visually. Okay, let me get this one. Okay. And opening this in Kiali, traffic animation should be working soon. It will show you how things are routed. Hope the internet is going to help me. Better. So you can see here that when requests are coming, they're all the time routed to the version 2. Because they're coming, by the way, the requests are coming from Safari. If I was too fast with my curl, it has a -a Safari in it. So that's how I say the agent is Safari. So that's how it knows how to route it and how to put it. And Kiali is very nice for visualizing how your network is behaving at some point in time. I really like this part of the animation. And especially when learning different patterns, how they work, it's good to visualize it with this. Depending on time, I think I can show you also how you can see it in Grafana, how you can see the workload in Grafana, and yeah, I also have configured that. So this is pretty much the part of routing when you are trying to assign request priority, and you're using the browser that you're using, that the person that's invoking to access the endpoints. Now let me end the joy here, because it was enough and go back to the presentation. So how about auto-scaling? Because some of you probably thought like, hey, but if it's a lot of workload, why can't I apply auto-scaling? It just scales things for me. If it's a lot of workload, it's all good. Well, auto-scaling on itself is good, but doesn't solve all your problem. What you can do is to interplay auto-scaling and load shedding. And how we can do that? So assuming that you have an auto-scaling condition, so this is the sign for auto-scaling in my picture, you're having requests coming. It's fine. Now the workload is increasing, and you can see it gets closer to the line of auto-scaling. But thanks to load shedding, the stress over the system is reduced. This is good. Now, load shedding stops at some point when things are going normal, right? Because it seems that the stress is reduced, so the system doesn't need to apply load shedding all the time. What you need to do is like check if the increased traffic is continuing. So that's the moment, so when the load shedding stops, you need to try to see, hey, is this traffic load still going on? Because if it does, that's when you should trigger the auto-scaling part. And that's when you should do it, because if something is going on continuously, like putting a lot of effort on your system, it's not enough just dropping some things and making an economy on the short term. You would be needing to think on the long term if your workload is applied continuously. If not, then you're happy, you're in a good place, you don't need to worry about your system got back to normal, you just solved your problems with load shedding. That was enough. Now, last thing that I want to show to you is how to fall back with Scooper. What's Scooper? So, it's my new best friend and the thing that I'm having fun with. Now, Scooper is there to help you with multi-cloud communication for Kubernetes. But it can also work in your same cluster. It works across namespaces as well. And that's how I used it in my example, so that everybody can reproduce this at home. And it's very easy to install, and they're easy to manipulate. Unlike Istio that requires a little bit more things to do in order to install their stuff, this one is much more easier to work with. The reason being is because, well, it's a little bit lighter, but Istio has its advantages in terms of control. And with Scooper, I have some examples. Let me see. I think I can do it myself. So this is the Scooper setup that I gave you. I have 3 namespaces. The first one is Benelux, the second one is CE, the third one is UKI. Now, what I did in my Benelux, I have deployed the backend Benelux, the one that I used earlier as well. I annotated my service with activity and the activity service with Scooper.io proxy HTTP. And what I did further is like to put my front end and, well, init the console of Scooper. I did similar things and also generated the token in this one, like saying, hey, this will be my primary place where I want to interact with this application. It has a front end and a back end, and I want to interact when I'm in Benelux. But maybe my back end is not all the time reliable. And it's good to have a fallback at another level. So this is why I moved myself also to another namespace called CE, installed backend there too, annotated it, and simply with Scooper I did Scooper init, and I've used the token earlier to tell that, hey, this namespace should be bounded to the other one from network point of view for load balancing purposes and also for fallback. And last but not least, I have done the same thing for namespace UKI. You can do this for as many as you want, as long as you use these simple commands. So it's way easier to deploy it and to interact with it. So let's see its magic. I need to find where my app is. So my front end is, of course, in Benelux. And I need to get this route. First of all, let me show you how Scooper console is looking like. So this is my Scooper console, and it has a nice view to see the graphic. And you can see that my deployment. So I have my hobby front end. that gets information from my activity backend from Benelux. It also gets information from CE, if this one replies faster, and also from UKI, if this one replies faster, or this one is at fault. And we're going to try 2 different scenarios. Which one you want to see first? Like kill things, or so who's for killing things? I like that. Okay, so let's kill things. But first, let me open the route for hobby. Oh, come on. Oh yeah, hobby. I scaled it to 0, sorry, before the talk. No. Sorry, before the talk, I scaled to 0 my front end. And I'm scaling it to 1 now. I killed everything. So, okay, let's destroy and scale to 0 the pod that's for the backend from Benelux. And, okay, let's try the route here for front end. And let's send some requests, depending on how internet is working. So you see that I'm getting responses from CE and UKI. These are the workers from CE and UKI for the backend, all the time. Okay. Good. Let me see. I know how they stop. I don't know how many times I clicked this. But we want to like put things to die to a little bit more, right? I think I clicked 8 times. So now it's to 8. Okay. Now let me go to the one in CEE. I'm going alphabetically, and put this to 0 as well. So I'm now relying only on the backend that's on the UKI, if I'm not mistaken. If I'm looking to Scooper, the console gives me informations as well. This one didn't change, 13 requests, it was before, this one changed, and yeah, it can tell you where the load was. Let me go now here, and C is at 8, right? So now when I'm sending requests, it should only go to UKI, and you see the only UKI is becoming and growing bigger because it's the only one that is giving you answers. Now this is for the fallback part, and that's on the slides. Now let's scale things to 1. Because Scooper can be also used for load balancing. And I want to show that to you as well. Come on, internet. Do not fail me, okay. Not activity, okay, good. Scale me to 1, okay. Now things should be back to normal. And let's balance things. So now when I'm sending the requests, Scooper is going to choose where it's sending it. And you can now see that it's serving from the closest, from Benelux, for example, or when it's feeling like it's serving from the rest. So it's balancing the request across these namespaces. And imagine that done at cluster level and across multiple cloud providers. Really reliable, right? And just with some simple configurations. And it's very secure, by the way. It works with certificates. I mean, in my example, I keep it at minimum, but it works with certificates as well, and it can even go a little bit more secure than just this simple example. So this is for load balancing with Scooper. Also, the example is provided in its repo. And let's make this bigger and to explain what happened earlier when we were like lowering down the pods and there was just one backend responding at some point. And I kept this only for 2 namespaces because, I mean, adding the third one, it would have made it even more complex. So what it did is that when I sent a request, my frontend received it and said, hey, get me an activity. But Scooper was the one that's like talking and proxying the backend and says, hey, I'm trying to get this from Benelux because it's the closest one. The backend from Benelux is the closest one. But there's a connection issue. Our pod was like scaled to 0. There was nothing there. Scooper sees this and speaks to the initialized Scooper from the CE namespace and says, hey, do you have something for me? Maybe your backend works. And this backend, in this case, it works. In our case, it didn't. I scaled it to 0, and it went even farther to UKI namespace. A response was sent, and the response was sent, and the response was sent, and the front end got a response. So this is how Scooper is proxying things for you, so you can get something regardless if something has failed and is not working anymore. And as I said, I kept this simple for the level of the two namespaces, so it doesn't become or grow a little bit more complex than that. Before saying thank you and everything, in my setup, that's done in OpenShift, but I've depicted a similar setup for Minikube as well. I tried it myself. What I want to show to you for the part with Istio is that in my setup that I have for Kiali and so on, let me go to Istio system. Okay, and go to routes. I have also Grafana. So when installing the service mesh here, I have Grafana and Istio, and I'm able to get some defaults about my workload and how my workload behaved, regardless if I know how to do Grafana charts or not. Before experiencing with this one, I was doing my own charts, and I'm still doing my own charts sometimes. But the thing is that you can see here different workloads, how they behaved. And I think it's easier to see how they behave in the last 30 minutes and what was the success rate on each workload. So the part with the infrastructure and Istio and so on, it plays and interplays really nice with all these tools, and it gives you a good control over what's going on with your app. And you can see also the traffic, how the requests generated, and so on. So it was not just me doing requests from my local, but they are also monitored in Grafana and seen there and observed there. Now, first of all, thank you. The code is available on GitHub in the resilience repository. It's all documented there, all the steps and everything. It's a little bit more on the Istio side, but I hope you would like to play with that one as well. And of course, if you scan this, you get the slides that also get you something like this. So you get 2 more free books that you can download. One for about Istio and one is Quarkus for Spring developers. If you're like a Spring developer and you'd like to get to know how Quarkus can help you, please read that one. By the way, both of the books are really short and concise. Thank you very much for listening to me. And if you have any question, I'm welcoming those questions right now. Not sure if there's a microphone or you're just shouting the question. Thank you. Okay. Yep, sure. Can you speak louder?
Yeah. And this is my first JFold, my first time in the Netherlands. I love what I have seen so far. And I love that we are back here in person. So, before I actually start, let me ask a few questions to the audience. Who here is working on DevOps? I see some hands. Okay, like half of the audience. Who here has heard about the left shift movement? A few hands. Well, this means that you as developers are going to take care of more responsibilities than before. So, and some of those responsibilities may be involved with the release process of your project or something related to that. So the idea of the tool that I'm going to demonstrate today is to help you when you have to release a project or when you have to release binaries. So my name is Andres Almeray. I'm currently employed by Oracle. And one of the things that I do on my current job is talk about the different open source projects and products that we have in the database. That is something that happens. We allow you to run the Oracle database on test containers for free as something that just you can do at any point in time. And like that, there are other things that we can have. But today, I'm going to talk about a project that is fully open source that is not currently related to my employer. So I will give you a quick or a brief introduction of why this tool came to be, the reason of being, and then we jump into how the tool works, what it can do for you, and then we will have a demo, hopefully it will work, and then we close with what the tool may be able to do in the future. Now, because of the nature of the room, if you have any questions, please feel free to ask them at any time, and I'll just repeat it for the recording. Or if you want, you can ask them later, or we'll just figure out how we do it. Okay? So, as a developer, one of the things that I like to do is build applications, desktop applications to be precise. This is something I've been doing for many, many years. First, I did it with Swing, and nowadays I do it with JavaFX. And just like any other engineer, once I'm done building my application, I craft a binary, I craft a distribution, and I just put it on a web page. And I hope that someone will find it, a user will discover that binary and make use of it. Or at least that's the way that I myself, as a regular software engineer, will look at these things. Hey, something is produced, and eventually someone will find it. But as it turns out, our users will prefer other ways to consume the projects or to consume the binaries. So if you are on a Mac, you might prefer to use a package or a platform packager such as Homebrew. If you're on Linux, then probably it will be something like a Snapcraft or Flatpak. Or if you're on Windows, it might be Winget or Scoop, Chocolate. There are so many choices. The point is that in order to make this work, as a producer of the project, as a producer of the binary, I need to be aware of the specific file format required for that particular package manager. Sometimes it's just a text file, maybe it's YAML, maybe it's JSON. For Homebrew, it's a Ruby formula. And if you figure it out once, then you know how to do it more times. But as you continue to do releases, you will probably would like to find a way to make things much more automated. And conversely, our users would like to consume more information about your project, such as release notes, perhaps, a changelog. They will probably would like to find, if your project happens to be open source, they would like to find what is the tag that is attached to that project, some additional metadata, right? So that was me a couple of years ago, trying to push out a particular desktop application that I wrote. And I had all these questions, and I didn't have all the answers. So I put a pause on that and started working on something else. And as an inspiration, I looked at two other projects. Even though I love Java and I work with Java almost every single day of my life, I also write code in other languages. And one of those languages happens to be Go. So I wrote, like a year ago, a small command line utility that will allow you to launch Maven or Gradle, if you're into that, with its command line or with its wrapper. And you will be able to launch the build from anywhere within the project, not just at the root. So I wrote that in Go because, well, I wanted to learn the Go programming language. And I faced the same problem. So I now have a command line utility, and I need a way to build it and to distribute it to many different uses. So I discovered a tool called Go Releaser, which allows me to do this. And it's not just that. You also calculate checksums for the input files. It can sign files using PGP. It can do many things. So when I saw that tool, I said to myself, this is what I want for my Java project. I really want to make use of this. But sadly, it only works for Go projects. Almost at the same time, I discovered JBank from Max Anderson. And JBank is a CLI tool that allows you to launch a single source Java file like a JShell, but you can define dependencies. So it's kind of like a Java script that is self-contained, and it has more other things. So one of the things that Max did very early on was make sure that once he has produced the binary for JBank, that he will also be able to publish it to many different distribution channels. Again, Homebrew, Chocolatey, Docker images, so many things. So one day, he and I were talking, and he told me that he has spent a lot of time doing all these things, automating these things with scripts and Gradle and Bash and so many things, just to make it work with JBank. And I said to him, well, I just built the same thing, the same ideas with Go Releaser for my Go project. And then it dawned on us, what if there was a tool that did like the things like Go Releaser did, but for Java projects? What if this tool were to learn from all the lessons that Max did or applied for JBank, but could also be done for any projects? Because if you were to look at how JBank does its thing, it only does it for its project. If you want to reuse that knowledge, you have to copy and paste a lot of code, and that, of course, is not going to scale. So that's how, my friends, this tool came out to be. This is what is known as JReleaser. So what it is, basically, you keep using the build tool that you use already, be it Maven or Ant or Gradle or what have you. You keep producing those binaries and those releases, and you supply those as inputs plus an additional file, an additional metadata file that describes what you want to do with this project. Those you supply to the JReleaser tool, and in turn, JReleaser can create a Git release for you, be it on GitHub or GitLab or other Git services. It can also create those platform packages, Homebrew, Snapcraft, Chocolatey, and additionally, it can also announce a release to many distribution channels. Perhaps the most popular one could be Twitter or Slack or even SDKman. So how does it do it? So JReleaser started life as a simple file template engine, because what we saw at the beginning is that, oh, you need to publish to Homebrew, you have to create a Ruby formula. Based it on a file template, you just substitute some variables such as the URL, the version number, the name of the application, and off you go. And the same will happen with the other platform packages. But then it started to grow more like that. If you were to have a look at Go Releaser, it is a single command, and it does everything for you in one go. It's just one package itself. Whereas in JReleaser, we figured out that if you want to do that, then you use the orange command, the one that you see on the top, that's full release. That does everything for you. Create the Git release, create the package managers, and announce the project. But if you already have a release process, and you only need to change a few things, say you want to keep the current way that you create a Git release, keep it. But if you want to add package managers, then JReleaser can do that for you, and then just invoke that particular set of commands. Or you want to create a Git release, you don't care about the packages, and you want to announce, then you can also do mix and match of all these different commands. So what you see in these columns are all the different options that you have at your disposal. You can invoke them in one go, or each one is separate from one another. I said earlier that JReleaser will expect your binaries to be built with your standard build tools, the ones I use right now. But if you would like to build, let's say, native executables using GraalVM's native image, you can do so with JReleaser. If you're building a Spring Boot application or Micronaut or Quarkus or Helidon or some other framework that already provides a GraalVM native image support, keep using that. If you're building a project that does not have that yet, JReleaser can help you building those executables. The other thing that it can do for you is build custom Java runtimes with JLink. This is regardless if your application is modular or not, because for J-Link, this is just a matter of shrinking down the Java runtime into its smallest pieces so that you can run a particular application. One more thing that I discovered when I was building this thing is that J-Link allows you to build cross-platform Java runtimes. So if I have a machine like this one on a Mac, I can build a Java runtime for Linux, or a runtime for Windows, or for any other JDK that I have access to. And that is one of the settings that JReleaser supports. You want a J-Link for this machine? Go ahead. You want a J-Link cross-platform Java runtime for all kinds of JDKs? Go ahead in the same place. OK, I already mentioned a few names, but this is the full list of integrations that we have. If you are releasing to GitHub, then you can use the tool. And it also works for commercial products or closed source products because it just happens to be GitHub. So whether it's a public repository or a private repository, or even if you're using GitHub Enterprise, this tool will also work. Same goes with GitLab, public, private repositories, or GitLab Enterprise. Or if you're using Gitya or Codeberg, which are also other different Git services. If you happen to be using another Git service that is not in this list right now, you can still use the tool. You will be able to tag the repository, but you won't be able to release because there is not yet API integration with that particular service. Now, besides uploading binaries, if you have them, to a Git release, you can also upload it to JFrog Artifactory. You can upload it to an HTTP or HTTPS server that is under your control, or you can also upload it to an Amazon S3 bucket. In terms of package managers, well, that's the full list. Homebrew for Linux and Mac, Chocolatey for Windows, Docker, we can build Docker images for you. JBank also allows you to launch jars across the network. Scoop is like Homebrew, but for Windows. SDKman is perhaps the way that will recommend you to keep your JDK installations up to date and other projects and other packages, such as JReleaser as well. And Snackcraft works for Linux. And in terms of distribution channels or announcers, well, we have a big list, and Telegram was the last one that we just added recently. So in terms of inputs that you supply, these are the things that you build. These are the inputs that we support. It could be a binary distribution, which is typically packaged as a zip file or a tar file. The file structure is already given, so it is expected to have a bin directory with the executable or the launcher script. There may be a lib directory when you find all the jars and any supporting files, such as the license or README, config files, you name it, right? You can build these kind of distributions with Maven. There is the app assembler plugin or the assembly plugin. There is a Gradle plugin for this, and we also provide an archive assembler because now is a good time to say that even though we're talking about Java, if you're building or someone else is building an executable with other languages, for example, Rust, you can use JReleaser to release that kind of binaries. We also support the Uber jar or the fat jar, which you know is a single jar, maybe executable that contains all dependencies. For obvious reasons, we can also release a J-Link distribution because JReleaser can assemble those. For the same token, GraalVM native images distributions. And finally, native packagers or native installers. So these are the ones that you create using JPackage, for example, or you can create it in many other different ways. In the case of Mac, that will be a DMG file or a PKG. For Windows, it's an MSI or an XE. And for Linux, it will be a div or an RPM file. So we support many different options. How would you launch such a tool? Well, depending on your platform. If you're on Mac, then use SDKman and install JReleaser. That will allow you to switch very easily from many different versions. Or you can use JBank and launch the latest version of JReleaser, or you can also launch the latest snapshot. Or you can use Homebrew, of course, because you're on a Mac. And if none of these options are your fancy, then you can go to the release page for a particular version and download either of these two zip files. The first one is universal, so for which you require a particular version of Java. So don't worry, it works with Java 8 and upwards. And the next option, the standalone zip file, this is a cross-platform Java runtime generated with JLink. So it comes with batteries included. You don't need a pre-existing Java version already installed in your computer, and then just off you go. For Linux, they're pretty much the same options, SDK-man, JBank, Homebrew, or download a zip file, for which the standalone version has two flavors. One, what is compiled with Ubuntu compatible platforms, I would say. This is a JDK that is compiled with glibc, and the other is compiled with Muscle. So this is the things that you will run if you are using Linux Alpine. Finally, on Windows, SDK-man, JBank, Scoop instead of Homebrew, and of course, download a particular zip file for your platform. You also have the choice to use a very simple Java source file as if it were a script. This particular source file will download a particular version of JReleaser on your computer. It's a single jar that you need Java 11 to run this, and then just pass the parameters, and off you go. Or you can also run it from Docker, for which we provide two different images. One is for, again, based on Ubuntu, and the other one is based on Linux Alpine. So far, I have mentioned all the ways that you can run the tool as a CLI tool. But we also support running the tool as a Maven plugin, or as a Gradle plugin, or as a set of end tasks. So we cover a wide range of different options. And of course, you can run these tools on your local machine, or you can run it on CI. You can use any of these services. We have guides that let you know how you can configure the tool to post a release of any of these CI/CD options. We have explicit support for GitHub Actions. There is a release action that can use the external configuration file, and the Docker images that we produce are already aware of the specifics for running within GitLab CI. So there's no need for you to create yet another Docker image to run JReleaser properly inside GitLab CI. OK, so that's the theory. Let's jump into the demo. So here we go. So what I have here is a very simple Maven project. It's a Maven CLI application that I just built with regular Maven, and then assemble it using the app assembler plugin and the assembly plugin. Nothing more, nothing really fancy. And the only thing that this does, if I run it, it will print out hello world, because we are very friendly. The other thing that this application has is, besides just 11 commits, is a really trivial application. If I make it a bit bigger, you can see that the names or the titles of the commits follow a particular set of prefixes, so sure or fix or fit. Now, this is a specific for the project, has nothing to do with JReleaser. But if I follow these conventions that I set forward, then JReleaser can do better stuff for us in the future. So what I'm going to do now, if we go back here at the top of the application, we see that there are no tags and there are no releases. So the first thing I'm going to try is create a release from my local machine. So let's see how this works. First, I need to know which version of JReleaser I have. And for that, I said I prefer to use SDK-man. So I can ask SDK-man for listing what are the current versions of JReleaser that you have access to. We have 8 releases so far, and I'm currently working on the latest snapshot. So we're going to use version 8. We can check that is true. JReleaser-b. Oh, that is not the command I want to use. JReleaser, typo. Now we go, and it tells us the metadata. So yes, this is the correct thing. Go right. Another thing, here are the sources of the project. There is no target directory. That means that there are no binaries yet. There's nothing, just the Maven POM and the Java sources. And even though there is a JReleaser YAML file there, this is the extra configuration file, we are not going to use it for now. One more thing, if I list the current remote of my Git repository, it matches the URL that I showed on the browser. OK, so that's everything that we need to know now. I'm going to ask JReleaser to create a release. And because I don't want to provide yet the model, I'm going to tell it, do auto-configure yourself. based on the metadata on the existing directory. And if there happen to be any additional environmental variables, then I will take those into consideration. So for now, it's simply say do autoconfig, and that will read the Git metadata and everything else. But I also want to say I want to release version 1.0. So here we go. We do enter, and then we see now a little bit of output on the tool with some metadata on the project. It says something like generating a changelog, then says something like calculating checksums, but it didn't find anything because there are no input files. It tried to sign some files, but we didn't configure signatures, and of course, there are, again, no input files. Then it says something like try to upload. Upload is not enabled because I don't have, again, any input files. And finally, it creates a Git release in this particular URL. So we go back to the browser and do a refresh here. And now we have a tag, and we have a release. The name of the release matches a particular conversion. The tag is v100, so we follow semantic versioning. But if your project follows any other numbering schemes, we also support them. The v prefix is optional, so you can use any other prefixes or no prefixes at all. And we get all the commits as part of the changelog, and no assets. Nothing there. So far, so good. Now, you might be wondering, Andres, you just push a release to GitHub. In order to do that, you need some credentials. You need a GitHub token. Well, yes, I have a GitHub token, and it's found at this location. It's a TOML file, but it could be YAML or it could be JSON. This is the default place, but it could be any other place. You can configure it. And I'm not going to show it because it has plenty of secret configuration there. But trust me, this is where I store my GitHub token. So let me do one more thing. I'm going to format the changelog. And so I'm going to pass in additional configuration. And if I do this, I will get a failure. Care to know why? Because I already have release 1.0.0. I'm not going to re-release it or override it or drop it unless you tell the tool to do so. Well, let's do that. We say override, and there we go. It works in just a second. Thank you, Internet. So we do a refresh, and notice that now it looks a little bit different, and I have the names of the contributors. At least, well, it's only me for now. We can do better. So we can build the project now, ask Maven to build it, and that invokes Maven, and eventually we get the tar file and the C file. These are the binaries I want to release. And I can tell JReleaser to do it again. Oh, I'm going to supply an input file that will be found in distributions app zip1, I believe. And there we go. And notice that this time it's calculating a checksum for that input file. I did not configure signing, so it skips that. And I'm not configuring publication to JFrog, Artifactory, or Amazon. That's what is skipping the upload. But you notice that now, as part of the release, we got that zip file as an asset and the checksum. So when we do a refresh here, the change will look exactly the same, but now we got those two assets. All right. And we can keep doing this. We can add as many files as you want to. But if you start to see that, well, there's so many options that you add in the command line, it's better that we switch into defining the project using the model. And that's the thing that I'm going to showcase next. So here's the model. Contains some metadata, some section on the project, like the name of the project, the URL, the license, authors. This information comes very handy when I want to create those platform packages as Homebrew, as Snapcraft, and the others. Then we see this block, release, and we want to release to GitHub. So that's what we have listed there. Also notice that now we're saying override equals true, so I don't have to set it on the command line. And I also want to sign, so that will sign commits and tags that I make. And I want to link this release to a discussion category, which by default happens to be announcements. And the rest of the configuration that I see here is reusing or taking advantage of those prefixes that I defined earlier on my commits. So for every commit title that matches a prefix like fifth colon or fixed colon or chore column, then I'm going to give it a label. And using those labels, I'm going to put them into some categories. And finally, with the replacers, I'm going to remove those prefixes because their default replacement is an empty string. Also, I want to sign all the input files, and I'm going to generate a homebrew formula, and I'm going to define my two different input files, the zip file and the tar file. As you notice this wonky syntax, you might have seen them before if you're a front-end or full stack developer. These are mustache templates. So you can think of this as a variable within your format. And then the value of this variable will be evaluated to the name of distribution, so that will be app. And the project version will be whatever number you have for your current release. OK, so now that we have that, I'm going to do one more thing, because if you noticed, there was no project version in that metadata file. I can show it here on the top. I could have added version here, but I'm not. So that if I define the version number as an environmental variable, my model file will become stable, and I just have to switch the version number in using the environment. So I'm going to export this, going to export an environmental variable that has to follow this particular name. That should be JReleaser project version, and the version number will be 100. And the next thing I'm going to do is do JReleaser full release. So here we go. No more auto configuration. You see that, again, the checksums are taken into account. And I'm also signing files. And there comes the uploading of all those assets, and then the creation of a homebrew formula for which is going to be placed on GitHub, because that's where my current project is hosted, and added to that particular repository, which will be created automatically for you based on certain conventions if it's not there yet. OK, so I can go back here and do a refresh. Now look, my change looks different. Now has emojis, has categories. There are no prefixes. They are all categorized. They look much better. I also am able to put the username of the contributors, and I have all the different assets, the binaries, the checksums, and the signatures. Look here. There is a button that says Join Discussion. Let's click on that one. And now, that moves me into Discussion tab of my project, and I can see the whole text of the project, and anyone can make any comments on the project. So this is how easy it is to create Git releases with metadata on your project. And as you saw, I just did it for my local environment. I did not have to do this on CI. But you can certainly do so, because JReleaser runs on pretty much all the CI options that I show you. So if you are into GitHub, well, I guess this is nice. But if you happen to be using other Git services, such as GitLab, well, the good news is that we support that as well. So surprise, surprise, it's the same project, but with a few changes. So let me switch to that directory. And you see here, trust me, they are the same sources. We can build the project, invoke Maven once again, and that runs the build. OK, perfect. And the model has two changes. The first one, as you see in line 16, we're going to release to GitLab. And the second one is that GitLab is not aware of any discussions. That's a GitHub-only feature. So we take it out. The rest of the file is identical to creating releases to GitHub. So now we do that. I just scroll in the history so you can tell that I'm using the same command as before, and do a full release. And this will calculate the checksums, do the signings, create a release, upload the assets, and create a homebrew formula for you. But this time on GitLab. And while this is working, you can tell here that there are no tags, right? So while that is working, I can show you on GitHub the homebrew formula that we created. So we go into the homebrew tab directory, formula, which was just updated 3 minutes ago, and we see a file based on a template. This is a template that already is provided by JReleaser, but you can provide your own templates as well if this is not good enough. there is an URL that points to GitHub and the checksum for that particular file. So that will come in handy in just a moment. We go back here on GitLab and do a refresh, and take a look here on the number of tags that will appear. Now, there is one tag, and I click on the tag, there's a release. I click on the release, and there are the release assets and the changelog that looks very much identical to what we saw on GitHub. And because we publish a Homebrew formula, we'll find it on the Homebrew tab repository. And there's the formula updated just a moment ago. And just like on GitHub, it's based on the same template, but two differences, the URL and the checksum. I'm not done yet. I can also do it for Gitya or Codeberg. Same project, no releases, but two changes in this case. Actually, let's make one more change. So let's edit JReleaser. And we see that now we are releasing to Codeberg. There are no discussions, because again, Gitya has no notion of discussions. But I'm not going to make an announcement. And now, besides announcing to my local Twitter, my local Discord, I'm going to be very bold and do a live tweet on JFall. So let's activate this always, right? And now I'm going to say something like status will be release and project version. Or actually, yeah, project version of project name. That is not the correct one, so it's sensitive, case sensitive. And then I say add JFall 2021. Okay. I think it's okay. Well, maybe I can put this into quotes just to be extra safe. And to be sure that this is going to work, I can also display what is the current model. What does JReleaser would look like if I were to run this? There's no build, so let's build it. It needs the artifact. So at least JReleaser will tell me, oh, you're trying to release something, but it's not there yet. So maybe if you build it, I will be able to read it. All right. So here we go. Here's the model. And that tells me that that's all the information that is going to be applied when generating the Homebrew formula. And those are the two artifacts that I want to release. Yes, thank you very much. And here are the two announcers. So that's the text message that is going to be sent to Discord. And this is the text that is going to be sent on Twitter. And more information, such as the secrets for signing. Remember, those are found on my secrets config file. And one more thing that I can do, just to be sure that nothing is really wonky, I can say JReleaser, full release, and I want you to run in dry run mode. I'm just going to give it a try. Is it going to work or not? So here we go. And it says, yeah, I calculate the checksums, I do the uploading, but actually it's fake. It did not create a release. Again, it's a dry run mode, so it will not affect any remote servers or operations. And then creates the Homebrew formula, and finally tweets something and sends a message. But actually, these messages are not there yet, and I can show you. If I switch to my Discord channel, there are no messages. How does JReleaser know that it will send a message to Discord channel? It uses the webhook integration. Because anyone that has access to that webhook URL will be able to send messages. I'll treat it as a secret. But if you want to, you can put it directly on the configuration file. OK, so now I'm going to do it for real. So the only thing that I have to do is run it without dry run. So it did not calculate the checksums again because it has it done already. And there are no changes in the input. So it has a little bit of a smart caching. Signs, uploads, creates the formula, and publishes two messages. So when I go back here on my Discord channel, now I have a message. I click on that URL, and there's the changelog that we saw earlier, and we have all the different assets. And of course, because we configure Homebrew, there should be a Homebrew formula, and it's right there. And it just looks very similar to what we saw earlier, based on those templates. But what about that tweet? Twitter, Almirai, And here we go. I did not post any URL, so it just looks like that. But this is live coming from JFile 2021. All right. So just like this, there are a few other things that the tool can do, specifically with the different services that you want to use. And of course, I show it with a project that publishes some sort of binaries. But if your project does not publish any binaries, and if you would like to have a Git release integration, you can certainly do so. If it's a library, or if it's just a set of POM files, you can make it happen. So here's a project, the Moditech project. Anyone has heard about the Moditech project? That allows you to keep Java 8 compatibility, but still have full module descriptors, so from Java 9 and onward? No? Anyone that is building modular applications and still wants to retain compatibility with Java 8, please have a look at this particular project. Makes things much easier. This is just a regular Maven project with a Maven plugin, nothing more. And if you click on this release tag, well, they also have their own categories. And the way that they build this release, or they publish the release, is using the Maven JReleaser plugin, which is found in the POM file. So of course, this will be XML, and we can search for JReleaser, and there is the JReleaser Maven plugin with some configuration. So instead of YAML, this is XML, and these are pretty much the same elements that we saw configured in the YAML format. A bit more verbose, maybe, but it does the trick. Here's another project that I can show you. This is a Quarkus application that creates native executables. It's a CLI tool that allows you to connect to Kafka Connect, kind of like kubectl, but for Kafka Connect. That's the idea. And because it creates native executables with GraalVM, we have to run it in the specific platform. So we use GitHub Actions to build the 3 different executables, and the same GitHub action to collect those binaries and then release them through JReleaser. So that's why, if you click here on releases, you see this early access tag with the current commit is that, and in the assets, we see those 3 different binaries. And this project, once again, is configured using the JReleaser plugin. There we go, latest version, by the way. And that's the list of assets that we're going to release. There are more things that I can show you about JReleaser, such as the documentation is currently hosted here. It contains everything that you need to know about the tool in order to get it started with what you want to use the CLI or Maven or Gradle, and here you go. If you want to know more about all the different options in detail, well, here are the list of all the different goals that you have access in Maven. All the names of the goals is not coincidence. They match the same workflows that I was showing before. And if you happen to switch to Gradle, same deal. And if you use the tool, same names. So it's very easy to move from one another. If you want to know how to configure something, let's say, for example, let's use another announcement, the latest one, Telegram. Well, this is what you have to do in order to configure it for YAML. You don't like YAML? Okay, switch to TOML, or JSON, or Maven, or Gradle. Every single bit of configuration that we expose in the site is done in the 5 different formats, so it's easy to move from one format or the other. And finally, there are some examples that you can find there. Here's an example for generating cross-platform JLinks, Java runtimes with JLink, a Quarkus application similar to KCCuddle, or a Spring Boot, or a Micronaut application, again, with GraalVM and JReleaser. And another question that comes in very often is, Andres, does JReleaser release itself? Because, hey, it's a CLI application, right? Well, yes, it does, since the first release. And so we built a snapshot, and then we bootstrap ourselves. So here's the full documentation for that particular project. It's a little bit more elaborate, because as you saw, we are able to have standalone versions or standalone launchers for the project. So I can show you here, if we navigate to JReleaser, the latest release, here's our release page. We follow a different convention for this project to do the changelog. And then, here are all the assets. And all these standalone custom Java runtimes were generated or assembled using JRelease. So the last bit that I want to showcase in terms of repositories is that you remember that JBank was one of the inspirations? Well, if you navigate to JBank, this is a repository of the project. You click here on the latest release. They use conventional commits, a feature that we added support for in the latest version. And this release has been posted using JRelease. So we've come back full circle. Max was able to delete most of the configuration that was explicitly done for JBank and reuse a tool that was born out of necessity inspired by JBank itself. So that's pretty much the demo. It didn't blow. Great. So what's going on in the future for the tool? We have a few ideas, but we depend on your feedback to let us know where this tool could go. For example, I did a poll a couple of weeks ago, and turns out that Bitbucket is still very popular among Java developers. So perhaps supporting Bitbucket. Right now, they don't have a release feature per se. You have to use a combination of other tools, but we can make it happen. Or maybe it's Azure DevOps, or maybe something else. We saw that we can publish to Amazon S3 buckets, but of course there are other cloud providers. If you would like to use other cloud providers, then we could perhaps also support those as well. And just like we did with JLink and GraalVM native image, that you can build it from the outside, or you can use JRelease, we can also looking at the option of building those native installers with JPackage, but within JRelease. Why? Because some of the metadata required for building those native installers is also already defined in the JRelease metadata. So there are a few resources for you. The homepage of the project that I'll show you, where we have all the documentation and everything you would like to know about JRelease. The documentation is searchable, by the way. The homepage of the project is hosted at that GitHub organization, where we have other repositories as well. If you happen to use the tool and you find it useful, and you would like to sponsor the project or contribute in a way, we have an open collective. And of course, we have a Twitter account when we post announcements or things to know about JRelease. Everything that we saw today is open source. If you have not contributed to open source before, let me tell you, it's very, very simple. If you find a problem with anything that we saw today or any other open source project library dependency that you consume in your daily work, file a ticket. That's it. There's nothing extra that you need to do. But if you've had the time and the passion, you can engage further with the team and set a patch, set a test case, or maybe even become a contributor. But you don't have to go all the way if you don't want to. Just by filing a ticket when something is not working properly, or if you find a missing feature or something extra about that project, is plenty of help for us open source developers. In that, I would like to say that in the month of October, we received plenty of updates coming from our community. And one of the things that we receive is a translation. So if I run JRelease passing a different flag for the language, for example, that would be user language equals Dutch. And I say JRelease, so it shows me the help. There we go. It's kind of Dutch. It was provided by a Flemish guy. But it looks good. I mean, from my eyes, it looks good. But of course, it will look a little bit better because that's my native tongue, Spanish. Or I can certainly regale you with something even more exotic. I guess Japanish didn't work. Why? That's weird. Hindi, it didn't work either. That's weird. Anyway, so we got a Dutch translation. And if it's not correct, we are accepting contributions. Okay, so that's everything that I have for you today. There's plenty more things that I can show, and I can talk by hours and hours about these things, but we have to wrap it up. And so thank you very much for your time. I hope that you find this tool useful. You can use it, again, in an open source fashion or in a closed source, or in a commercial fashion. We have received contributions from people making sure that the tool works correctly on GitHub Enterprise and GitHub Enterprise and a few other things. I have names of companies that are using the tool. I cannot disclose those names, but I can certainly tell you they are using the tool in a commercial fashion. So just use it, and if you find it, you find something that is not working properly, let me know. I'll fix it. And if you think it's cool, then just spread the word and keep using it. Thank you very much. I don't know if there are any questions in the audience. It's a bit hard to see you with those bright lights coming into my face. Yes, a question over there.
So you show that we can override the version, can be outside the file. Can we also do the same thing for other properties to have them outside the file?
Thank you for that question. And the question is, if because we can override the project version from the outside of the file, can we override other properties or other concerns? And the answer is a resounding yes. There are many other options that you can override using the environmental variables, not everything. To begin with, every secret can be provided using a configuration file, an extra configuration file like I showed, or environmental variables. But such as the project version, I can override the branch, the name of the release, the tag, if I want to override or update on a few other things. And everything that I can do in that manner is documented in the website. Yeah. Thank you for that question. Yes, the question is, if I use the Maven plugin, will that pick up the same metadata that is already defined, such as the project version, the name, URL, description, SCM, license, developers? And the answer is, of course, yes, it does. Because why would you repeat yourself? But it gives you the option that if you do not define it there, you can define it in the Maven, in the JReleaser model. And if you still define it in the POM file, in where it's supposed to be, and you want to override those values, you'd put them in the JReleaser configuration. Yeah. We look for places where we can reuse configuration that already exists. We are very big in convention over configuration. Don't repeat yourself. Only specify those things that you need to, or when you want to override something. Any other question? Well, you have been a fantastic audience. Thank you very much, and I keep enjoying JFrog.
Hè, no pressure. Ja, is goed joh. It is almost 5 p.m. Drinks are waiting for you outside, and you're sitting here waiting for a security talk. Thank you. Anyway, I want to bring you up, want to start with the phrase, and you probably have heard of it. Space, the final frontier. It was the opening phrase of one of my favorite, basically the fourth favorite series during my childhood. Star Trek, The Next Generation. And you say the fourth? What were the other three? Well, basically Mutant Ninja Turtles, the Power Rangers, and My Little Pony, of course. However, I am a Star Trek fan. And who of you likes Star Trek? Who of you is more of a Star Wars kind of? I'm still with you. I love that too. So don't worry. I'm not gonna do the old school bashing Star Trek versus Star Wars. But there is a thing with Star Trek that interests me so much because, you know, it can be true, right? I mean, if you look at Star Wars, it's a fictional thing. There's not even an Earth in it or something like that. But it's a great storyline. However, if you look at Star Trek, it could be at the end of the end of days that we have starships or kind of that. If you look at Star Trek and say the OG series, you saw a couple of things. For instance, did you know that they have this sliding doors, opening and sliding doors back? Look closely at one of the episodes and you will see that they're not really synchronous because at that time they didn't have that. There were people behind that and actually pulling and pushing the doors, which makes it interesting. Because if you would look at, for instance, the computers they were using in the original series of Star Trek, you know, the Star Trek with Spock, it's kind of this. To be honest, if this is the future, I'm sorry, but I don't want to be in it. I mean, if I give this to my little cousin, he would look at me like, dude, what is this? I've got a smartphone. Go away, old man. Anyway, there's one other thing that fascinates me about Star Trek, and that is this: teleporting. It would be amazing to be on the stage, like here, and instantly be back at home without driving for an hour or 2 hours or even more. I thought COVID would solve all of this, but now we're all back on the road. But let us take us into this technology. Of course, it's fictional. But what we're trying to do is we try to decompose an object, the human, send it over some stream to the other side of the world maybe, and compose the human back again. That is basically what we do in Java if we use serialization and deserialization. But can you imagine if something goes wrong with this, that your ear is not on the right spot, but on the top of your head or something like that? That would be funny for us, not for the person who actually has that. However, these problems can exist, or some weird things can exist if we do serialize and deserialize in Java. Well, you've seen me on stage today before. This is me. I'm Brian. I'm a developer advocate for Sneak. That means I do some Java programming and I email a lot. I'm a Java champion, do some stuff in the community. Oh, really? Yes, I do. That. However, that is not what we're going to talk about. We're going to talk about deserialization, not specifically only the Java deserialization, but also more ways of deserializing your data back and forward. Because you know how Java's custom deserialization and serialization framework is, what the nickname is of it? This sounds like early Christmas, but it's not a good thing. The gift that keeps on giving, because it is the source of a lot of potentially and actual harmful features, or, well, not so much features that went into the Java framework. Okay. Some basic knowledge to make sure that we're all at the same page. We have an object, we compile it into a stream, and we can store it either in a file or maybe send it over the line. That is basically what serialization is. You probably already guessed it. Deserialization is the other way around. So we have a file with that serialized data, we get the byte stream out of it, and we recompose the object. All right, so let's look at some code. This is my value object. And there are a few things that are important if we want to do serialization in general. First of all, we need to implement serializable. And that's for a reason. They tried to make it simple. And, well, successful, but also a simple way to manipulate the stuff. And what happens is, look at this constructor. In this constructor, we set the value, and that is one of the parameters. But the second field, the side effect, is actually set during construction. Okay, so let's go into serialization of this object. We have this object again, and we serialize it. Nothing's wrong with it, right? But what serialization does in general is we get the values of the field in the state that they are. And they are based on reflection. Okay, you would say. But the point is, if we look at a serialized object, say I have this object, this value object, and this value object says something like hi is the value. Well, if we look at it with a hex editor or something like that, it looks something like this. And you see at the end that it's two characters, the H and the I. Well, if I can read this, that means that I can easily do some sort of man-in-the-middle attack, grab that data or grab that object and change it into hello. And then you would say like, yeah, fair enough, point. We can make sure we can validate the stuff, right? Maybe. But one thing is, if you have that object and it's actually the right object that you want to deserialize, you're not sure if the object was actually the original object because, hey, we can just simply change it. That can already be a bad thing because we don't know what actually happens afterwards. But okay, that is still something we can cope with. But let's look into deserialization. So we have that same object again. And then we have this. This is what we call, well, this is basically how you deserialize an object in Java. Who of you ever used serialization and deserialization like this? A bunch of you, all right. So then you know, then the harmful thing is the third line in this red outline block. Because when you construct or basically reconstruct the object, it does not use the constructor. It uses the read object. So what does the read object do? Basically, the read object looks in that object input stream, creates an object, and at that point it's already in memory, and then casts it to the object that I want. So what if the object is not the object I want? I get a class cast exception. However, there are two things that are going wrong here. First of all, we are not using the constructor to recreate the object. So if I have validation in my constructor, it doesn't work. It uses reflection to reflectively put the fields in. Okay. The second thing is that that read object reads the object already before it casts. So if that object is something totally different, it can already set off a few things. And I will show you that in a second. Because now you know what serialization and deserialization is, and we do not use the constructor basically, but the read object. We need to look into gadgets. And this is my 5th series that I love the most. Who of you recognizes this reference? Thank you, I'm not feeling old anymore. Anyway, what is a gadget? Let's decompose that. I create a gadget over here. And a gadget basically is an object that if you create it, and it can either be via the constructor or something else, it not only sets the fields, but it also sets off a process. Look what I did over here. The constructor, nothing special. The field that I can implement in this gadget is a runnable, so I can actually run that process. But what I did, I overrode a private vinyl void read object, and that's basically the thing that we just use to deserialize stuff. I practically read the object and I run it. So even though it's not the object, even though it might be an object that I don't want, and I get a class cast exception, we can basically see that this already run. Because, again, if I do this, and you see in the third line, I still expect my value object, right? But it's already in memory. So that gadget contains some code, a runnable, and that runnable is already set up. And if you don't believe me, I will show you. So over here, this is my gadget, exactly the gadget that I showed you. It has a runnable, and I overrode the read object. So what I'm doing here in this example is I'm creating this gadget, and I'm serializing it to a file, gadget.ser. Then I'm going to deserialize that same file. And if we go here, what deserialization does is basically what I showed you before. And we expect actually a value object. Yes? Oh, let's run this one. What we see is if I run this one, and let's run the right one, it's the main. Oh demo gods, please be with me. What do we have here? Lambda static issue. This wasn't what I was supposed to do. That's not what I wanted. Oh, I get it. It gets the wrong one. This one I need. Example 2 without any parameters. Oh, thank God. So what are the odds? What do we have here? Let me enlarge this for you. You saw that the gadget contains that extra thing, that command that is, in this case, env, right? Over here, env. And that shows me the environment variables of my system. It has the class cast exception because it is actually not the object I'm supposed to be, but because it's already in my memory, and because it's actually already constructed into an object, because of the read value, it already sets off the process, and we have basically a side effect that runs that command. So even though if I accept serialized data in this case, and this data is based on a class that is on my class path that has a side effect like this, that side effect will run if the read object already, if the read object is overridden and the read object sets it off. And then you probably say, yeah, but how bad is that? Who overrides the read object, right? Well, let me get back to you on that in a second. The problem is not so much that single gadget. That single gadget here was just to explain to you what a gadget is. The problem is that if there is a gadget that has overridden the read object and might be able to instance another object and another object and another object, we can create a gadget chain. And then it's get interesting, because in the end of a gadget chain, we are looking for a sync gadget that actually exposes the arbitrary code execution, as we call it. So we need a starting point, and we need an endpoint. And if we connect that, then we have a gadget chain that can do arbitrary code execution. And then you probably say, but yeah, that chain is very hard to find. True, but think about this. How many libraries do you pull into your application? A lot. 80%, almost 90% of the code that you pull in your runnable jar, war, whatever it is not your code. So we can assume that there are so many classes available on the class path that there might be a possibility that such a gadget chain exists. Okay, but then still I need a starting gadget, right? Just avoid that. Well, that is nice, but just take a look at the implementation of HashMap. I can show you what HashMap does, but HashMap by default overrides the read object. So we already have our starting gadget. Nice, and it's there in the JDK. I love it. Okay, what is my next step of attacking this? Well, now I need to find a gadget chain, and that is very hard. Trust me, that is very hard. But we've got an app for that. We call it Why So Serial. Hence, well, if I have to explain a joke, it's not funny anymore. What does Why So Serial do? Why So Serial is an open source package, an open source project. And it is a proof of concept tool for generating payloads that exploit unsafe Java object deserialization exactly what I need. So if you look at what it can do, it can create these chains for you based on certain packages that you might have included. And it can be something like one package. This one is Commons Collection 3.1. But it can also be a combination of multiple packages, like over here. And this tool already creates such chain for you, and you basically can use it to execute a deserialization attack. Love that. Want to try it. What I'm going to do today, I'm going to use the Commons Collection 5. It's the fifth problem in Commons Collections using Commons Collection 3.1. That means I need to have Commons Collection 3.1 on my class path. It needs to be loaded into memory, or else it wouldn't be possible. But hey, if I download a Commons Collections library, I probably download it to use it. So I made a proof of concept of this. I'm using a lazy map just to make sure that I'm actually using Commons Collection map. And what I'm doing here is I'm just reading a payload.ser. Okay, but let's create that payload first. I'm using YSOSerial, the jar I compiled myself, with the Commons Collection 5 entering, and I'm saying touch hello.file. Let's make it a little bit cheesy. Hello.jfile.file, and output it in payload.ser. So if I do this, it's created. Fine, cool. Nothing there. We have a deserialized chain of objects created in a file. Now I will load this file, and I will deserialize it, and I expect again a value object, one of the objects I showed you before. Let's run this one, example 3. Okay, it runs. Cool. Well, what now? Well, let's check back into the terminal. And hey, now I created this file. So basically, by just importing this library, by using this library, you are already exposed to a deserialization chain, and I can do something in the background. That is interesting because that is just one library. But can you imagine what happens if you have a ton of libraries? Who is using Spring Boot? Do you have any clue how many jars Spring Boot includes to your application? One too many, basically. But seriously, it's a lot. So just to make an example of this, you see, if I import the wrong version of a library, we are available, or we are already vulnerable to such an attack, which is interesting because I don't see any output in it, but I see that the file is already created. But if I can create a file, I might also be able to create a script, run that script on the background, and may do harmful things to you. Interesting. So I bluntly copied this slide. This is the exact slide from Ian Haken. He is a security analyst from Netflix. And they did this research for gadget change. They created a tool to do that, an internal tool to do that. And I'm not pretty sure if the tool still exists or is still maintained. But the fact what they did is they provided it on their own services. And what they saw is that with a combination of this, in this case, of 6 libraries combined with a the JRE, we can create such a gadget chain. So the combination of a ThoughtWorks Extreme, something in Commons configuration, some closure stuff, some internal Netflix stuff, like all these bits and pieces all together could create such a gadget chain. And then it's just waiting until disaster happens. It's still very hard to find such a gadget chain, but if somebody found it, publishes it, and puts it in a tool like YSOSerial, ta-da! Oh, by the way, don't use YSOSerial to hack, use it for test purposes, right? Okay, so this is basically interesting, but what about records in Java 16, 17, whatever? I mean, if you are on Java 16, you should update to Java 17, period. But what about that? We have records now, right? This solves the whole problem. Well, yes and no. As a proper consultant, I would say it depends. I wrote a record here, a to value. And what I did specifically, I overwrote the constructor to have the side effect of a println. So what happens is that a record already helps you a bit. As in, deserialization of a record doesn't circumvent or doesn't go around the constructor, but actually uses the constructor to recreate that object. So say this is my application, or this is the piece of code that I want to do. Basically, I have a to value, having 1 and 2. I am serializing it to a to value.ser. I print out that it's serializing, and then I deserialize it, just in the regular way. This is basically the output. So it creates the to value, cool. It serializes, and by deserialization, you see that the constructor is actually used. So even if you overriding the read object thing is not a thing anymore, because with records, we use the actual constructor. That means if you have validation methods in there to see if your object is valid, it will actually get executed. That is already a big okay. However, we're still doing this. So that means that every other POJO in your application is still vulnerable to it. So does it make sense to have records? Yes, as long as you don't put in other objects that can contain a gadget chain, or put in libraries at all. So yes, it helps if everybody just does have records, but basically in the end, you're still vulnerable to the same thing. Even though people say records will be safer, yeah, record itself will be safer, but it doesn't help you in the bigger picture. So, it was boring, but what can we do? How should we solve this? First of all, try to avoid serialization in Java at all. But if you need to do serialization, for instance, you need to, say you have an abstract class that you need to implement or something, or you need to extend, and it's serializable. What you can do is you can override the read object. So if it gets written, or if it gets read into memory, it directly throws an exception. This way you prevent that something goes wrong. But say we actually depend on serialization in Java, and then I mean the custom serialization. One thing you can do is use the Apache Commons library. And Apache Commons library, what it does, it uses the validating object input stream. And the validating object input stream basically looks into the input stream and sees if what the actual object is that you're trying to deserialize, instead of deserializing this and casting it and waiting for a class cast exception. In this case, I can create an accept list or a decline list. In this way, I know that for this piece of code, only my value object class is cool. However, there are also ways in Java to do this, in plain Java without any libraries. And that's basically in JEP 2.19 and JEP 4.15. In JEP 2.19, which was already released in Java 9, if I'm not mistaken, the folks introduced the object input filter. And you can create a filter by using a string, like you see over here. And basically what I say over here, I only accept the value object for this specific stream and decline everything else. This is already helpful, but JEP 4.15, and that's the JEP that is released with Java 17, helps it a little bit more, because there is a problem with JEP 2.19. It's actually, it's useful, but it's not really useful. Let me get to this. You can set such a filter globally to your whole application. That's cool. But once you set a filter to a specific stream, which is also possible, like I do here, it basically overrides the global filter. That's not what we want. Also, if you are depending on libraries that do serialization for you, or use serialization, even though you set a global filter, you're not sure what happens, because maybe in that library, they set a filter specifically on a stream, and they might override it. So you're not sure what happens, and it's not really a feasible way to work. What you can do in Java 17 is use the new stuff that they created in JEP 4.15. So, what I do here, I'm creating a filter, and filters you can create filters in a very much easy way by creating such an allow filter in this way and giving it a lambda. And I can now say, hey, let's look at the package name, and if it equals something like this, I want to allow it or I want to disallow it. I set this filter here to the global configuration, and I can do this either in code or by setting a JVM parameter. But what I can do as well, I can set a serial filter factory. And it took me some time to read the JEP and understand what they mean. But in that factory, what I do is I give it a lambda or a function and telling it how to combine the existing filter with a new filter that is specific to that stream or to that context. So say I have a global filter and I have an extra filter somewhere to that, in that stream. I can decide with this factory, I can decide how we should work with that. And in this case, what I say is, hey, we have 2 filters and we merge it in the standard way. So that means that if I set a filter over here on my specific stream, I know that my global filter is still in place. A lot of stuff. But if you want to know more about this, I wrote a blog post about it with some examples that you can try it out yourself. And then probably a lot of people say, yeah, nice, Java serialization, Java deserialization, blah, 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 but I'm using JSON, right? Who's using JSON to serialize and deserialize data? Thank you, I appreciate that. So let's go into JSON deserialization with Jackson, because Jackson is the main library which is delivered to you by Spring Boot to deserialize and serialize your stuff. How many of you actually know how this works? That's a lot. Well, great, we just use it because Stack Overflow told me so. Anyhow, oh, that's not what I want to do. Oh, my theory is still there, cool. So what you can do in JSON is normally you have an object mapper, and with that object mapper, you can use that object mapper to read any JSON, right? But there's one thing, you can set default typing. Who of you heard of default typing? One. That's already one good answer. With default typing, luckily it's something that is not by default true, but with default typing, you can basically set automatic typing on. Let's call it that. Say I have an animal, and I'm not sure what that animal is, if it's a cat or a dog. Both the cat and the dog are animals, and if I'm deserializing, I'm not sure, and I want to be open for that. If I set it like this, it is allowed. It will deserialize and look for it, and it accepts the cat and the dog because they're both animals. Let's take that to the extreme. So we have this object mapper. We globally set that enable default typing is true, and we read that value. And this value, in this case, is person. But instead of a name, which normally should be a string, or an age, well, the age is actually a type. But the object of the name is an object now. So basically, I took this to the extreme, and I accept everything. If I just do this, and I deserialize the JSON, this will be perfectly fine. But this will be as well. This means because it's an object, everything is an object. And I can deserialize everything that is over there and put it in, and in this case, it's a gadget again, and it automatically executes for me. You can do default typing either globally, like I do here, or you see that JSON annotation, and I put, or you can see that JSON annotation that I put here, so you can do this by field. So over here, I have the same example, and I'm basically trying to deserialize my not evil.json, which is my normal JSON file, which I showed you, right? So by running this one, this will go perfectly fine. No worries, default typing doesn't actually involve me. It doesn't, I just have the things that I want. It basically says, hey, it's me, and I'm 37 years old. Cool. So let's move to that evil.json. And my evil.json uses the example for gadget. And the example for gadget is basically the same gadget I showed you before in the other thing. It runs a runnable when the constructor is there. If I call the constructor, it actually gets the command and it runs the command. These kind of classes exist. So if I run this one, you will now see that as a side effect, I've executed an ls-l. So, okay. You probably would say, yeah, but default typing is off by default, right? Yes, it is. But are you the only one who is using or reusing your JSON mappers? Or is your library as well? Secondly, how many of these problems are there in JSON? Well, I checked the database, and these are the problems for a subset of the problems from 2020 and 2021, and these are all deserialization issues with Jackson data binding. However, the folks at Jackson data binding do a really good job. First of all, they enable default typing, but they also actively, if they find another gadget that can be influenced by this, they blacklist it or blocklist it to be more woke. By blocking it specifically, they have to update a new version. So one of the things you should be doing is, if you're using either Spring Boot or your Jackson data binding that is there, like directly, please be aware that you update to the latest version, because these folks do a great job, but you don't want to be caught in the crossfire because there is an object. For instance, a year ago, there was a problem with an EH-cache object that could be used as a starting gadget to execute a gadget chain. And that is something that is well and commonly used in Spring Boot, for instance. One of the things you shouldn't be doing yourself is, for instance, do not enable default typing and update your libraries. But just using JSON and just using Jackson doesn't solve the problem. You have to be aware of what these things do. So let's go into two other examples. I have enough time. Let's go into YAML, everybody's favorite way of deserializing stuff, isn't it? Okay, let me put it. Who doesn't like YAML so much as I do? Well, I won't say I hate it, but I dislike YAML. Who dislikes YAML as well? So that means that 40% likes YAML. Who likes YAML? 5, 6, 7, so the rest is asleep. Okay, cool. These are not particular problems with gadget chains, but other things that can go wrong with deserialization stuff. Say YAML. If I want to serialize and deserialize YAML, I probably use one of the most common libraries called SnakeYAML. And again, that is provided to you in every Spring Boot distribution. So let's go to an actual application. Well, this one. Let me run this application. And I'm using a little bit an outdated version of SnakeYAML. Let's hope it runs. Cool. So it's an application I wrote for a workshop, and it has a bunch of users in it, and you search users, you can add users, and one of the things you can do, you can import an XML file, or in this case, also a YAML file to include new users. If a YAML file looks like this, and I will enlarge it in a second, this is the normal way of how it accepts the YAML file. This is pretty clear, right? I'm introducing a new user. oh, don't ever do the password like this, but hey, I work at a security company, this is perfectly safe. However, this is the okay way of doing this, and this works. But what if my YAML file looks like this? This is what we call a billion laughs attack. And what I'm doing here is one of the things that I can do in YAML, and basically this is also possible in XML, but all the XML parsers in Java already prevent this. But this is an actual problem that consists already for years in XML, but it's also possible in YAML. Because what we can do in YAML, we can create variables and we can create anchors. I'm not sure if anchor is the right word, but links to that variable. What I'm doing here is I'm creating LOL1 with a link LOL1. And it contains a list of strings with LOL, 10 to be precise. Then I create LOL2, which basically contains a list of lists that contains LOL. So 10 times 10. And I do this over and over and over and over and over again. And at LOLZ, I basically have a billion times LOL. That's why they call this a billion laughs attack. And what I'm doing here, instead of the first name, I'm calling LOLZ. What happens? All these objects will be loaded into memory. But how big is your memory? That depends. Hopefully you're not running on a cloud instance, because you pay for this. However, let me show you what happens. Let me choose the file. Let me go to the correct one first. Examples, laughs 2. So if I'm doing this and I'm submitting this, this will run for a while. And this is okay because I'm a single user. I'm the only user that we're working with this, and what can possibly go wrong? But it loads all the objects into memory, and at a certain point, my heap is just full. So it will basically go into a memory problem. That's still loading, and it keeps loading, and it keeps loading. But trust me, at a certain, here we have it. So can you imagine what happened if you work at Amazon or something like that on Black Friday, and there are a trillion, gazillion kind of requests per second, and the heap falls away of a few nodes? It's not what you want. Basically, this can end up in a denial of service. And the thing is, if you update to the right version, because this is 125, and from 126 what they did is they just look at the amount of recursive calls, and it can be just a certain number of it. So that means that your heap will not get filled up. I can update the version and show you, and then it will say like, hey, you do more than 50 traversions, and that's not allowed anymore. So we cut it off, you get an exception, but your application is still running. So by using the wrong version of a library, I can get a denial of service. Interesting. So, okay, we covered YAML. Let's cover one of our other favorite topics, XML. And I already told you that XML had this problem before, but actually all XML parsers already took care of this, but the folks that created SnakeYAML didn't until recently. Again, good job, because they did. What can happen with XML? Well, one of the things you can do if you deserialize XML, because that is what marshalling and unmarshalling is, serializing and deserializing. All XML parsers in Java are vulnerable to external entities attacks. Let me show you. If you're not aware what an external entity is, I will basically show you now. So, similar to uploading a YAML file, I can also upload an XML file. Am I in the right directory? Nope. Nope. Where is it? Here is it. Nice. All right. So a good XML file in this case would look like this. So again, basically the same arguments, 2 superheroes with a comment. Nothing special. But now I can do things like this. And this is getting interesting. You see what I do here? I have a doc type entity. And trust me if I say every parser in Java is vulnerable for this by default. You can circumvent it, or you can solve it, but by default, this is vulnerable to this. What I'm doing is I'm creating an external entity using a doc type, and I point it to a file on my system. And the reason that this normally can happen is you can include things like XSDs or whatever files to look into your XML and validate things. That's the original reason for it. But it also allows me to go into other files on the system if I know where they are. For instance, the passwd file. So if I know where the file is, okay. What I'm doing is I bind it to the variable xxe. And instead of putting out a comment here, I'm actually putting out xse. So that means that if I upload this XML, and I'm using the sax parser that is there available for you to grab in Java, and I will show you the code in a second. And I'm using the user bad XML I showed you. If I submit it, what I see is that the comments now contain the body of my passwd file. So outside of the box of my web server, because this is a Spring Boot application, I can access files on the system that might be open or not. Depends on what your user privileges are. But side question, do you know what the default privileges of a Docker containers are? Root, exactly. Check your Docker files if you run them with a specific user or not. Because if you put this in your Docker file and you might have other things in it, I can access them in this way. So you now disclose information that is not actually you want to disclose it to any other people. Simple thing, what you need to do is you just need to set a few... Oh, still there? It was black on my screen here. You simply need to set a few things. So if I go to my XML processor, and this is a very naive way of using the sax processor. It's still there, right? Yeah, cool. And what I can do, I can set, for instance, on the factory, and yes, I put a note here. I can set, for instance, set the feature that I want to disable, or I do not want to enable external entities. So if I do this over here, and I say to this factory, using this string like external general entities, are they allowed? Set them to false, and it doesn't work anymore. Funny thing is that I didn't know about this until I was researching XML for some reason. God knows why. But the point is, in very old or older applications, we're still using some form of XML, maybe even SOAP connections or something like that, and we parse it into objects. So if you allow XML files from the outside and you parse it to objects or something like that, I can do these kind of tricks. Unless you set the proper features. So you can disable this, but by default it is on. And that counts for the DOM parser, that counts for the SAX parser, and a lot of other parsers that are there out in the outside world. Okay, so I showed you a few problems why deserialization is something you have to be aware of and not just blindly do. Let me give a recap. First of all, do not deserialize input from unknown sources. And that sounds okay. Like, yeah, obvious, dude. But think about it. If you deserialize object that might be in a data store, are you the only one that can access that data store? If not, I'm not attacking your application, I'm attacking your data store. And in the end, it will traverse back to your application. That holds for any type of validation of the object. Basically, try to prevent just the Java's custom serialization as much as possible. If you don't need to use it, don't use it. A lot of things like the hash map override the read object value already, and that is because I think it is to make sure that it's still compatible with older versions. I'm not sure what the reason is, but that is probably the reason why. But I can already give you hash map is one of these entry gadgets for Java deserialization. But if you don't need to use it, if your application is not using it, don't use it yourself. Make sure that you use filters if you still need to use serialization for some reason. Also, it's good to set a filter if you are aware of what your libraries, what a library that you use is using. If you're using JSON, XML, or YAML marshalers, by default, they might have issues, like I showed you today. So be aware of how these things work. Don't just blindly use them. Read the documentation. I mean, that sounds probably weird, but it's all there. But also make sure that you update these insecure default values if they are there. And also make sure that you update to newer versions of it. Because I know we probably work at banks or at government agencies or at insurance companies, and they say, if it works, don't touch it. But if somebody found out that, for instance, the XML parser that you're using doesn't have the enable the external entities disabled, somebody might get in. So make sure that you update these insecure libraries and scan your applications for known vulnerabilities in libraries. For instance, if I would scan my application with, well, let's say the OWASP scanner or Sneak scanner, it will say to me, like, hey, you're using Commons Collection 3.1. We know that in that library itself, it already contains a gadget chain. If it scans the other application with the YAML problem, it says, hey, you're using 1.25 of Snake YAML, update to 1.26, and then you're done with it. So the steps are easy, but you need to take them. Not just trust Stack Overflow or any blog post. Be aware of what you use and try to prevent problems that you don't want to encounter. That is it for now. I think beers are cold. Thank you so much. Are there any questions? One. Yeah, you can go if you want to. I mean, I understand beers are far more important.
Would you have these files available so I could try them on my own application?
The question is if I have these files available so I can use them on my own system. All these files are part of my GitHub repos, but they're in different places. I will publish the slides. There's also the link to the blog post, and there I connect to the files where they are. So if you want to recreate the things I did, feel free to do so. Any other questions? You can wake up now if you want. One question over there. So the question was, I create a filter for a package name. If I create a class within that same package, yeah, that will depend if it's an allow or a decline filter. If it's a decline filter, so I decline it, it will decline every class in that package. So I just block the complete package. So if I create a new, say it's my own package, and I create a new class file in it, a new object in it, it will get declined. Because I'm not sure if I understand the question correctly, but let's get over here and discuss this one. And if anybody is interested, of course, join me. Last question. So it can, what you say is, if you have a global filter, and you override it somewhere, and you don't know what the global filter, but the global filter, hopefully your global filter, you said it, the problem, if you have a global filter and you override it somewhere else with the context specific, or with a specific filter for the stream, can it be a blessing in disguise? That's basically what that depends, because I hope that you are in control of your application, so that you are able to set that global filter yourself, either in code or as a JVM parameter. That is how you set the global filter. Normally, if you use JEP 290, that is, was available since Java 9, you overwrite that global filter when you do a stream-specific filter. But because you want to be able to control yourself what happens, that's why JEP 415 came in, so you can create that factory. That was the word. It's the most common word in Java. Factory that you can describe how to include that new filter that is context-specific or stream-specific together with your global filter. So I would say be aware that the global filter is something you set. That is set on, well, main level, global level, whatever, or as a JVM filter. So I'm not sure if that's actually a blessing in disguise or a problem, but there can be edge cases, of course, but if you want to discuss this, please come also for it, because it will probably be a longer discussion than just 2 sentences. Anyway, thank you so much for attending, and enjoy your drinks. Cheers.